Good morning, bhai. Good morning. Good morning. Good morning. Good morning. Good morning. Check once, everyone. Audio, video, every batch. Is it coming? I'm good. I'm chilling. I'm always chilling. Today, anyway, big festival is there. Second day of the big festival. Marathon Gold Festival. But today I'm extra chilling. Chaliye bhai. So yesterday it was lovely to see that everyone was reading chemistry. So whole campus was full of chemistry. So today also, if you do one more day like that, done, chemistry will be over. 118 chemistry will come. Then botany, geology and physics will be jealous. Make sure that you don't read anything else today, only chemistry. If you are feeling bored, read even more. If you feel you are not able to understand, read even more. If you feel you are understanding, then obviously read more. What to read? Chemistry. What to practice? Chemistry. What to eat? Chemistry. You eat chemistry only, chemical compounds. Anyway. But today realize what you are eating. Starch in rice. So if you put a little bit iodine on that rice, it will turn blue. Iodine starch complex is blue color. Chaliye bhaiya. So let's start. So today the topics we are going to cover, I think you already are aware of because yesterday VSP sir class happened. So you might be having the idea which topics we are going to start today. You should have the NCR, you should have the notebook for practice because physical chemistry is also there. So firstly, we are going to start with the easier part of today's lecture, that is the physical chemistry part. NEET physical chemistry is very straightforward. Formulas are there, application is there, no hi-fi thinking is required, bare minimum basic knowledge is there, practice done properly, mathematics is okay, practice you will be able to get decent marks in physical chemistry part. To be prepared within the NEET examination, out of 45, roughly 10 to 11 numericals are going to come. For that 10-11 numericals only we need mathematics and practice. So make sure whatever you are practicing right now in the class, same amount of questions you will practice in the study hour also. Chaliye, starting now. Number one. Before starting the solved example, what is a formula mass? Understand, for ionic compounds like NaCl, NaBr, NaI, ionic compounds, we cannot define a molecule because ionic compound will exist like this, like Na plus Cl minus, Na plus Cl minus, Na plus Cl minus. So one set of anion cation, one set, for example Na2SO4, so two sodium ion and one sulfate ion is one set. So a neutral set of cation anion, that mass is called the formula mass. So for example, NaCl, when we find the mass, we find the formula mass for sodium 23 and chlorine 35.5. So 58.5 AMU or 58.5 gram per mole. This is the molar mass. So for ionic compound, we find the formula mass. For remaining people, atomic mass, molecular mass, all those things are there. Then, starting the example number 1.1, calculate the molecular mass of glucose molecule. So glucose is C6H12O6. And we know that its molecular mass is going to come 180 AMU, that is 12 into 6, carbon into 6. Hydrogen mass is 1, but there are 12 hydrogen. Oxygen 16 into 6. Total 180 will come. Now 180 AMU, if they are asking, that is one answer. Clear, right? AMU or U, unified mass. That is one answer. Other answer can be converting this into gram, that is actual weight. Weight of the molecule of glucose, but in grams. So you will not just cut AMU and write grams, it will be wrong. Understand, 180 AMU will be converted into gram. How? When we go from AMU into gram, 1.66 into 10 to the power minus 24 gram has to be multiplied, or 1 by 6 into 23 gram will be multiplied. 1 by 6 into 10 to the power 23, when you will multiply, you will get here 3030 into 10 to the power minus 23 gram. Clear, bhaiya? So this is the mass in AMU and this is the same mass in gram. This conversion is very important, bhaiya. Next. A compound contains 4% roughly hydrogen, 24% carbon, 71.65% chlorine. Its molar mass is 98.96. What are the empirical and the molecular formulas? So here carbon is 24% by mass. So I'm taking 24 gram roughly. Hydrogen 4 and chlorine 71.65, roughly 71, 71.5, whatever. Now, first thing is convert into moles. Whatever they give you mass, convert into moles by dividing with molar mass. They give you number, convert into moles. They give you volume of the gas at STP, convert into moles first for finding the empirical or molecular formula. So I'm dividing this with 12, given mass by molar mass, dividing this with the molar mass, dividing this with the molar mass. So how much will come? C2H4Cl2 roughly. But this is not the empirical formula. Empirical formula is the simplest formula. Simplest formula means this can further be divided by 2. So CH2Cl. This is my empirical formula. So from here empirical formula mass will also come. Empirical formula mass means mass of this formula. So 12 plus 2, 14. 14 plus 35.5. So 14 plus 35.5 will be 49.5 roughly. Empirical formula mass. Now I can find the factor molecular mass by empirical formula mass. So molecular mass in the question is 98.96. So 98 point something by empirical formula mass 49.5 roughly. This will go 2 times. So what we understand? We understand that whatever is the molecular formula, it is the empirical formula into 2. Empirical formula is CH2Cl. So molecular formula will be C2H4Cl2 double. Check this question once, bhai. So firstly, I divided the molar mass with, given mass with molar mass. I found the moles, found the simplest ratio. Over. Find the empirical formula mass, 49.5 will come. Molar mass by empirical formula mass will give you a factor. Multiply that with the empirical formula. You will get your desired molecular formula. Twarga, going to the next question. Next. Calculate the amount of water produced by combustion of 16 gram of methane. So here we are taking methane combustion reaction. So methane plus O2 gives you CO2 plus water. Combustion will always give you, understand one important thing here, one important point. Combustion, carbon give you CO2 and hydrogen give you water. This much is a general knowledge now. If you are attending the marathon class by this time, that means main track done, revision done. So this much people generally know. But understand, nitrogen will remain N2. It will not become any oxide. So in combustion, if you get any amine combustion, aniline combustion, so understand there the nitrogen will not become NO2 or NO or N2, that remains N2, nitrogen gas. Very important point. Moving on, balancing, 2 plus 2, 4 oxygen atom, so there should be 2 O2. Solving the question now, 16 gram methane, 16 gram methane means 1 mole. Now moles of methane by 1, what they are asking? Amount of water produced is moles of water by 2. So moles of methane by stoichiometry will be equal to moles of water by stoichiometry. Which moles are these? Reacted moles of methane, and these are the produced moles of water. So methane reacted moles are 1 mole. So moles of water produced will be 2 moles. You can directly also do 1 react 2 produced, 1 mole react 2 mole produced. So weight of water produced will be 2 into 18, 36 gram. Bolo tararara. So obviously problem number 1.4 you can be easily solving because 22 grams CO2 given, that is half mole, and they are asking methane how much required. So 1 CO2 1 methane, half mole CO2 half mole methane, and half mole methane means half into 16, 8 gram. Time pass question. Next, 50 kg of nitrogen, 10 kg of hydrogen are mixed to produce ammonia. This question becomes the limiting reagent question, bhai. So how much we have taken? 50 kg of nitrogen and 10 kg of hydrogen. So first thing, never solve the question in the form of mass. Convert mass into moles first. How, sir? Divide with the molar mass. So 50 kg is 50,000 grams. So 50,000 by molar mass of nitrogen atom is 14 gram and N2 molecule is 28 grams. So these many moles are going to come by. Similarly here as well, 10,000 by molar mass of H2 gas will be 2 gram per mole. So these many moles are going to come. So this will be 5,000 moles. This if you take roughly 30, 28 I am taking roughly 30. So 5,000 by 3 will come. So 5,000 by 3 and this is 5,000. So obviously 5,000 is more and 5,000 by 3 will be lesser. Or you can take 5,000 by 2.8. So this is going to be lesser amount, but we cannot decide limiting reagent like that. We have to divide the given amount with the stoichiometry, divide the given amount, given moles with the stoichiometry, and then we have to compare. So I'm dividing. Firstly, I found the given moles. Given moles by stoichiometry I am doing now. So this was the mass given to me. I divided with the molar mass. I got the given moles by stoichiometry, given moles by stoichiometry. See how I am approaching math. I'm not dividing this like an idiot in the first step. I have to just compare. And when I'm going to compare, it is very important to understand that 2.8 and 3 I can easily compare here. So 5,000 by 3, 5,000 divided by a larger number and 5,000 divided by a smaller number. So divided by a smaller number means this value will come more. So this bhai sahab became my ER, this became my LR, and my LR will be my hero. Limiting reagent. So now what they are asking, ammonia produced. So moles of hydrogen by 3 is moles of ammonia by 2. Now these moles are reacted moles. For limiting reagent, complete moles will get consumed if the efficiency is 100%. And here no efficiency mentioned, so I will take 100% only. So how many moles are there? So it is 5,000 moles. 10,000 by 2, 5,000 moles. So 5,000 by 3 is moles of ammonia by 2. Here people do a mistake. Sometimes they put 5,000 by 3 by 3. Don't do that stupidity, bhai. So moles of ammonia came 10,000 by 3 moles. Clear, bhaiya? Check. So method is clear. Number 1, find limiting reagent. Find moles. Moles tarvata LR, and using LR you can find the amount of product produced, amount of reactant reacted. Simple fundamental idea, bhai. Next, a solution is prepared by adding 2 gram of a substance to 18 gram of water. Calculate the mass percent of the solute. So we know that percentage weight by weight is the weight of solute by weight of solution into 100 by. So solute is 2 gram, solution is not 18 gram, solution will be 2 plus 18. Silly mistake le do auntie. Clear bhaiya? So low beautiful 10%. देखो भैया, pause. These questions are easy, but these are important. Total number of questions of solved examples and in text from NCERT in chemistry are more than 250. Now, more than 350. So, if they have to create a paper from NCERT, they have enough number of solved examples in the in-text questions here. Even we are not able to concise all those solved examples and in-text questions in one single mega paper. So, firstly, in the mega paper, our objective is simple. It's a clear-cut case of paper leak. Mega paper will include all the questions of solved examples and in-text. In other words, All the solved example in text will not be covered in the mega paper, but whatever will be there in the mega paper tomorrow will be solved example and in text questions. Clear fundamental idea. Our objective for these 3 days is solved example in text question should be properly done. And if you are good in the subject, be extra careful. Because after this class, many moderate level students will be getting very good marks tomorrow because they are attending the class seriously. They are underconfident. But some people who are overconfident and they are not doing it well and they are doing other things, extra things, and those extras are not important, they might get lesser marks tomorrow. So make sure right now our objective, Gosalite objective is first, we have done main track teaching completely, revision ho gaya, done. Very well, fabulously done for some of you. But that first cream layer, be extra careful whether you're attending the class or not. This voice in speaker will be coming to your ears. Listen very carefully. Bhai, every single goddamn solved example in text question, good questions of NCERT exercise should be properly done by you. Because only 45 questions will come in chemistry in NEET examination. And NCERT, only solved example in text questions are more than 350. Understand? An exercise question included. Today I will give some of the homework there also. Understand, exercise question included. More than 500 questions are there which are relevant for NEET examination without changing data they can give. Like for this, why the hell they have to change the data? So prepare, understand, know the exam better than the subject. This exam is NCERT based and NCERT have ready-made questions. A paper setter will not put extra effort for making a question when there is a good question ready-made here. Keep that in mind, everyone. Every category of person in this class today or self-study today should be able to benefit from this program. Use it wisely. Calculate the molarity of NaOH. Molarity of NaOH in the solution prepared by dissolving 4 gram of it in enough water to form 250 ml solution. So volume of solution given 250 ml. Weight of NaOH given 4 gram. I know that molarity is moles of solute by volume of solution in liter. So 4 by 40 given mass by molar mass of NaOH. You can find the molar mass of NaOH. It will come 40. 4 by 40 volume of solution 250 ml into 1000. So this will go 4 times. This will go 4 by 10, 0.4 molar. Very important line. Note that molarity of a solution depend upon temperature because volume of solution is temperature dependent. Can be a reasoning question. You know this very well. I'm just telling. Again, see, boring thing is the thing which will give you marks. I know everyone know. I know you might feel, sir, this must be no, sir, but extra. Extra, why you need extra? We are duffer, we are teaching from main track and revision. And then also something extra will be left. Nothing is extra. Same thing we have to do again. Name you should forget. This you should not forget. Clear, bhai? Objective is clear. Vigorous preparation. Everything coming in the examination, 45 out of 45 questions should be done by us before they have come in the NEET examination several times, not one time. Bruce Lee said, I don't know Bruce Lee said or someone said, but when I use the name Bruce Lee or Mike Tyson, power comes in the sentence. Bruce Lee said, I'm not afraid of that one question. I'm not afraid of that 10,000 questions that you have done one time. I'm afraid of that one question that you have done 10,000 times. Clear, bhai? That question comes in the examination. You will know every single step. Silly mistake. 0. Next. Last question. The density of 3 molar solution of NaCl is 1.25 gram per ml. Calculate the molality of the solution. So they are giving me 3 molar molarity. Density is 1.25 gram per ml. And they are asking me molality of the solution. It's a clear question of interconversion. Very important. Now 3 molar. So molarity is 3 moles of solute. Who is the solute? NaCl. By volume of solution in liter. So from here extract the data. How to extract? Compare the numerator with the numerator. So moles of NaCl came 3 moles. Compare the denominator with denominator. Volume of solution came 1 liter. Now for molality, Molality is moles of solute. Molality is moles of solute by weight of solvent in kg. So moles of solute undi 3 mole. Weight of solvent not there. So weight of solvent is going to be weight of solution minus weight of solute. Weight of solution not there, but volume of solution is there. And I know that density is mass by volume. So weight of solution will be density into volume of solution. So density into volume of solution. Density how much? 1.25 gram per ml. Volume how much? 1000 ml. Units are important here. Gram per ml, so volume also 1000 ml. Chinna mistake should be avoided, bhaiya. Weight of solute. Weight of solute 3 into 58.5 gram. Why, sir? By 3 mole NaCl solute into molar mass. So how much will come? 1250 gram minus 58.5 into 3. So roughly 180, little below that 180 will come. Sorry, correct. Clear, bhaiya? Hello. So how much? 5 3 15, carry 1. 8 3 24, 25, carry 2. 5 3 15, 16 17. Say bhaiya, any problem, samasya, pida? Check. Done? How much? So this will come 250 minus 175. So 1025, something like that. Clear, bhai? 1075, something like that. Understood the idea, bhai? Now understand, in NCERT, if you are just blindly following the solution, you will see this chinna mistake. Because this is what some people do, especially underconfident people, even overconfident only. They don't check the question and the answer. They check solution in the middle. And then they find 75.5 coming. It's a printing mistake. It is 175.5. But when you will subtract it, you will realize that 1250 minus 75.5 is not coming 1074.5. And I have met some low IQ idiots who have this doubt in the main track time, कि sir, this subtraction not coming. Abey, auntie, above that, the topic which was there, the question which was there, you did not understand also, kya? How you got 75.5? Chalo, NCERT printing mistake done. But how can you do the printing mistake, bhaiya? Which thing you are printing? Anyway, so weight of solvent came 1.075 kg. I can put it here. So it will come 3 mole by 1.075. This will be the molarity. 0745, because I've taken 175, so it will come 1075. 175.5 I will take, so 1074.5 will come. Anyway, the point is how to understand, how to solve this question. From molarity, I got moles of solute and volume of solution respectively. For this mole, how much volume is there? Then I found the weight of solvent by solution minus solute. Solution was density into volume and solute was moles into molar mass. If you want to create a low IQ formula, which some people love to create, I don't know why the IQ level of the student have to be decreased so much. But anyway, if you feel like, nice sir, without formula I will not do anything. Molality is molarity upon density of solution into volume minus molarity into molar mass into 1000. Decrease the IQ of the whole, average IQ of the universe have decreased by 1 point after mugging up one formula. But if you understand the method, you are able to solve every single question. Done by this statement also you should know. Often in chemistry laboratory, a solution of a desired concentration is prepared by diluting a solution of known higher concentration. The solution of higher concentration is also known as Stokes solution. You will find this in your notes as well. Stokes solution numerical. Note that molality of a solution does not change with temperature since mass remain unaffected with temperature. I think you know this. Molality, percent weight by weight, mole fraction, they are independent of temperature. Molarity, normality, percent weight by volume, percent volume by volume, wherever volume comes, that is dependent upon temperature. Chaliye bhaiya, let's increase the IQ of the universe by 1 more point now. Let's bring it back to the original formula we have written. Next, This match the column 1.15. You circle in your NCERT, practice that in the study hour. Very important, match the column. Simple but chala mugging required, especially if your rank is going to come, if you want, in the top 1000 of the all India. These are the things which you will ignore, and these are the things you have to do. Clear, bhai? That's why I'm saying it's very important for toppers also to completely do NCERT properly, bhaiya. Chinna things are there. To make sure this match the column question you should be able to see properly in the study hour. Then one more question I circled here. This one I circled. Circle not coming. Chalo, anyway. Which of the following will have the largest number of atoms? Just divide, these are mass. This is MCQ. MCQ in the NCERT exercise are very important. Direct questions are there, so paper setter will pick them directly. It's a NEET previous year question also. 2021 or 20 this came. Which of the following will have the largest number of atoms? Simple. Given mass by molar mass, given mass by molar mass, given mass by molar mass, given mass by molar mass into 2. Sir, why into 2? Because when you do given mass by molar mass of Cl2, then moles of Cl2 will come. Multiply with 2. Otherwise, take the molar mass of Cl, 1 by 35.5, then also directly answer will come. But anyway, you will find the moles and then compare which has maximum number of atom. More moles of atom, that is more number of atom. Clear, bhai? Practice this question also. 1.32 is the average molar mass question. If you remember the formula for the average molar mass, so average molar mass, because there are 3 different isotopes, M1 N1 plus N2 N2 plus M3 N3 by N1 plus N2 plus N3. Achha, in these kind of questions, little bit brain also use here. 1.32 for example. Here if they give you these 3 isotopic form around 36, 38 and 40. I'm rounding off. 36, 38, 40. Abundance is 0.337, 0.063 and 99.6%. Average they are asking. And the options are 36.5, 37.2, 38.2, 39, 39.95. Then understand, if 99.6% is 39.96, then the final average molar mass will be very, very close to majority stakeholder. So majority is 99.6 and it's not 70% majority, 30% minority. It is 99.6% is only argon, 39.9, around 40. And only 0.4% are remaining. So remaining contributions are almost negligible. So roughly the answer will be closest to 39.96. So 39.95 I will pick up. Sir, can I pick up 40? Crack hai kya? 35.96 minimum, 39.96 maximum. So the average will be between that only, na? In your revision, highest came 650, lowest came 600. Kya average becomes 720? So average cannot be lower than 35.96 and higher than 39.96 here. Common sense, but because it is common sense, it has to be told. Because only name is common sense. But this is actually sense, and sense though you have too much. Anyway, moving on. Now here, in Rutherford model, some reasoning questions are also there which can come in the examination. Which kind of reasoning questions? That most of the alpha particles passed straight through the gold foil. It is going to tell you that most of the space in the atom will be empty. Assertion, reason. Assertion, most of the alpha particles pass straight. Reason, most of the space in the atoms are empty. Or experiment, observation and inference. Now assertion, reason you all know because you have practiced that. Also there is another type of model which used to come previously in JEE advanced examinations, and at that time JEE advanced was not there. At that time also it used to be IIT mains and IIT advanced. At that time some questions came. Now also these kind of questions are very common in CAT. Clear, bhai? For MBA, for IIMs. So in that questions it comes as observation and inference. Observation means when experiment is conducted, what you observed. Inference means what is the conclusion of that. So observation, Most of the alpha particles passed straight through the gold foil undeflected. That was observation. What is inference? Inference means what is your deduction, what you have understood from this experimental result. So our observation was 99% particle passed straight, but our inference will be most of the space in the atom is empty. Clear bhaiya? So keep that in mind bhai. Next, observation inference question. Word meaning is very important. Observation means experimental result. Inference means what is your conclusion as a scientist? What is your conclusion from that observation? Calculate the number of proton, neutron, electron in 85 Br 35. So देखो भैया 80 Br 35. This is atomic number of proton. This is mass number, neutron plus proton. Neutron will be A minus Z. So 80 minus 35. Simple. Number of electron, proton, neutron in a species are equal to 18, 16, 16. So number of electron are 18. Oh bhaiya, hello. Hello. Hello, hello, hello. Is anybody in there? Proton 16, neutron, electron 18. Electrons are 2 extra. So 2 extra means, firstly, proton is a roll number. It is a roll number of atom. Roll number is unique. So which atom has 16 proton? Whose atomic number is 16? So uncle ji, sulfur. And it contains 18 electron only, but 16 proton, even less proton. So 2 extra electron means 2 minus charge. And mass number 16 plus 16, 32. So that's the symbol bhai. So number of electrons are Z minus charge. Number of protons is Z, and number of neutrons will be mass number minus atomic number. Any element, ikkada atomic number, kinda paina mass number. This is the symbol of writing any element. Done. Done, 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 done. Moving on, moving on, moving on. Next, Vivid Bharati radio station. This question directly with the same data came in 2019 NEET examination. Same data without changing anything. Options were very close. Options were 219.3, 219.2, not 19, 2021. And I remember one of our toppers did this question wrong. That was the first batch of Gosalites. Then 219.3. How it came? So we know that C equal to nu lambda. Question is very simple, straightforward. They are asking you 1368 kilohertz. So frequency is 1368 into 10 to the power 3 hertz. Lambda they are asking, and speed of light I can take 3 into the power 8 meter per second. But the main point is dividing. So this will come 3 into 10 to the power 8 by 1368 into 10 to the power 3. That is going to be your lambda. Done bhaiya. Make sure that you divide and check properly. Answer will be coming 219.29, which is 219.3 round off. This is how the answer actually came in the exam. After dividing, make sure that you check it. Next, the wavelength range of the visible spectrum is 400 nanometer to 750 nanometer. Same formula. C equal to nu lambda. Find the frequency now by giving lambda. Make sure to remember that nanometer is 10 to the power minus 9 meter. Picometer is 10 power minus 12 meter. Angstrom is 10 power minus 10 meter. You should be knowing this. Done by. Next. Wave number question. Calculate the wave number and frequency of yellow radiation having wavelength of this much. So we know that wave number is 1 by wavelength. So directly put the value 1 by 5800. Angstrom means 10 power minus 10 meter. So this is your wave number. Frequency you can easily find by C equal to nu lambda. You can apply. Frequency will come. Lambda will be 5800 10 power minus 10 meter. C will be 3-8 meter per second. Direct lollipop questions. But important questions. Easy question are important, bhai. This is the main game. People don't understand this simple fundamental idea कि easy questions are important. Clear, bhai? It's like cricket match. If a very good Yorker is given, you cannot hit it as a 6 if you have a perfect Yorker. even though you are MS Dhoni of his prime. You have to wait for bad deliveries and hit them outside the stadium. So waiting for good deliveries is the main game. Now calculate the energy of 1 mole of photon of radiation, this frequency this much. So energy of the photon will be number of photons into h nu or number of photons into hc by lambda. Now energy of 1 mole photon, so number of photons are 6 into 10 to the power 23, that is 1 mole, 6.022 10 to the power 23. Planck's constant 6.626 into 10 power minus 34 joule second, and frequency is 5 into 10 power 14. This is the energy of 1 mole of photons. Next, 100 watt of bulb emits monochromatic. Monochromatic means single color. Light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. So you have the power 100 watt. 100 watt means 100 joule per second. Done by. Now they are asking per second only. So in 1 second, how much is the energy? So sir, per second energy is 100 joule, total energy. And we know that total energy is number of photon into hc by lambda, number of photons into hc by lambda. Total energy 100 joule, number of photons I have to find in 1 second, that is 100 joule energy is there. 6.626 10 power minus 34 into 3 10 power 8 by lambda, 400 into 10 to the power minus 9, because nanometer. Simple calculation will be there. 6.63 into 3 around 20, 20 by 4 around 5. So bhaiya n into 5 into 10 to the power minus 34. This will become minus 7 because I'm ignoring zeros. Minus 7 will go up, 8 plus 7 15, minus 34 plus 15. So the question is going to be very easy calculation wise. If you can just understand that 6.626 into 3 is roughly 20. Clear hai bhai? So 5 into 10 power minus 19 will go in the denominator, you will get the number of photons. Clear bhai? 4.969 means 5 into 10 power minus 19 in the denominator. So main game is to remember E is equals to, see NCERT solved example is telling you that this formula is very important. That's what you have to learn. Maybe direct question will come. Additionally, this formula is very important. Moving on. When electromagnetic radiation of wavelength 300 nanometers, very important question and very good question also. Important as well as little moderate to tough. Then, when electromagnetic radiations of wavelength 300 nanometer fall on the surface of sodium, electrons are emitted with a kinetic energy of this much joule per mole. Now, understand, one photon ejects one electron. But they have given me the kinetic energy 1.68 10 to the power 5 joule per mole. They have given me for 1 mole. They have not given me the kinetic energy of 1 photon. They gave me 1 electron kinetic energy not given. They have given me kinetic energy of a mole of electrons. So 1 mole of photons ka wali. 1 electron 1 photon ka wali. So for 2 electron 2 photon ka wali. So for 1 mole electrons 1 mole photons are required. Now, what is the maximum wavelength that can cause a photoelectron to be emitted? Threshold wavelength they are asking. And minimum energy needed to remove the electron from sodium. So by it's a photoelectric effect question. And they are asking me this W naught. And let's see, they are asking W naught in the terms of joule per mole or no. They are asking for 1 electron. They are asking in the terms of only joule, not joule per mole. So what to do? Our first job is to convert this kilojoule, this joule per mole into per electron. How? Dekho. One conversion is there that I have written here. Electron volt per species. Multiply with, this is wrong. It's not kilojoule, it is joule. I'll write here. Electron volt per species will be converted to joule per mole by multiplying with 96500. So right now I have joule per mole and I can find electron volt per electron. How? by dividing with 96500. This is very important. I converted joule into electron volt, first thing I have done. And second thing, I converted per mole into per electron. Now the question will easily come by. Now I will put the value. Energy of the photon, if you remember the shortcut, 12400 electron volt angstrom by 3000 angstrom. 300 nanometer means 3000 angstrom. So I got the energy E minus W naught. Now W naught I cannot put in joule per mole. So I converted into electron volt to 168,000 by 96500. This much electron volt. Sorry, this is W naught is equals to 168,000 by 96500. This much electron volt. Understood the story, bhai? So 3 4s are 12, 3 1s are 3. So 4.13 minus 0.000 cancel, 1680 by 965 will be equal to W naught. This is the answer in electron volt. And if you want to convert electron volt into joule, you'll just multiply with 1.6 into 10 power minus 19. Check by everyone. Question is not very direct because you are habitual of solving the question in same units, electron volt per species generally. Also in physics. But in this question, they have given the kinetic energy in joule per mole. So you have to convert that into per electron. Understand, one photon eject only one electron. So if the energy of the photon you are putting here, it should be hc by lambda for one electron. One photon. hc by lambda is for one photon. Here the work function will come for one electron, and here you will also put the kinetic energy of one electron. Or you can put everyone joule per mole, joule per mole, joule per mole. You can put here 168,000 joule per mole. You can put W naught, you will get in joule per mole. This you can put hc by lambda into n, like you found here, na? Like you found here. For 1 mole, how much is the energy? This was the energy in joule per mole. You can find like this, multiply with this number hc by lambda. But the point is, if everyone is in joule per mole or everyone is in electron volt per electron, then only the answer will match. And this is a question that even our top ranking students should be properly seeing, bhai. Avoid silly mistakes. Threshold frequency of a metal is this much, calculate the kinetic energy. This question is direct, easy question. I don't think problem will come. Threshold frequency, they have given nu naught. You will get E minus or h nu minus h nu naught equal to K. Calculate the kinetic energy they are asking. Frequency they have given you this much. So H common. Nu minus nu naught equal to K. Put nu 1 10 power 15. Put nu naught 7 10 power 14. Put H 6.626 10 power minus 34. Kinetic energy will come. Moving on. Chaliye. NCERT exercise, some questions I'll give as the homework for this question also, this chapter also. So be very careful. Don't miss that. What is the frequency and wavelength of photon emitted during a transition for n equal to 5 to n equal to 2 in the hydrogen atom? So dekho bhai, when we are having a transition from 5 to 2, so 1 by lambda is rz square, 1 upon n1 square minus 1 upon n2 square you can put here. So 1 by lambda is r 1.1 10 to the power 7 meter inverse into hydrogen z1 1 by which is the smaller number minus larger number square. This is how you will find lambda. You want energy? Energy of the photon will be hc by lambda. So basically this into hc. Check bhai, straightforward question. Calculate the energy associated with the first orbit of He plus. What is the radius of this orbit? So देखो भाई, energy of helium plus first orbit will be energy of hydrogen first orbit into z square. So minus 13.6 electron volt per atom into z square, that is 2 square, that is 4, to minus 54.4 electron volt. You can convert into joules also if required. Sir, how to convert into joules? Already I told you, electron volt per electron into 1.6 10 power minus 19 you will multiply. Fundamental charge you will multiply. Electron volt will become joule. They are asking the radius. So radius is 0.529 n square by z angstrom or 52.9 n square by z picometer. So putting the value, first orbit of helium. Check भैया. तो 0.059 by 2, तो 0.026. Make sure that you remember the formulas. Radius, velocity, energy. 2.18, 10 to the power 6, z by n, meter per second. Because radius done, energy done, then why not velocity also? Check the formula once. Moving on. What will be the wavelength of a ball of mass 0.1 kg moving with a velocity of 10 meter per second? Now, this is an object moving with a velocity. His wavelength they are asking. It is de Broglie-Chacha. So de Broglie-Chacha told you that lambda is equals to h by mb. So h will be 6.63 10 to the power minus 34. Mass of the ball is 0.1 kg SI. Velocity 10 meter per second. Lo bhaiya, lollipop question over. Chewing gum question coming. The mass of electron is given to you, kinetic energy given, calculate the wavelength. So the other formula is h by root 2 mk, where k is the kinetic energy. Clear by? Root 150 by voltage angstrom for electron. These are the formulas by. Focusing upon this formula, because they are talking about kinetic energy. Lambda is equal to h by root 2 mk. So root 2 m 9 10 to the power minus 31. K 3 10 to the power minus 25. Put the value. Don't use this method. This is the derivation of this formula. So don't use this NCERT solution. Use this formula. Correct answer will come. Enjoy your life. Calculate the mass of a photon of wavelength 3.6 angstrom. So mass they are asking of a photon. Lambda they are giving you. So I know that mass will be h by lambda v will come. I just exchange them. So h will be 6.626 10 to the power minus 34. Lambda is 3.6 angstrom. Converting into meter 10 to the power minus 10. But velocity of a photon, so we know na, in vacuum. So in vacuum it is 3 into 10 to the power 8 meter per second. Not very good question conceptually. But if NCERT have asked, so bhaiya, we will answer. Whatever we can understand, we will answer by that. But this formula is generally not applicable for photons. You might have read this in physics. You can apply de Broglie everywhere except light. But here they are applying on photon. So who are we? We are no one. NCERT, NTA. They will decide everything, bhai sab. Clear, bhai? In this world, whose name start with N, they decide everything. NTA, NCERT, NEET, Narendra Modi garu, Naidu garu, and our own Narendra garu. Are clear hai yaar? Are understood yaar? Never underestimate a power of a common N. Chaliye, moving on. Arey, oye. Moving on. Clear hai bhai? Newton. Chaliye, going on. A microscope using suitable photon is employed to locate an electron in an atom with a distance of 0.1 angstrom. So this within a distance of 0.1 angstrom means the error in the position is 0.1 angstrom. What is the uncertainty involved in the measurement of its velocity? So delta p into delta x is more than equal to h by 4 pi. H by 4 pi, remember the value 0.527 10 to the power minus 34. Quickly answer will come. So bhaiya, delta v they are asking. Uncertainty in the measurement of velocity will be 0.527 10 to the power minus 34 by delta x into m. Mass of electron, yes, 9.1 10 to the power minus 31 kg. That's how you can find the uncertainty, error in the measurement of velocity. A golf ball has a mass of 40 gram and a speed of 45 meter per second. Now understand, velocity is 45 meter per second, speed. Accuracy is 2%. So delta V will be, remember physics, errors and measurement. 35 into 2 by 100, that much is the error. So 45 to 90, 90 by 100, 0.9 meter per second is the error in the velocity. They are asking the uncertainty in the position, error in the position they are asking you. So m delta V into delta x more than equal to h by 4 pi. Say bhai, Diliginda. Mass of ball is 40 by 1000 kg SI unit into delta V 0.9 meter per second SI. Check. So for Heisenberg's principle, they are giving you two questions. Achha, one more thing. This value is very, very small. This is nearly 10 to the power 18 times smaller than the diameter of a typical atomic nuclei. It is even much smaller than a nuclei also, which is also very, very small. So for large objects, for macroscopic objects, Heisenberg and de Broglie principles are not very properly applied. Negligible answers will come by. Done by for big objects, but we can apply them comfortably and the result will be relevant for microscopic objects like electron, proton, neutrons, etc. Moving on. Here, number of orbitals associated with principal quantum number n equal to 3. So number of orbitals are n square. So third shell, 9 orbitals. How many electrons? 2n square. Using the SPDF notation, you have to tell n equal to 2, L equal to 1. So I think you know L equal to 0, 1, 2, 3, 4, S, P, D, F, G, H. So if they are saying n equal to 2, L equal to 1. So n equal to 2, L equal to 1 means 2p. Similarly, 5, 3, 5f. So you can try this once. Direct straightforward question by. This graph you can check. This is psi r versus r and psi r square versus r graph. So psi is radial probability, radial part of the wave function psi r, and psi r square is the radial probability. But which probability? Probability density. Psi square is not probability, it is probability density, radial probability density, R for radial. Clear, bhai? Sir, what is probability then? Probability will be psi square into volume, which is, if you remember a little bit, 4 pi r square dr psi square. We call it probability distribution function. But anyway, in NCERT only these two graphs are there. So whenever, see, this graph I have made this extra line for you to understand. In the NCERT, the graph is not starting from origin. It is starting from -10. So it might appear, because you might have mugged up, if there is one cut, if the graph cuts one time the x-axis, so you will get one node, one radial node. But the graph was given like this, and it appeared like it is not cutting, but it is cutting. Why? Because 0 was here. So only one cut was coming, so radial node is 1. For psi r square graph, it is touching and jumping up. Why? Because psi can have positive, negative, both values. But psi r square has only positive value because square of a number cannot be negative here. So only difference in the graph shape is that negative on squaring become positive. But that is not the question. The question they will ask you, how many radial nodes are there? One more thing, formula for the radial node. To understand, if you have total node, it is going to be n minus 1. Radial node is n minus L minus 1. An angular node will be equal to L. For example, 5f. So 5 minus 1, 4 total node. Angular node S, P, D, F, 0, 1, 2, 3. Angular. Radial will be 5 minus L minus 1. So that is 1. Clear, bhaiya? So this graph is not 5f because S starts from infinity. This graph, S starts from infinity. But for P, D and F, for these graphs, they start from origin. So this graph will come like this. So don't ever check here and don't ever check here. Node is always checked between origin and infinity. In between this, number of cuts will be equal to the number of radial nodes. But be extra careful with the graph starting from origin or not. If not starting, draw a line yourself at the 0 and then carry on with the question. Number of cuts equal to number of radial nodes. Next, this is the explanation of the energy levels. Why? So we know that for multi-electron species, 1s, 2s, 2p, 3s, 3p, 4s, 3d. This is the energy levels. And for single electron species, hydrogen and hydrogen-like species, for one electron species, 1s, then 2s equal to 2p, 3s equal to 3p equal to 3d, and so on. So this is 1s, 2s equal to 2p, 3s equal to 3p equal to 3d for hydrogen. But for multi-electron, 1s, 2s, 2p, 3s, 3p, 4s, 3d. N plus L rule will be applicable here. And here only N will decide the energy. Clear, bhai? Remaining, you know, if N plus L will be equal, lower N has to be checked. This is the important question, bhai. Energy of 2s orbital of hydrogen, lithium, sodium, potassium. Very important. This I feel can be the NEET 2025 question from this chapter also. So energy of 2s orbital of hydrogen is more and potassium is least, because we are not comparing last shell. We are comparing different nuclei. Second shell electron only are. Every one second shell. To understand, electron is almost at similar kind of a distance, but hydrogen contain 1 proton, someone contain 11 proton, someone contain 19 proton. So if the protons are more, attraction will be more for electron. If attraction will be more, the electron will be more stable. If the electron will be more stable means lower energy. So potassium has more proton. Hydrogen has only 1 proton. So 1 proton, less attraction, less stability. So more energy will be there for the electron. Very to the power infinity important. Moving on. Now, D5 here. D5, 10 exchanges are there. Half filled, fully filled configurations are stable. Why? Number 1, symmetrical distribution. Number 2, exchange energy. So number of exchanges for D5 are 10. And for P3, half filled configuration, there are 3 exchanges. You can just remember them. If you know how to find, great. If you don't know, remember it, move on. Live your life peacefully in a medical college. Now, the homework questions from NCERT exercise are very important. Next page. Number 1, 2.15. Number of spectral lines, delta n into delta n plus 1 by 2 formula. 2.18. Question is very easy. Just joules to ergs conversion is there. So joule to erg conversion will be 10 to the power 7. Very common in physics. But I am not trusting how much you know in physics. So I am just telling one more time. Then this question. Which of the following set of quantum number are not possible? Like n equal to 0. Very stupid. N cannot be 0. It should be 1, 2, 3, 4. N equal to 1, L equal to 0, okay. ML will be 0, possible. MS equal to minus half, correct. N equal to 1, L equal to 1, no. L will be 0 to N minus 1. 0 to N minus 1 means if N equal to 1, L will be at least 1, at least show. If N equal to anything, integer, positive integer, L will be less than N. So equal and more not possible. N equal to 2, L equal to 1, allowed. M 0, no problem. Similarly, N3, L3, bakwas, garbage. N3, L1, okay. M equal to 0, okay. MS, S means spin. Plus half, minus half, okay. This question also I would have circled, yeah. 2.132. How many electrons of an atom may have the following set of quantum number? N equal to 4, spin equal to minus half. So N equal to 4. So how many electrons are there? N equal to 4, number of electrons are 2n square. So 2 into 4 square, 16 into 2, 32. Out of 32 electrons here, 16 will have plus half spin and 16 will have minus half spin. They are asking only minus half. So our answer will be 16. What transition of hydrogen spectrum would have the same wavelength as the Balmer series transition of 4 to 2 of helium plus. Now understand, for hydrogen atom, if the energy here is minus 13.6, minus 3.4, minus 1.51, minus 0.85 electron volt per atom for hydrogen, then for helium plus, second shell will have the same energy as the first shell of hydrogen, fourth shell will have the same energy, table of 2, and so on. So that means 4 to 2 of helium plus 13.6, 3.4 will be 1 to 2 of hydrogen. All these you will find in the main track notes. 2.34, very important question in physics also. Clear, bhai? Make sure you do this as well. 2.39 is on quantization of charge. Q is equals to Ne, number of electrons, total charge. This E is fundamental charge. 2.39. So these are the main questions you should be doing. And if your math you want to practice, then do question number 2.43 and 2.44 also. Very good questions, but tough mathematically. 2.43 and 2.44. In fact, 2.42, 43, 44. In fact, 2.42 is previous year JEE mains as well as advanced question from NCERT exercise. But if you are good in the topic, if your chemistry is okay, make sure that you try 2.42, 2.43 and 2.44. Chaliye bhaiya, tata, bye bye, bye bye, bye bye, bye bye. Structure of atom. It was a lovely meet and greet scenario. Moving on to thermodynamics. Chalo. Direct theory question, one see that. Now, 2 liters of an ideal gas at a pressure of 10 atm expands isothermally 25 degrees Celsius into vacuum. So, bhaiya, whenever there is expansion against vacuum, the work done will be 0. This is called free expansion. Consider the same expansion, but this time against a constant external pressure of 1 atm. So pressure is external, 1 atm constant. So minus P external delta V. So minus 1 into delta V. 2 liter to 10 liter. So 10 minus 2. So this is liter, this is atm. Don't forget. So it is minus 8 liter atm. So don't forget to multiply with 101.3, then also joules will come or joules will come, depending upon how you want to speak. Consider the expansion for 1 mole of an ideal gas conducted reversibly. So direct formula is there, reversibly, isothermally, minus 2.303 nRT log V2 by V1 or P1 by P2. Here, whatever you want, you can put the units, liter, ml, it should cancel. So from 2 liter to 10 liter. Clear, bhai? Next. If water vapor is assumed to be a perfect gas, molar enthalpy change for vaporization of 1 mole water at 1 bar. So they are giving you molar enthalpy change delta H, they have given you 41 kilojoule per mole for vaporization of water at 100 degrees Celsius. Calculate the internal energy change, delta U they are asking. So we know that delta H is delta U plus delta NGRT. For that I need a reaction. Delta NG means product minus reactant, gases. So product and reactant kawali, reaction kawali. So sir, what is the reaction? Are lallu, reaction is H2O liquid becoming H2O gas, evaporation. Delta Ng, sir, 1 gas minus no gas. Delta Ng is 1. So delta U will be delta H minus delta NGRT. So delta H is 41 kilojoule. Delta Ng is 1. R is 8.314 joule per Kelvin per mole. Temperature 100 degrees Celsius. Lo bhaiya, lollipop question over. देखो. C. Cp minus Cv equal to R. Here write down for 1 mole. Write it down here for 1 mole of ideal gas. Cp minus Cv equal to R for 1 mole of ideal gas. Ideal gas important. This is not applicable for solid liquid. For solids and liquid, Cp and Cv are approximately equal. Remember that also. But Cp and Cv, Cp minus Cv equal to R. This is only for ideal gas and 1 mole. Clear hai bhai? Bohm calorimeter question, how to solve? Bhaiya, for Bohm calorimeter, I have given you a simple shortcut. Apply that every time, easy answer will come. So number one, Bohm calorimeter is a closed container. Volume constant, work done 0. Heat transfer at constant pressure. Open container heat transfer is delta H. And closed container heat transfer is delta U. So delta U will be there for Bohm calorimeter, will be equal to minus Ct delta T by moles of reactant. For example, this lollipop question is there, 1 gram of graphite, 1 gram graphite. So moles of reactant will be 1 by 12 moles, given mass by molar mass. Bohm calorimeter, excess of oxygen 298 Kelvin, 1 atmospheric pressure, this to this, 298 to 299 is the temperature change. So delta T is 1. 298 to 299. And Ct, total heat capacity, heat capacity, heat capacity, heat capacity, heat capacity, heat capacity, 20.7 kilojoule per Kelvin. So minus 20.7 kilojoule per Kelvin. That's it. Delta U came. Sir, how to find delta H? So for example, carbon was getting combusted. So when carbon get combusted, delta Ng will come 0 because 1 gas minus 1 gas will be 0 gas, solid ignore. And delta H will be delta U plus delta NgRT, delta Ng will be 0. So delta H will be almost delta U. Are simple lollipop yaar. Are happy question over, happier question coming. Next, a swimmer coming out from a pool is covered with a film of water weighing about 18 gram. So moral of the story, we have 18 gram water, we have 1 mole manchinilu, or we can say chaddanilu, because who will drink water from the hand of a swimmer here? So chaddanilu. How much heat must be supplied to evaporate this water at 298 Kelvin? So temperature 298 Kelvin, if required. Internal energy of vaporization at 298 you have to find. Delta H they have given you 44 kilojoule per mole. Did you realize that the question is same? Again evaporation happening, again reaction I will write. So revision of the revision NCRT have done. Delta Ng is 1 gas minus no gas. So delta H is delta U plus delta NGRT. Delta H is 44,000. Delta U I have to find. Delta Ng is 1, R is 8.314 joule per Kelvin per mole and temperature is 298. Akada 373. Ikada 298. Akada data was for 373. Ikada data for 298. Question is same. Only swimmer came. Just like a paper of physics track 2 you got na. Ki Professor Cool have done something. Similarly, this is Professor Hot done something. Some extra information is there. Ki Professor Cool go to the pool, come with a pot of water, and he fall down and broke his crown. Getting by? Hello. After that, 18 gram water was there in the bucket. How much will be the delta U? So initial story is not relevant. From 18 gram of water onwards, the story starts. So always write the data like this in a separate page and solve it. Even big questions won't be bothering you. 5.8, this question you will try once. Method I'm telling you. Means everything I will tell, just put the value and try once. So from 100 degrees Celsius of water, we are going to 0 degrees Celsius ice. Very common question in physics. From water at 100 degrees Celsius, liquid water, we are going to 0 degrees Celsius ice. But this process happens in multiple steps. So from 100 degrees Celsius liquid to 0 degrees Celsius liquid. Then from 0 degrees Celsius liquid to 0 degrees Celsius solid. This is phase transition. At phase transition, pressure, temperature both are constant. Bhai. So here delta T coming, so here the heat transfer will be NC delta T. Let's call it Q1. And here the Q2 will be N into delta H. Constant pressure, heat transfer is called delta H. And phase transition happen at a constant pressure. So the heat transfer of phase transition will be delta H. Simple. So Q1 plus Q2 will come. Delta H they will be giving in the question. See, heat capacity also 4.2 given. Delta H also 6 kilojoule per mole given. Number of moles of water you can find 1 mole given in the question. So try this question once. Problem 5.8. And search this in your physics notebook also. You will find it. Moving on. The question done. Hanji. For enthalpy of formation, there are 3 conditions required. For enthalpy of formation, you should be having 1 mole product from elemental states, elemental reactant, standard state. If these 3 conditions are satisfied, then the reaction enthalpy is called enthalpy of formation. For example, 1 mole of ethanol, elemental reactant, graphite, H2O2. And everyone is in their standard state. For carbon, graphite is the standard state, hydrogen gas and O2 gas are the standard state. Chaliye bhaiya, let's come to the question. They are saying the combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atm. After combustion, CO2 and H2O are produced and 3267 kilojoule heat is liberated. So enthalpy of combustion of benzene is given minus 3267 kilojoule, because liberated means minus sign we have to put, sign convention. Calculate the standard enthalpy of formation of benzene. Enthalpy of formation of benzene they are asking me. See, when I'm reading the question, I'm not focusing upon the initial garbage. I'm directly coming to data what they are trying to give me and converting them into symbols. Standard enthalpies of formation of CO2, and formation of Mancini-Lou, they have given us minus 393.5 kilojoule per mole and minus 285.83 kilojoule per mole. Badhiya. So yaar, I have 3 enthalpy of formations mentioned in the question and 1 enthalpy of combustion. Whichever enthalpy is mentioned one time, for that we will write the reaction. Simple. Benzene C6H6 plus O2 gives you 6CO2 plus 3H2O. So 12 plus 3, 15, 15 by 2, O2. So enthalpy of this reaction is the enthalpy of combustion of benzene. It will be equal to enthalpy of formation of product, enthalpy of formation of the product, minus enthalpy of formation of reactant. For elemental standard state, enthalpy of formation is taken as 0, if you remember. Elemental standard state, enthalpy of formation is taken as 0. Putting the value, CO2 will be minus 393.5 into 6 plus water, minus 285.83 into 3 minus enthalpy of formation of benzene, you have to find 3267, minus sign here, over. In my memory, something was wrong in the solution of this question. So when you will solve, don't panic. If after 2 times you are solving, answer is not matching, don't panic, because some silly mistake NCERT have done here. I think with the minus sign or something. So either the final answer was not matching or the in the middle steps are not matching. Something is wrong with this numerical in NCERT. But don't worry, mathematically any mistake is there, we can correct it. We don't have to that much blindly follow the NCERT. If mathematical mistake is there, calculator mistake is there, it can be easily claimed. Then by historically also NEET have changed the answer keys of NCERT if it was a mathematical mistake. Conceptual mistake, NEET generally don't change. Now, for metals, enthalpy of sublimation for metals and graphite. For metals and graphite, enthalpy of sublimation is equal to enthalpy of atomization. Clear, bhai? Achha, the formula I'm using here, formula is enthalpy of reaction is enthalpy of formation. Let's write here. Enthalpy of reaction is enthalpy of formation of product minus reactant. If combustion is there, two or more combustion enthalpies are there, then R minus P, and bond enthalpy also R minus P, but this is only for gases. That's the formula, just a quick revision. But question that we are doing majorly is that one, which came in the NCERT solved example. Next, this gas phase I underlined here for the last formula, but I think that's okay. Next, very important question, might be NEET 2025 question from this chapter. Enthalpy of solution is enthalpy of hydration, that is hydration enthalpy plus lattice enthalpy. This is positive, this is negative. Then by enthalpy of solution of salt is generally positive, not always, but generally positive. So for example, NaCl, they are giving me hydration enthalpy is minus 784 and lattice enthalpy is plus 788. Find the enthalpy of solution of NaCl. So the answer will be 4. Then by hydration enthalpy plus lattice enthalpy. It's application of Hess law. And also one more thing. If the enthalpy of a reaction is negative, exothermic reaction is there, then the mixture will cool down. Keep that in mind. If reaction is exothermic, if it is releasing the heat, the container will cool down. Remember that, very important, because here the confusion can come. It is the heat withdrawn from the surrounding. Doubt can come, sir, it is exothermic. So why the heat is withdrawn from the surrounding? Think yourself, now if it is exothermic, energy is released to the universe, container becomes cool. But container is not reaction. Container is the surrounding for the reactant. So I don't want you to go here and get confused for this line. But remember, whenever there is an exothermic reaction, for example, enthalpy of dilution came exothermic. So solution become cool. But remember, solution is not the reaction. Reaction is this HCl. This is the reactant and product. This reaction is the system. Surrounding is the solution and the solvent particles. Solvent particles in the solution. So when this energy is exothermic, we say, clear hai bhaiya? That means this reaction is releasing the energy. It is going out. Hello? Hello? And the container becomes cool. Understood, bhai? And the container is the surrounding here. Container is the immediate surrounding. It is becoming cool. That means the heat is withdrawn from the container. We can think like this, ki heat is withdrawn from the container. That's why the cooling effect coming. Otherwise, I cannot explain how the cooling happens. But we have seen that's how cooling happens. Evaporation also causes cooling. But that's a different scenario. It is not a reaction. It is endothermic, taking the heat away from my body. That is different scenario. For sweating purpose, it's a different scenario. That's not a reaction. But when reaction is there, in the reaction, the energy is getting released. The container becomes cool. Keep that in mind. Clear, bhai? NCERT have many lines like this which can create confusion and which is correct. It's not wrong. Just that it is tough to understand. Now, out of delta U and delta S can differentiate between reversible and irreversible process. Very important statement. Remember that. Now, increase, decrease in entropy. Liquid crystallize into solid. So when liquid becomes solid, bhai, so we know that solid, liquid, gas, the entropy of gas is more than liquid than solid. So when liquid becomes solid, entropy decrease, delta S negative. Now, entropy change is proportional to temperature. Sorry, entropy proportional to temperature. Temperature increase, entropy increase. Solid become gas. In a reaction, entropy increase. Number of moles increase, entropy increase. Clear, bhai? Volume increase, entropy increase. External pressure is increasing, entropy decreasing. Here, 1 mole hydrogen become 2 mole. 1 mole become 2 mole, entropy increase. To check all these examples, 2021-22, somewhere this same direct question came in the NEET examination. Clear, bhai? In last 5 years, 3 times this model have come. One for chlorine, that was NCERT exercise question, and 2 times this only came. Done. Remember one thing, change in entropy proportional to temperature inversely. Entropy proportional directly, but change proportional inversely. Chaliye, moving on. Life is to move on. They are saying entropy change is negative. That's after that also. Why the reaction will be spontaneous? Because delta H is more negative. That is the answer. Because delta H is more negative. Understand here. Spontaneity depends upon delta G. Delta G negative, reaction is spontaneous. Delta H and delta S are one of the criterias, contributing criterias for spontaneity. But they are not alone. Only delta S and only delta H of a system cannot decide the spontaneity. It is decided by delta H minus T delta S together. This is the first law part. This is the second law part. Together they decide. Because the first law was not able to explain many examples why the reaction is spontaneous. That's why second law was made for thermodynamics. So combined that, delta G will come. So delta H is minus 1648 into 10 power 3 joule per mole. Temperature 298. And entropy is minus 549.4 joule per Kelvin. Clear, bhai? Overall answer comes negative. Overall. So delta G overall negative. That's why spontaneous. So why spontaneous? Because delta H is negative. Delta H is more negative than T delta S is positive. So because delta H is more exothermic, more negative, then T delta S is positive. So overall answer comes negative. That is why even though entropy change is negative, the reaction will be spontaneous. That's what the question they are asking. Can be a Russian reason question in the NEET exam also. One more thing. Can you see this formula? Delta G is delta H minus T delta S. This is for constant temperature condition. Bhai. This is only applicable at constant temperature. See, if the temperature is not constant, the formula will be this. Delta G is delta H minus T delta S minus S delta T. So temperature constant, so delta T is 0. That's why this formula we use. All this is there in NCERT, bhai. Please remember, doesn't matter which category of a student you are, everyone have something to read from NCERT, bhaiya. Moving on. In the NCERT exercise, one easy question of the same formula is there. So the formula, I think you know, delta G naught is minus 2.303 RT log K. So based upon this formula, one easy question is there in NCERT exercise. So these two you can try once. NCERT exercise question I'm telling you first, which is the easier version of the same question. Yeah, this one, 5.20. Important but easy. Equilibrium constant of a reaction is given as 10. Value of delta G naught they are asking. So R will be 8.314. Temperature will be 300 Kelvin they have given. Log 10. Log 10 is 1. A sec. Now, coming to NCERT exercise, one by one. Firstly, MCQs. I think MCQs you can try 5.1, 2, 3, 4 easy questions. 5.5 also. Clear? I don't think problem is going to come. They are all easy questions. 5.7 also. These are the homework. Make sure that you tick the homework. 5.5, 5.7. Clear, bhai? If you want, you can try this bomb calorimeter 5.8 question using the shortcut delta U of bomb calorimeter is minus CT delta T by moles of reactant. 5.9 we can see. Calculate the number of kilojoule of heat necessary to raise the temperature of 60 gram aluminium. So I have weight of aluminium as 60 gram. So moles will be 60 by 27 moles given mass by molar mass. Raise the temperature from 35 degree to 55. So delta T will be 55 final minus initial 20 degrees Celsius. Molar heat capacity of aluminium is given as 24 joule per Kelvin per mole. It's the molar heat capacity per mole. Total heat they are asking me. So molar heat capacity given, total heat asking to NC delta T. Moles are 60 by 27. Heat capacity 24. and delta T is 20 over this much joule is the answer. Straightforward question. In 5.15, try 5.15 also, but where you are seeing na enthalpy atomization of carbon. So remember that for carbon and metals, enthalpy of atomization is the sublimation enthalpy. So if you want to write the reaction for enthalpy of atomization of carbon, it is going to be carbon solid become carbon gas. For this one, it will be carbon solid become carbon gas. Enthalpy of sublimation. Sublimation atomization is same. And atomization of a diatomic gas is equal to the bond enthalpy. So this atomization of chlorine given, it is equal to bond enthalpy of Cl2. And I think bond enthalpy reaction you are able to write more easily. So bond enthalpy of Cl2 and atomization enthalpy of Cl2 will be same. That is the case for diatomic gases. So in 5.15, make sure that you write these two things. This atomization enthalpy of carbon is same as the sublimation enthalpy. So that you can write directly solid become gas. And atomization enthalpy of chlorine is directly equal to bond enthalpy of chlorine. Done, bhai. Next. 5.18, previous year question of NEET I was telling about. This question came in the NEET examination. Same, direct question, no change. 5.19, delta U naught is given to you, delta S naught given, delta G naught they are asking. Simple. From delta U naught, delta H is delta U plus delta NG RT. From this formula, delta U naught, delta NG RT, delta NG will find from here. I will get delta H naught. And then I will put delta G naught is delta H naught minus T delta S naught, and then how I will get delta G naught. So 5.19 question, two-step question. Try. 5.21, enthalpy of formations are these. You can see now, 1 mole NO, 1 mole NO2 formed from the elemental reactant, but this one is not elemental. So this is the enthalpy of formation and this is not. They are asking you to compare the stability. So if the enthalpy of reaction is more negative, the product is more stable. For example, here the enthalpy of reaction is negative. So product is more stable. NO2 is more stable than NO. Fasak. They are asking to compare the stability of NO and NO2. You can see that NO became NO2, energy release. Think like this, na? NO become NO2. Exothermic. Exothermic means product should have lesser energy. NO2 have lesser energy. That's how it will be exothermic. And lesser energy means more stability. Next, calculate the entropy change in surrounding. Enthalpy of formation of water they have given you, but they are asking you enthalpy change of surrounding. So dekho, delta S of surrounding will be Q sur by T sur. And Q sur is minus times of Q system. So heat absorbed by the surrounding is released by the system. And Q system they have given me minus 286 they have given in the question. And surrounding temperature nothing mentioned. So if nothing mentioned, I can take 298 Kelvin. If surrounding temperature is not mentioned, I will take 298 Kelvin. Otherwise, whatever the temperature they have mentioned, I will take that. This is 5.22. Check, bhai. Coming to equilibrium, before the first break, last chapter. After that, a brief break we can take and we'll continue with the senior interphysical chemistry part followed by the inorganic. Chaliye. Here, some questions are very direct. So make sure those direct questions you should be able to apply directly. Sometimes the easy question become difficult because of lack of practice. Clear, bhai? We are prepared for a bouncer. And a good length, slower one came. Caught out. The following concentrations were obtained from the formation of ammonia and N2H2 at equilibrium 500 Kelvin. Concentrations given, equilibrium constant. So Kc will be product by reactant concentrations, power, stoichiometry. For solid and liquid, active masses are taken as 1 with respect to gas. So directly you can put reaction is N2 plus 3H2 gives you ammonia. So ammonia square by N2 into H2 whole cube. Simple question. Same question is this. Equilibrium, the concentrations are given. Kc they are asking you. So direct questions, both of them are there. Make sure that you see them. Practice them. Don't just see, huh? NCERT solved example, data also they use. So sometimes the data are difficult. And people think, yeah, method I know. There is no need of practice. If you know the method, then is the need of practice now. Because if you know the method, that means 90% job done. But in the NEET exam, 90% done means -1. Chinna mistake will happen in the calculation. Why to take the risk? So if you know the method, great, practice it, try to get the answer. And I'm giving you guarantee, when you solve every single question that you think you know, half the answer will not come. This is the learning stage number 1. Understanding the problem is not in the method, but in the process. While doing it, you will realize the problem is coming. The equilibrium constant Kc for the above equilibrium can be written as this one done. Simple. The value of Kc they have given you. Calculate the equilibrium concentration of CO2, H2, CO and H2 at 800 Kelvin if only CO and H2 are present initially in the concentration this and this. Dekho bhai. Question is CO plus H2O. Both are gas. Equilibrium CO2 gas and hydrogen gas. They are saying initially CO and water were 0.1 molar. This was 0.0. So at equilibrium, from here C reacted. So 1 react, C react, C react. 1 react, 1 produce, C react, C produced. 1 react, 1 produce, C react, C produced. Kc given 4.24. I am taking Kc as 4, let's say. So it will be C into C by 0.1 minus C into 0.1 minus C. Why, sir? Product by reactant power stoichiometry. C square upon 0.1 minus C whole square. Taking square root both sides to 2 is equals to C upon 0.1 minus C. So 0.2 minus 0.2, sorry, 0.2 minus 2C. 0.2 minus 2C is C. So 3C will be 0.2, so C will be 0.2 by 3 molar. Check bhaiya. In case quadratic equation comes, in case it comes, then you have to make it like ax square plus bx plus c. You have to write in this form, and you will be getting x equal to minus b. Minus b plus minus root of b square minus 4ac by 2a. This also, yeah, interesting thing is this only. This also I have recently taught in one of the good batches as well, because people did not know this formula as well, and I don't know how the hell 500 plus marks came in the NEET examination, but that's the reality of last year cutoff. So if the cutoff goes down this year, it will be good for some but bad for many. So make sure you are on the good side. Practice well. Trust the process. Done bhaiya. Chaliye. So moving on. Kc they have given you, Kp they are asking you. So remember the formula. Kp equal to Kc RT power delta Ng. Here R will be 0.0821 liter ATM per Kelvin per mole. Because your Kc will be in the terms of molarity. Kp will be in the terms of Kp will be in the terms of ATM. That's why it's better to use R equal to 0.0821 liter ATM per Kelvin per mole. Direct question. Next. Kp for this reaction is 3. If the initial, you can see units they have not used here. They used Kp is 3. That means they are taking Kp, Kc in NCERT as unitless quantity. That's the condition for standard condition by, like you can see here. This is what they are trying to say. Units of equilibrium constant. Equilibrium constant can also be expressed as a dimensionless quantity if the standard states of reactant and the products are specified. Clear, bhai? Now here, Kp they have given as 3 at 1000 Kelvin. If initially CO2 was this much, CO was this much, pure graphite is present. Calculate the equilibrium partial pressure of this. Dekho. So this question is for gases and they have given us pressures. So we can solve in the pressure directly. So initially CO2 was 0.48 bar. I am taking 0.5 approximately. Carbon solid active mass 1 and CO was 0. So at equilibrium from here P reacted. So 1 react, 2 produce, P react, 2P produced. 1, 2, 1 react, 2 produced, P reacted. How much left? 0.5 minus P. Kp they have given as 3. So Kp will be 2P whole square upon 0.5 minus P. So make sure that you solve it. I'm making the equation and I'm leaving it for you to practice this way. I'm putting in this form. Dekho. Because I know there are many people who don't even know how to make this equation as well. That's the unfortunate thing. 4P square AX square. 3P on the other side minus 1.5 equal to 0. This is AX square plus BX plus C equal to 0. Now you will get P is equals to minus B, that is minus 3 plus minus root of B square, 3 square minus 4 into A into C by 2A. This is the fundamental problem here we are facing as teachers, that the quality of basic elementary math is decreasing so much. That's why for goal admissions also we have put math and aptitude this year. We don't want the people to believe by their board marks that they are too good. And then 3-4 months they are in the hangover of the senior inter or board marks. And then they come and think, yeah, I'm so great. And then they don't even know how to solve a quadratic equation, which is a class 9th syllabus, 10th syllabus. So if someone is passing class 10th, they should be knowing the basic of at least class 9, 10. Formula, I'm not saying high-fi question, formula. Clear, bhai? This much low level we cannot go here. We are coming in the long term and I have to teach you beta A for his apple. This is not how it works. But anyway, this was the situation for some of the students in this year. Anyway, hope by the end of this year, you'll be surpassing all these levels and your all schooling backlogs are completed. But when you start your MBBS first year, study from first year onwards here. Clear, bhai? Because everyone will not fight till the end for you. You have to take the responsibility of your actions now. The value of Kc for the reaction, 2 10 power minus 3 at a given composition of the reaction mixture, this much, which direction the reaction will proceed. Now we know if Q is more than K, reaction go backward. If Q is less than K, reaction go forward. And if Q is equals to K, it is called equilibrium. So for this, I am finding Q. Q is also P by R power stoichiometry at any conditions, not equilibrium, at any condition. Like in this condition, putting the value, concentration of C into B by A square, I am putting whatever they have given me. So C into B by A square. So khadak, this will come 1. Oh. Khadak, this will come 1. So Q equal to 1 and K equal to 0.002 given in the question. So Q is more than K. So the reaction goes backward. So from the given concentrations, they were asking at some reaction mixture, this is the concentration where the reaction will go. So reverse direction. Moving on, 13.8 gram N2O4 placed in 1 liter vessel, allowed to attain the equilibrium. N2O4 gives you 2NO2. Total pressure of this much was 9.15 Kp Kc. You have to find. Dekho bhaiya, very good question. N2O4 equilibrium 2NO2. Now molar mass of N2O4 will be 92. So I'm taking a similar kind of a data for simpler calculations. It is 13.8 gram given. So 13.8 gram, let's say 14 gram by molar mass 92. 16,464 plus 28. हाँ, ठीक है. Clear भैया? These many moles are there initially. Now understand, they have given us total pressure at equilibrium is around 9 bar. And whenever they talk about moles and total pressure, we have to apply Dalton's law of partial pressure. That means we have to find the partial pressure of a substance by total pressure into mole fraction. So I need mole fraction, bhaiya. at equilibrium. So this is 0. Clear, bhai? For simplicity, I can take this 15 by 90 roughly. Clear? 1 by 6 mole initial. At equilibrium, 1 by 6 minus x, here 2x. Total moles. 1 by 6 minus x plus 2x will be 1 by 6 plus x. Mole fraction of N2O4 is 1 by 6 minus x by 1 by 6 plus x. Mole fraction of NO2, 2x by 1 by 6 plus x. Partial pressure of N2O4, 1 by 6 minus x by 1 by 6 plus x mole fraction into total pressure, 9 bar given in the question. And partial pressure of NO2 will be 2x upon 1 by 6 plus x into again 9 bar. Question over. Put in Kp, answer will come. So Kp will be partial pressure of NO2 power stoichiometry by N2O4. So one more time, I want you to focus upon the method, especially moderate students, because good students are able to do this already. But moderate students, see properly what we did. We found moles, then at equilibrium we found moles, then we found total moles. So moles by total moles are mole fraction. Clear, bhai? So firstly, I will find moles from their mole fraction, from their partial pressure. And once I get the partial pressure, I can put in the formula of Kp and get the answer. Question is big? Yes. Tough? Yes, we can say tough question. Moving on. 3 mole of PCl5 1 liter container. This is easy. So this one you can try, because here there is no extra effort. We have done this same kind of question before. 3, 0, 0, 3 minus x, x, x. X square upon 3 minus x will be Kc. Solve the quadratic equation. Delta G naught. This question also came in NEET 2021. Same question, same data. They did not ask to multiply, but the question was same. But this question we have done already, so I'm not trying again. Delta G naught is minus 2.303 RT log K. But here the R will be 8.314. Huh? For Kp equal to Kc, one more time I'm repeating. For Kp equal to Kc, RT power delta Ng, this is 1 by 12. And for delta G naught is minus 2.303 RT log K. R can be 8.314 if you want delta G naught in joules. Units of R are very important. People are putting random values of R and then they are getting frustrated, sir, answer not coming. Grow up, be more mature, remember things. Silly mistakes you cannot be doing for your whole life. Clear, bhai? 6.11 also try same exact formula. Now, this reaction 2-3 times in Gosalite we have asked this. Fe3 plus HCl minus deep red color. FeHCl 2 plus. Fe3 plus yellow dirty fellow. FeHCl deep red blood red coloration. If I add this is looking like H2SO4, it is not. It is H2C2O4, oxalic acid. If I am adding oxalic acid, so oxalic acid oxalate is a ligand who will react with Fe3 plus. So if oxalic acid added, Fe3 plus will react with H2C2O4. Clear, bhaiya? Voice clear? Everyone, give a quick yes if the voice clear or not clear. One person said voice is getting stuck. Their internet problem is there or the universal internet problem is there. Twarga se. It is getting stuck in the middle. Now it's fine. Clear or not clear, bhaiya? Give me the final verdict. Clear, not clear. Let me check YouTube also. From my end. From my end, it is coming. If it is coming in my mobile, why it is not coming in yours? Something is off. Chali, no problem. Maybe in the middle, little bit up and down, little bit hiccup will happen. Chill, yaar. Little bit. Kuncham, NCERT there with you. You're not illiterate. You can read what is given. You can read this part given here. But I'm saying in the same language, English only given. So oxalic acid forms a complex with Fe3 plus. Done by. So Fe3 plus will be consumed. So Fe3 plus decreases, reaction goes backward to produce more Fe3 plus. So deep red coloration decrease, yellow increase. Similarly, if Hg2 plus added, it's a central atom, D block. Hcn minus is a ligand. It reacts with the ligand. This will decrease. Reaction again go backward to produce more and more Hcn minus to compensate the loss. Again the yellow color will increase, deep red decrease. If you add potassium thiocyanate, KHCN, then Hcn minus increases, then the reaction goes forward. So these three things are given in the paragraph below this. Can be a very important question, but we have asked several times in our papers. In grand test also we will ask somewhere this thing. Next, moving on. This also can be a confusion sometimes. In D and F block it is written, the color of cobalt 2 plus 3 plus is blue pink. In last exam also it came on heating, someone was pink, became blue. It is cobalt 2 plus 3 plus. They are always in equilibrium like that. Then by on heating becomes blue. Very important point. If a reaction has very small k, equilibrium constant is very small. That means the reaction is not product dominating. Reaction is not even happening. The catalyst will be of no use here. So we are catalyst. Our job is to increase the speed of your preparation. But if your equilibrium constant is negligible, that means you don't even want to react. What will the catalyst do, yaar? Little help. Time pass we can do for you only. Clear, right? So K value very less, catalyst will be of little use. K value very high or high, catalyst will be useful. Make sure this box also see properly. H plus cannot exist independently. H plus will never exist independently. H plus will always be existing in the form of H3O plus or something like that. Surrounded by water. Very important. Moving on. Chinna things. Conjugate base. Conjugate base means you have to release one H plus. So HF, conjugate base is F minus. H2SO4 conjugate base will be HSO4 minus. pKa of conjugate acid and pKb of conjugate base is 14. Next. So try these two questions based upon conjugate acid base, and one more. Conjugate acid is stronger. If the conjugate acid is stronger, conjugate base will be weaker. For example, HF, HCl, HBr, HI. That is the acidic strength in P block. So conjugate base F minus, Cl minus, Br minus, I minus, conjugate base, basic strength order will be opposite. So conjugate acid is stronger, conjugate base weaker. Then bhai, concentration of hydrogen ion in a sample of soft drink is this much. What is the pH? So pH is minus log H plus concentration. That is minus log 3.8 into 10 power minus 3. So देखो यार, minus log x into 10 power minus y will be y minus log x. 3 minus log 3.8. So log 4 is 0.6. 0.6020, log 4. Log 3.8 is little less than 0.6. So 0.58, something like that. So 3 minus 0.58 will be 2.42. This is a rough estimation. Either they will give you log data in the question. If they are not giving, approximately only answer you have to find here. pH of 10 power minus 8 molar HCl. So remember, 10 power minus 1 molar HCl, pH is 1. 10 power minus 2 molar, 2. Minus 3 molar, 3. Minus 4 molar, 4. Minus 5 molar HCl, pH is 5. Because minus log 10 power minus 5 I will do. But when it comes to 10 power minus 6 molar, 10 power minus 7 molar, 10 power minus 8 molar, 10 power minus 9 molar, 10 power minus 10 molar, problem comes. What, sir? Up to here, water contribution can be neglected. But from here onwards, we have to consider water contribution also, because water will also give you H plus and OH minus. So here, the pH will come 5.96 because some H plus will be given by water around 10 power minus 7. But you have to consider that also. Here the pH will come 6.8. Here the pH will come 6.98. So my advice is, why to waste your time in calculating? Remember it. After that, the pH will be approximately 7, little less than 7, but approximately 7. Then the HCl become negligible. Clear, bhai? And if they ask you for NaOH, same answer for POH will come. And I think you know pH plus POH is 14 at 25 degrees Celsius. So 10 to minus 8 molar HCl solution, 6.98. I think last exam chaser also this question came. Moving on. Now, this is about the weak acid, weak base. The ionization constant of HF is given to you. The degree of dissociation of HF in its 0.02 molar solution they are asking. So, देखो, whenever there is a weak acid HA dissociate to form H plus and A minus, it is initial C00. At equilibrium C minus C alpha, C alpha, C alpha, Ka will be C alpha square upon 1 minus alpha. That's a perfect formula. But if alpha is much lesser than 1, that is alpha is less than 0.1. Then you can take 1 minus alpha is approximately 1 and alpha will be root of Ka by C. So how much is Ka? 3.2 10 power minus 4. And how much is C? 0.02. So 0.02 means 2 10 power minus 2. So this is 1.6. This will go up to 1.6 10 to the power minus 2 root. So it is 16 into 10 power minus 3 root. So it is 4 into 10 to the power minus 1.5. Clear, bhaiya? So, but minus 1.5 have no value. We cannot find that value. So you can simplify that. How, sir? 10 power minus 2 into 10 power minus 1 root. So this will be 4 into 10 power minus 1 by root 10, around 3.3 something, 3.2, 3.3. So 1 point something something 10 power minus 1. Clear hai bhai? But this is not a very proper way of solving because alpha is coming more than 0.1. So if you want exact answer, make sure that you use this. Clear bhai? But if you use this, only drawback is that you will get a quadratic equation. That's why I'm saying, bhai, please practice quadratic. Yeah. Every time alpha will not be less than 0.1. Clear, bhai? Every time alpha cannot be less than 0.1. You can check like this, root Ka by C. If it is coming less than 0.1, no problem. If it is not coming less than 0.1, that means you have to use this quadratic equation. Then only the answer will be matching, bhai. See, 0.12 coming. Clear, bhai? pH of 0.1 molar monobasic acid is 4.5. They are asking all the values. So, देखिए, for pH, I can use, देखो, this formula which I am using. Firstly, H plus concentration for weak acid. The H plus concentration will be C alpha. That is C root Ka by C. That is root Ka into C. Same for OH minus for base. For weak base, same thing for OH minus. Then by this part is applicable if alpha is much less than 1. That is, alpha is less than 0.1. But every time it is not going to be less than 0.1. But if it is less than 0.1, you can comfortably solve the question by using a formula. The formula is pH is equals to half of pKa minus log C for weak acid, and for weak base, pH is equals to POH equal to half of pKb minus log C. But this is only applicable when alpha is less than 0.1. So don't just randomly put it. Once, always try to check. Like 0.1 molar monobasic acid, pH is 4.5. They are asking pKa, pKb. So pH 4.5 is equals to half of pKa minus log 0.1 means log 10 power minus 1. So 4.5 into 2 is 9 equal to pKa minus log 10 power minus 1 is minus log 10 power minus x will be x. So 1 will shift here. pKa will be 9 minus 1, 8. So Ka will be 10 power minus 8. Sir, is my answer correct? Can I use this formula? Yes. How? See, alpha is coming root of Ka by C. Ka will be 10 power minus 8. C will be 0.1. So it is coming root of 10 power minus 7, which is 0.000 something. It's negligible. But every time you will not be so lucky, na? So I'll give you one simple rule. If the concentration is more than or equal to 0.1 molar or 0.01 molar, you are in a comfortable zone for weak acid, weak base. If the concentration become too dilute, then alpha become too high. Remember that if the concentration is less, alpha will be more. But 0.1 molar, you are comfortable, you are safe. 0.1, 0.2, 0.3 kind of molar. Clear? By 0.01 also it can be risky, but 0.1 molar you are going to be safe. Clear, bhai? Until someone make a hypothetical question just to bother you, but that NEET will not do. Then bhai, NEET don't have this sadistic approach to take the pleasure from the students' low marks. So that they will not do. But yeah, they will do their job. They will try to create a question where the judgment of the knowledge can be done. So remember, these formulas for weak acid, weak base are correct, but for only alpha less than 0.1, which is mostly going to be there in your NEET examination. All the PYQs are like that. But still, be extra careful. Same question like this, you can try this one, 0.08 molar, can be risky. So always check. How check? Alpha is root of Ka by C. So Ka will be 2.5 10 power minus 5 given, and this is 8 into 10 power minus 2. So this is 8 3s are 24. So 3 into 10 to the power minus 6 plus 2 minus 4. So it is 1.732 10 power minus 2. So 0.01732. Correct. Alpha is coming less than 0.1. So now very comfortably, without any headache, you can apply the formula pH is equals to half of pKa minus log C. Answer will match. Clear, bhai? Done. Try by this. So log will be tough to solve. No, it won't be. If you are getting log 2.5 as a problem, so remember log 2 is 0.3. Log 3 is 0.48. In between that, any number you can choose. You can choose 0.4 approximately. Learn. Clear, bhai? Ab in the revision of 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 the revision will not happen, na bhai? It's something I have told once today. I'm assuming you are listening this for the 4th or 5th time. So you should be able to now recall it. Same question here, pH of 0.004 molar hydrazine. I don't know it's what, but I know that they are talking about Kb, pKb. It's a base. Hydrazine is a base. Clear, bhai? So pH of 0.004 molar, this 9.7. Apply the formula POH is equals to half of pKb minus log C. Then bhai, don't see the NCERT solutions, they are too lengthy. Make your own solution and match the answer. Same question here, but now the story changes. Now in the story here, we are having ammonium chloride and ammonia. We are having weak base plus its salt. It is buffer. Clear, bhai? Weak base plus its salt is a buffer. And for buffer, we use Henderson equation POH equal to pKb plus log of conjugate acid by conjugate base moles you can take. Concentration precisely, but moles also you can take. So POH, how much is POH? We have to find. pKb, how much pKb? 4.75. Log of conjugate acid. Sir, ammonia is a base. Ammonium is the conjugate acid. So 0.2 by 0.1. And sir, log 2 is 0.3. So answer is 4.75 plus 0.3. 5.05. So pH will be 14 minus 5.05. So 8.95. Don't check these solutions. These are too lengthy. Final answer 8.95. So make sure the methods we have told you in all the campuses I'm talking about here. Doesn't matter which campus you are sitting in. All the methods are going to be almost similar throughout the Gosalites. Make sure use that method rather than the lengthy ones which NCERT is giving you. You're not writing IP examination. Time is the main problem. Then degree of ionization alpha, they are asking you pH of ammonia, ionization constant has to be taken from 6.7. Same question. They are saying that Kb they are giving you, alpha they are asking, pH they are asking, and concentration 0.05. Simple. So firstly you can find POH, half of PKb minus log C. And then you can put OH minus equal to C alpha. C also you know again. OH minus will find from here because POH will come. Actually, you know, pH equal to 5. So H plus will be 10 power minus 5 molar. So POH you will get, OH minus you will get. Put OH minus, put concentration, alpha will also come bhai. Lollipop questions hai yaar ye. Done, 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 done. Calculate the pH of 0.1 molar ammonia solution. Calculate the pH after 50 ml of this solution is treated with 25 ml of HCl. So first part of the question is a direct weak base. See, very good question. First question is calculate the pH of 0.1 molar ammonia. Kb given 1.77 10 power minus 5. So pKb will be 5 minus log 1.77. I know log 2 is 0.3 and log 1.77 will be somewhere 0.2 something like that. So for simplicity I am taking 4.8 pKb. Then for ammonia POH is half of pKb minus log C. I will apply and I will get POH. That is going to be half question, easy one. Second half is very interesting, for which I picked this question up. 50 ml of this solution of ammonia is reacting with my favorite HCl. Remember something called as Dumas-Geldal methods. In that also this reaction was used. You will get ammonium chloride. Clear by? How many moles of ammonia? 50 ml 0.1 molar, 5 millimole. HCl 0.1 molar, 25 ml, 2.5 millimole. This is my LR. My LR is my love of my life after my wife. So 5 minus 2.5, 2.5 will come. This is 2.5. How, sir? Stoichiometry. Sir, can you say one more time? Already said. Moving on. So this is my base. This is my conjugate acid. Now what to do? Now chill, enjoy, relax and understand it's a buffer. Understood, my dear buffer. POH is equals to pKb plus log of conjugate acid by conjugate base. And this is maximum buffer capacity. When conjugate acid, conjugate base are equal, it is called maximum buffer capacity. Best buffer right now, bhai. Maximum change in the maximum resistance to the pH change it can show. So POH is 4.8, pH will be 14 minus 4.8. Don't forget to subtract this here. Many a times it happens, people forget to subtract. They take 4.8 and then they enjoy, and after that, after the exam, they are doing shit. So don't shit in the examination, so you will not have to say shit after the examination. Clear, bhai? Understand this question. Ammonia with HCl reaction going on. I'm solving with moles only. I can directly put moles in the Henderson equation. My life will be going very awesome high. So this is long Mahabharat Ramayana method of NCERT. You can ignore. Moving on. pKa of acetic acid, ammonium hydroxides are this and this. Calculate the pH of ammonium acetate. Now it's a salt. Ammonium acetate is a salt. For salt, pH is equals to half of pKw plus Ka, Kb both are there. So Ka add, Kb subtract, and log C plus also minus also. So log C I will take as 0. Why? Plus log C minus log C. Ka to plus log C. Minus pKb to minus log C. Both are there. I remove it. So pH will be half of pKw plus pKa pKa 4.76, pKb 4.75. लो भैया, so elegant, so beautiful, just looking like a cow. अरे से यार, तो 14.01 by 2. क्लियर है? तो 7.005. So Duffer solution heading is later, but Duffer solution they have given before. Yeah, that's what NCERT is all about. This table, make sure that you remember. Yeah, soluble more than 0.1 molar solubility is soluble, slightly soluble between 0.1 to 0.01, and sparingly soluble less than 0.001. Move on. Solubility of A2X3 in the pure water is this. Assume that D the solubility product. Clear, bhai? KSP they have given you, solubility you have to find. So A2X3, remember 2 power 2, 3 power 3, S power 2 plus 3. That is KSP for pure solution. So 2 to the 4, 3 3 to the 9, 3 27, 108. S power 5 is 1.1 10 power minus 23. You can find S roughly here. KSP of two sparingly soluble salts are given to you. Which is more soluble? To understand, if they are giving you KSP for solubility comparison, never compare KSP directly. Then sir, what to do? Find S. For example, nickel hydroxide is 2 into 10 power minus 15 NiOH whole twice. 1 power 1, 2 power 2, S power 1 plus 2. 1 power 1, 2 power 2, 4, S power 2 plus 1, 4S cube. So ये खटाक ignore, S will be 10 power minus 5, something like that. For AgCN, KSP is 6 into 10 power minus 17. So 6 into 10 power minus 17 is AgCN. 1 power 1, 1 power 1, S power 1 plus 1. So S will be 10 power minus 8.5. So which is more solubility? So this solubility is more than this. So nickel hydroxide is more soluble than AgCN. So never compare KSP directly. Find S for all of them and then only compare. Badhiya. So elegant, so beautiful, looking like a cow. Calculate the molar solubility of nickel hydroxide in 0.1 molar NaOH. So bhaiya, nickel hydroxide is the sparingly soluble salt. So I will write his equilibrium. And this is going to be S, this is 2S. Stoichiometry 1 to S, stoichiometry 2 to S. Solubility is S here. KSP will be, it is equilibrium constant, product by reactant power stoichiometry, and reactant is a pure solid, active mass 1. Equilibrium going on. They are telling me KSP is ionic product of nickel hydroxide is 2 10 power minus 15. Nickel 2 plus will be S. But remember, check bhai, voice coming. Once check, audio video clear. Audio video clear. Once check. Badhiya. So now we are starting with the class senior interphysical chemistry topics. 3 are there. Chinna topics: solution, kinetics, and electrochemistry, along with redox. Chaliye. So number 1, in the solution chapter, table number 1.1, a very good match the column question can come. And as usual, I will highlight the main thing here. Whenever you are dissolving solute and solvent, forming the final solution, then the state of solvent and solution will be same. For example, sodium amalgam is actually NaHg alloy, where sodium is a solid, mercury is a liquid, we know. But the amalgam alloy is a solid. And because amalgam alloy is a solid, solution is a solid, then the solvent must be solid. So mercury is not the solvent here, sodium is the solvent. How to know? Product will be solid. That means the solution is solid. That solvent must be solid. So this table see once. Example from here, match the column questions can come. Then you have concentration terms here. Try all these questions of concentration terms, bhai. Okay, bhai. Now, solubility of solid in liquid. देखो भैया, solubility is like marriage. Solubility is like arranged marriage. Depends on 4 factors: husband, wife, how much fire they have to get married, and obviously parental pressure. These are the 4 factors deciding the solubility: husband, wife, how much is the fire to get married, and the pressure of the parents here. Marriage, marriage. So here, if the solid and liquids are there, they are almost incompressible. They are very rigid. They are not affected by pressure. Clear, bhai? So out of solute, solvent, temperature, pressure has no role in the solid or liquid solubility. For gaseous solubility, Henry's law will come. Anyway, temperature, what the effect of temperature is going to be? It is going to be Le-Chatelier principle. So for example, a solid dissolves in aqueous medium in water to form aqueous medium, and the delta H was negative. Exothermic reaction was there. To understand, T increases, temperature increases, reaction goes to endothermic direction. Endo means heat absorbed. So heat, temperature increase, it will eat the heat. But it is exothermic direction forward. Clear, bhai? So if the delta H is negative, then if temperature is less, reaction go to exothermic direction. That is forward, so solubility will be more. Similarly, if delta H is positive, then on decreasing the temperature, on increasing the temperature, solubility will increase. So understand, for solid in liquid, the effect of temperature is decided by Le-Chatelier. And what's the Le-Chatelier principle saying? It says that on increasing the temperature, reaction goes to endothermic direction. Clear, bhai? And what about solute, solvent? Like dissolves like. Whenever marriage happens, like dissolves like here. Done, bhai. Ionic compounds soluble in water. Covalent compounds are soluble in organic solvents. Then solubility of gas and liquid is decided by Henry's law. It says that, statement is important, the solubility of a gas and liquid is directly proportional to the partial pressure of the gas present above the solution. That means if this is the liquid, this is the gas. So if you apply the pressure, so pressure of the gas is proportional to the mole fraction of the gas in liquid state. In other words, if the pressure of the gas is more, so more gas will come in contact with the liquid and more gas will dissolve in the liquid. Simple hai na? Pressure, marriage. More pressure, more marriage. So partial pressure will be KH into X, mole fraction. Mole fraction of gas in liquid. That is a partial pressure of gas. KH is Henry's constant. Now, this is the solubility, depends upon 4 factors. For gas, it depends upon pressure, how much is the fire to get married, solute and solvent nature. Out of which in this formula, pressure undi, temperature, solute, solvent ledu. So all these 3 factors must be included in KH. So KH must depend upon solute, solvent and temperature, but should not depend upon the pressure. Now, if your maths is very poor, you might feel, sir, KH and P to proportional na? They are not proportional. KH is the constant of proportionality. So KH is not proportional to P, or P is not proportional to KH. It is a constant of this proportionality. P proportional to X, X proportional to P. So KH proportional to temperature directly. Remember that. Temperature more, Henry constant will be more. And solubility proportional to temperature inversely. Sir, you were saying temperature something here, check clear. Ha. This is for solid in liquid. Solid solute, dissolve in liquid solvent. This is for gas in liquid. For gas in liquid, solution enthalpy is going to be always exothermic. It is like condensation. Condensation is a process of gas becoming liquid. And that is always going to be exothermic. And as we know, at low temperature, reaction go to exothermic direction. So if the enthalpy of solution is negative, so we say that solubility is proportional to the temperature inversely for gases. That's why aquatic lives are more comfortable. Fish and all, they are more comfortable at the cold temperature. Why? Because in the cold temperature, more oxygen will be dissolved in the water. Oxygen is a gas, O2 is a gas. It will dissolve more in the water in low temperature. That's why at low temperature, the aquatic lives are able to do more respiration. Henry's constant, first question. If nitrogen gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter water? To understand what they are asking you, they are asking how much will be nitrogen gas dissolved in 1 liter water, or we can say solution. Assume that nitrogen exerts a partial pressure of 0.987 bar. Partial pressure of nitrogen is around 1 bar. I am taking chalo for simplicity. Henry constant for nitrogen is 76.48 kilobar. Henry constant I am taking 75 kilobar approximately. Then that's all. So I will apply the formula. Partial pressure of nitrogen will be KH into mole fraction of nitrogen in liquid. So mole fraction of nitrogen in liquid I can find first. Partial pressure of nitrogen 1 bar. KH will be 75 kilobar. Kilo, 1000. Then by, so 1 by 75 into 10 power minus 3 in the numerator. Done bhaiya? That's a mole fraction. But they are not asking me mole fraction. They are asking me moles in 1 liter. So let's do interconversion question. Let's compare. Try to recall in the first part of this same lecture. I taught you how to extract the data. So moles of nitrogen by total moles. So moles of nitrogen are 10 to the power minus 3 and total moles are 75. So moles of nitrogen came 10 power minus 3 mole in 75 mole water or solution. Now why I am saying water or solution? Because nitrogen is negligible. Na? Nitrogen is only 10 power minus 3, 0.001 mole and total moles are 75. So water will be 74.999, around 75 bhai. Clear? So putting the value here, around 75 moles of water is there, but I don't want moles of water. They are giving me volume, 1 liter water. Clear bhai? They are talking about 1 liter water. So 75 moles of water I will convert into grams. So 75 into 18 gram, moles into molar mass. And if I know mass, and density of water I know is 1 gram per ml. And density is mass by volume. And if I know mass, I know volume because density is mass by volume equal to 1. So for water, mass and volume is same. So the volume of water is 75 into 18 ml. Question over. How, sir? Simple. 75 into 18 ml Mancini contain how much nitrogen? Sir, 10 power minus 3 mole nitrogen. Can I say 1 millimole nitrogen, bhai? So I need to find in 1 liter. So this much ml, 1 millimole. So 1 ml contain 1 by this much millimole. So 1000 ml, that is 1 liter they are asking now, contains 1 by 75 into 18 into 1000 millimole. And that's the answer. Tough question, obviously tough question. But a good one to understand interconversion one more time. Check once what we have done. We found the mole fraction. Up to here my Henry law over. After that again concentration terms start. So Henry's law over. From there I extract the data. I found moles of nitrogen in how many moles of water, how many grams of water, how many ml of water. So this much ml, this much moles, 1000 ml, how much moles? 3 workers can make a wall in 5 days. How many workers will make the wall in 7 days? Mathematics. Clear, bhaiya? Then, in test question, both are same. Try to do that. Question number 1.5 solved example. Vapor pressure of chloroform and dichloromethane at 298 Kelvin are 20415 mmHg. Calculate the vapor pressure of solution prepared by mixing this and this. So, देखो भैया, this is liquid in liquid, भाई. Liquid in liquid is Raoult's law. So, according to Raoult's law, partial pressure of A is PA naught XA. This is partial vapor pressure of A. This is vapor pressure of pure A. And that is the mole fraction of A. Dalton's law, if I apply, that means total pressure if I am finding, it will come PA plus PB. And according to Raoult law, PA is PA naught XA and PB will be PB naught XB. Putting the value, PA naught 200 into mole fraction of A. Who is A? A is 25.5 gram chloroform. So chloroform molar mass is 119.5, given mass by molar mass, moles came 0.2 moles roughly. Similarly, 40 gram CH2Cl2 dichloroethane divided by molar mass 0.5 roughly. So I will say here 0.2 moles by 0.7 moles. Why, sir? Moles by total moles is mole fraction. Plus PB naught 415, around 400 torr I am taking, chalo 415 lo, into 0.2 by 0. Sorry, not 0.2, 0.5 by 0.7. That's how you will find the PT and the units are going to be mmHg. Say bhai, simple question. Second part of the question is they are asking find the mole fraction of each component in the vapor phase. For each component mole fraction in the vapor phase, let us say in the liquid XA, XB are the mole fraction, and when they evaporate, YA, YB are the mole fraction in the vapor phase. So YA is PA by PT, that is PA naught XA by PT. So YA will be PA naught XA by PT. Make sure you remember the formulas here. Very important. There are going to be only formula number 1, formula number 2, and third formula I am writing here 1 by PT is YA by PA naught plus YB by PB naught. This formula number 3. Only 3 formulas are there in the Raoult's law. The whole game is played by these 3 only. PA naught 200, XA 2 by 7, 0.2 by 0.7. Total pressure you will find from here. How much total pressure coming? Around 350 coming. So 350 I am writing here. On solving this is coming around 350. That's all. That's why A. Main thing in this Raoult's law, liquid-liquid solution is to apply the formula correctly. Done by. Understand one more thing. If, like for here, PA naught is less than PB naught. Can you see? Pure vapor pressure of A is 200 torr. and for the B is 415 torr. So who is more volatile? Wherever PB naught value is more, P naught value is more, that is more volatile, more evaporated. So my question is, in the vapor phase, who will be more richer? Obviously, the person who is more volatile, will more evaporate, will be richer in the vapor phase as compared to the liquid phase. So that's what the NCERT is writing after this solved example. This statement. At equilibrium, vapor phase will be always rich in the component which is more volatile. Then a statement question can come. Raoult's law is a special case of Henry's law. See, compare the formulas, you will understand. Raoult's law formula is PA equal to PA naught XA, and Henry law is PA equal to KH into XA. So it's a special, Raoult's law is a special case of Henry's law where KH equal to PA naught. Done, bhai. That's the paragraph they are writing here. Next, this kind of a graph you are going to get for a non-volatile solute. Dekho, if you have volatile solute, so liquid, so the graph is going to come like this. This is going to be PA, this is going to be PB, and this total is going to be PT. This is how the graph will come. But if you have solid in liquid and solid is non-volatile, non-volatile means no evaporation. That means P naught B is 0. So then you have only PA, you don't have PB. And PA is the PT. Because PT is PA plus PB, na? So if PB will be 0, if the PB will be 0, then only there is one pressure, that is PA. So this is how the graph would look like. So this is the graph for non-volatile solute. So make sure you write in your NCERT also over this graph, write non-volatile solute. Then ideal, non-ideal solution, bhaiya. Ideal solution means same kind of attraction before and after mixing. Non-ideal solution means attraction will be more or less than before after mixing. Dekho. So for example, you are mixing A and B, and the new attraction is less. That means A and A attraction, B and B attraction was more. A and B attraction together, they are not very happy. So they will easily evaporate. They are not very happy together, so they will easily evaporate. So when they easily evaporate, their vapor pressure will come more than expected. This is called positive deviation. And remember, very simple trick I'm telling you, for positive deviation, delta H, delta V both are positive. Delta H positive, endothermic, delta V positive means 1 liter A, 1 liter B will not give you 2 liter solution. It will give you a little more than 2 liter solution. And the example is, see, so beautiful example, alcohol plus anything. So sir, if I add 1 liter alcohol in 1 liter water, I will get more than 2 liter solution. Huh? Yeah. Clear hai bhai? Dekh rahe ho? How much good of a business. Chadda business, but good business. Money wise good, moral wise chadda. Alcohol plus anything is positive deviation. Ethanol plus water, ethanol plus acetone, anything. Methanol plus water. Acetone plus CH2 is positive deviation. Acetone plus chloroform, negative, because of hydrogen bonding formation. So acetone has dipole-dipole interaction with acetone. Chloroform, dipole-dipole. But chloroform, acetone have hydrogen bonding. The new attraction is better. So it's a negative deviation. And how to remember all the examples of negative deviation? Acid plus water, HCl plus water, sulfuric acid plus water, acetic acid plus water, formic acid plus water, any acid plus water. Alcohol plus anything, positive deviation. Acid plus water, negative deviation. Delta H also negative, delta V also negative. Delta change in the volume also negative. Clear, bhai? Phenylenediamine is the extra example you have to remember for negative deviation. Chaliye, moving on. Then, this question is a direct question of Raoult's law. You can see once orally. Vapor pressure of pure A and B, PA naught, PB naught, I am giving you 450 and 700 mmHg. They are asking XA, XB if the total pressure is 600 mmHg. So remember, PT equal to PA naught XA plus PB naught XB. And because XA plus XB is 1, I can create another formula. Let's call it BABA. बी ए बी ए बी ए बी ए, तो पीबी नॉट माइनस पी ए नॉट इंटू पीबी नॉट पीबी नॉट माइनस पी ए नॉट इंटू एक्स बी प्लस पी ए नॉट. तो एक्स बी इज ओनली वन वेरिएबल लेफ्ट, पीटी गिवन टू यू, पी ए नॉट गिवन टू यू, पीबी नॉट गिवन टू यू. एंजॉय पार्टी भाई पार्टी. क्लियर भाई, पार्टी हो रही है पार्टी. Vapor pressure of pure benzene at a certain temperature is 0.85 bar. Pure benzene 0.85 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram. So WB 0.5 gram. Added to 39 gram benzene. So WA weight of benzene is 39 gram. Molar mass 78 gram. Chalo, we know that. Vapor pressure of solution is 0.845 bar. Oh ho. Vapor pressure of solution they gave 0.845 bar. Now remember, it's a non-volatile solute. So for this, we are going to use RLVP. Don't use Raoult's law. Raoult's is for volatile solute. Liquid. This is non-volatile solute. So here, I will apply P naught minus PS by P naught is equals to XB, mole fraction of P. Now, P naught 0.85 given in the question, PS 0.845 by PS or P naught. Actually, precisely PS if I write, perfect answer will come. But approximately if I'm doing approximately I NB by NA for very dilute solution, we can say that. That's how NCERT solved it. Moles of B given mass by molar mass. We have to find molar mass. And moles of A given mass by molar mass, we know molar mass. So this will come 0.005 by 0.85 is equals to 0.5 into 2, because this will come 1 by 2, 2 will go up, that is 1 by m. So molar mass came 850 by 5. So 5 ones are 5, 6, 7, 8, 5 sevens are 35. So 170 gram per mole. That's the molar mass. Check bhai. So because non-volatile solid solute was there, so I applied RLVP, relative lowering in vapor pressure. Very important question. Check this too. This one. 18 gram of glucose is dissolved in 1 kg water in a saucepan. At what temperature will the water boil? At 1.013 bar, Kb is given to you. So again, delta Tb is I into Kb into m. That's the formula. Elevation in boiling point. So delta Tb is Vent-Hoff factor 1, if nothing mentioned, because glucose and fructose, sucrose, for them, we take Vent-Hoff factor 1. I'll talk about that also. Again, Kb is 0.52 Kelvin kg per mole. So molality will be moles of solute, 18 by 180 moles of solute by weight of solvent in kg. So this will get divided 10 times. So 0.052 degrees Celsius, that's elevation in boiling point. So boiling point of solution minus solvent is delta Tb. So boiling point of solution will be, how much is the boiling point of water? 100 degrees Celsius. And how much is the elevation? So elevation in the boiling point, increase in the boiling point, that came 0.052 degrees Celsius. So 100.052 degree Celsius. Check bhai. And remember one more thing. 100 degrees Celsius is 373.15 Kelvin. Don't forget this 0.15. This 1.15 extra, because people mug up 273 Kelvin 0 degree. No, 273.15 Kelvin is 0 degree. Keep that in mind bhai, especially for this topic. Done. Next, the boiling point of benzene is 353.23 Kelvin. Example 1.8. So boiling point of benzene they have given me 353.23 Kelvin. 1.8 gram of a non-volatile solute was dissolved in 90 gram benzene. So weight of solute is 1.8 gram. Molar mass I don't know, we have to find that probably. And weight of benzene is 90. Clear bhai? And molar mass of benzene is 78 gram per mole. The boiling point is raised to 354.11 Kelvin. Okay? So boiling point is raised to 354.11. So how much is delta TB? 354.11 minus 353.23. So 11 minus 3, 8. 10 minus 2, 8. 0.88 degree Celsius or 0.88 Kelvin, delta TB. Applying the formula, delta TB is I into KB into M. What they are asking me? They are asking the molar mass, I think only. Calculate the molar mass of solute. Yeah. So delta TB 0.88. Went off factor 1. KB given as 2.53 for benzene by. Molality, moles of solute 1.8 by molar mass. Given mass by molar mass. Weight of solvent in kg, because kg not given, I'll multiply with 1000. That's all. So the molar mass will come 2.53 into 1.8 into 1000 by 90 into 0.88. This is coming as 58. Check bhai, simple hai? See, so beautiful questions, direct questions are there, then why to ignore that? See, very important conceptual point. Kf and Kb, cryoscopic constant and ebullioscopic constant. They are R into molar mass of solvent into freezing point of solvent square by 1000 into enthalpy of vaporization or fusion. For freezing point fusion, for boiling point vaporization. So you can understand molar mass of solvent, boiling point and freezing point of solvent, delta H of the solvent, all these decide Kb, Kf. And Kb and Kf is the part of the formula here. So Kb is decided by solvent and delta Tb is decided by Kb. So can I say elevation in boiling point and depression in freezing point depend upon the solvent? Say yes or no. Delta Tb, delta Tf, these two colligative properties, elevation in boiling point and the depression in freezing point, they depend upon the solvent. Yes or no? In case you have mucked up, the colligative property depends only upon the nature, number of solute particles. If you have just mucked it up, then your heart will say, nahi sir, colligative property na. But if you are conceptually understanding the concept, you will realize, ha sir, about solute, I remember I have mucked up. It does not depend upon nature of solute. But delta Tb, delta Tf, boiling point, elevation, depression and freezing point, they depend upon the nature of solvent, bhai sahab. RLVP, osmotic pressure, will not depend upon solvent. But delta Tb, delta Tf are clearly depending upon solvent because Kb depend upon solvent. Freezing point question, let's see. 45 gram ethylene glycol mixed with 600 gram of water, calculate the freezing point depression. So just for the time pass, we can do this question also. Ki delta Tf is equals to I Kf into M. Delta Tb, we have to find ethylene glycol. This is anti-freeze. You can circle that and write anti-freeze, ethylene glycol. Kf, not given, to take 1.86 for water. Molality. Molality will be moles of solute, 45 by 60. Given mass by molar mass, 62. Given mass by molar mass. Divided by weight of solvent in kg. That's all. Delta Tf will come. Then bhaiya, so like delta Tf came 2.2 Kelvin. So how much is the freezing point? So freezing point of solution. See, 0 degree Celsius is freezing point of water. Depression is coming 2.2 Kelvin. Clear bhaiya? For delta T na, Kelvin and degree Celsius are same for delta T. So minus 2.2 degrees Celsius is the freezing point of solution. Then bhai, question number 1.10 you will try yourself. Same question, direct question, but very important for the NEET examination. Very important. This can come in the NEET exam because answer is also a whole number. Practice that in the study are very simple direct question. Osmosis is the spontaneous movement of solvent particle from low concentration solution to high concentration solution. Only solvent particles will move. So all those questions of red, blue, semi-permeable membrane, where the color will be coming, not coming, all those things we have done. Focusing upon the NCERT main question. 200 centimeter cube means 200 ml. M centimeter cube. Protein contain 1.25 gram of protein. तो भैया weight of solute is given 1.26 gram. Osmotic pressure was found to be 2.57 10 power minus 3 bar. Temperature 300 Kelvin. They are asking find the molar mass of protein. बढ़िया same. So भैया we will do pi equal to ICRT. So pi is the osmotic pressure. Here the concentration C is in the terms of molarity. Molarity is moles of solute. 1.26 by molar mass by volume of solution in liter. The volume of solution is 200 ml, but in liter, so I multiply with 1000. So this is C. R 1 by 12 approximately, temperature 300. Over. Acha, osmotic pressure they have given, sorry. They have given the osmotic pressure. That is 2.57 into 10 power minus 3. Done bhai. Which is the best colligative property for the measurement of molar mass of protein and macromolecules and biomolecules? Osmotic pressure is the best. Why it is the best? You can see here. Because number one, molarity will be used, which is easy to find molarity. It can be measured even at room temperature, because elevation in boiling point measured at boiling point. Depression in freezing point measured at freezing point. The protein can get denatured. That's why we use osmotic pressure, that is better. Clear hai bhai? In test questions, try one, all of them are easy. Coming to the Vent-Off factor. Vent-Off factor I is number of particles produced on adding 1 mole, number of moles of particle produced on adding 1 mole solute. For example, 1 mole of glucose added, it remains 1 mole. But 1 mole NaCl will be added. You are going to get Na plus and Cl minus almost completely. So 1 mole of NaCl is going to give you 2 moles of particles. That is your Vent-Off factor. But remember always, कि भैया we know concentration less, alpha will be more, and if alpha will be more, I will be more. Because I is 1 plus n minus 1 into alpha. So alpha more, I will be more. So on this table is there, yaar. See, NaCl is a strong electrolyte, but see the data they are giving you. कि 0.1, 0.01, 0.001. Concentration less, I will be more. Approximately 2 only, but some variation will be there. Exactly 2 will not come. So if they ask you this kind of a question to compare Vent-Off factor of NaCl at 0.1, 0.01 and 0.001 molar, don't take all of them equal. JEE main asked this question in 2023 by approximately 2, but not exactly equal. So for example, this question is there, 2 gram of benzene. This is tough calculation. TC means tough calculations. So you can see the method properly once. 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point 1.62 Kelvin. So 1.62. Vent-Off factor I don't know. Kf 4.9. Molality 2 gram benzoic acid. Molar mass of benzoic acid we will put here. Okay, by given mass by molar mass. By weight of solvent 25 into 1000. Check bhaiya. Check. That's how you will get Vent-Off factor I. Done bhai? That's how you will get Vent-Off factor I. So benzoic acid, roughly 240 I can take here, molar mass of C, 6 H5 COOH. So once you get Vent-Off factor I, it will be 1 plus n minus 1 into alpha. How to find n? So what we are doing right now, we are putting benzoic acid in benzene. So whenever you are putting benzoic acid in benzene, it will dimerize. So 2 benzoic acid will become a dimer. And n will be product by reactant. N, here n will be product by reactant moles. So product are 1, reactants are 2, to 1 by 2. Or you can say for dimer 1 by 2. So you will get here I is equals to 1 plus 1 by 2 minus 1 into alpha. So 1 minus alpha by 2. So Vent-Off factor I is 1 minus alpha by 2. You will get Vent-Off factor from here. Alpha they are asking you. Check bhai. I prefer not to give 2 different formulas for Vent-Off factor for association and dissociation. if you understand N will be NP by NR, product by reactant, stoichiometry. It will work for dissociation also, association also. Done, bhaiya. So try this question once, tough calculation, but you'll be able to do it. Same thing here also, tough calculations, but easy question. Acetic acid in water. So remember that when you have acetic acid or benzoic acid, whatever, in water, it will dissociate. And your Ventov factor will come more than 1 because particle 1 mole break to form more moles. So more number of particle forming. But the same acetic acid in benzene, it will not dissociate. It will associate. Clear, bhai? Forming a dimer. So here the Ventov factor will come less than 1. Here the value of N will be 2 by 1. Here the value of N will be 1 by 2. But the formula will be same, 1 plus N minus 1 into alpha. Done, bhaiya. Now, these are the questions we'll be trying. TP means topper problems. If you want to become a topper and your elementary theory is done, then only try these questions in the study R2A 1.18, 1.19, 1.20, 1.21. Some of these questions I gave in the exam also. To 1.18 to 1.21. All these questions are for the topper. Next, 1.23, 1.24, 1.25. These three are the questions where people are ignoring them. But now for this year, these questions are very important because previously, states of matter was also in the syllabus. So these were very easy at that time. But now, because states of matter is not in the syllabus from last 2 years, these questions can be difficult. Let's see. They're asking which kind of intermolecular attractive interactions are there. So hexane, octane, both are non-polar, and non-polar people have London dispersion force. You can write somewhere in the notebook also, non-polar London dispersion force. So iodine CCl4, hexane, octane, they both have London dispersion force. NaClO4 and water. Dekho, NaClO4 will dissociate to form ion, and water is a dipole. So ion dipole interaction. Methanol and acetone. So methanol will have hydrogen bonding alone, but methanol plus acetone both will have dipole-dipole interaction. This is wrong. It should be dipole-dipole interaction. Clear, bhai? This is not hydrogen bonding. Hydrogen bonding is only methanol. Aaja, bhai. So you can write it. You can cut this hydrogen bonding. You can write here dipole-dipole interaction. Yeah, okay. Because both are dipoles. Only methanol, hydrogen bonding. Then acetonitrile, acetone, both are polar, again dipole-dipole. 1.24 answer is given at the back in NCERT, so I don't have to worry about it. Clear, bhai? Logic only I am telling you. In octane, they are asking the solubility. In aqueous medium, more ionic are more soluble. But in an octane, organic solvent, more ionic is less soluble. Like KCl is most ionic here, so least soluble. Cyclohexane is non-polar, so most soluble. So check the answer from the back. NCERT exercise at the back. 1.25 meanwhile, dekho, they are asking which are insoluble, partially soluble, highly soluble. This question also I asked, but a simpler version I asked here in the recent revision pace examination. Why easier? So that you are not getting stuck while getting, means marks also matter, na? Plus at the same time wanted you to open NCERT. So now when we are opening NCERT and showing, then why not? Remember this properly, bhai. Insoluble, partially soluble, highly soluble. So dekho, phenol partially soluble. Why? OH group there. So hydrogen bonding possible. But hydrophobic benzene also there. So completely not soluble. Toluene, insoluble. Chloroform, insoluble. Sir, why chloroform insoluble? By chloroform, you remember layers test. It forms a separate layer in presence of water. So insoluble. Formic acid, hydrogen bonding also. Chala amount. Plus it will dissociate also to give you H+. So because of double bumper bonanza and there is no long hydrophobic tail, it's highly soluble. H means highly soluble. Ethylene glycol contains 2 OH. So good hydrogen bonding. And hydrophobic tail is only 2 carbon. So highly soluble. Pentanol. Pentanol, long hydrophobic chain of 5 carbon. Amyl alcohol. and OH group, hydrogen bonding. So partially soluble because of OH and not highly soluble because of hydrophobic tail. Badhiya. Moving on, electrochemistry. Chaliye bhaiya. Number 1, how would you determine the standard electrode potential of the Mg2 plus Mg using SHE and salt bridge? So using the standard hydrogen electrode SHE, I can find the electrode potentials of other half cells. Can you store copper sulfate in zinc pot? No. The container in which you are storing the substance, that metal should not be more reactive than the metal in the salt. And zinc is more reactive than copper. What is the reactivity series? Remember, reactivity series is Sul. Sul means S block plus aluminium. Then zinc, iron, tin, lead. Then hydrogen. Hydrogen is even more reactive than copper. Happa. Copper happa. Hg, Ag, Pt, Pd, Au. These are least reactive people, bhai. Then moving on. These two lines are very important. Tick these two. JEE Main asked this question 2023. A negative E0 means the redox couple is a stronger reducing agent than hydrogen couple. And a positive E0 means redox couple is a weaker reducing agent than hydrogen couple. This statement you should be knowing. Concept is very simple. If SRP is more, oxidizing agent tendency more and reducing agent tendency less. And for hydrogen electrode, the SRP is 0. He is my reference electrode. For him, SRP taken 0, assumed 0. So because of that, what happens? If hydrogen is 0, so person negative means less SRP. Less SRP means better reducing agent. Hydrogen 0, so positive SRP means SRP more, reducing agent nature less. That's what they are writing, but the statement is difficult to understand sometimes when it comes directly in the examination. So be mentally prepared. This question is there. They are asking E cell, E0 cell they are giving you. Clear hai bhai? Are? क्या प्रॉब्लम है भाई? Oh, unknown reason program has closed. I think too many slides got filled. Kya? That's why the program got closed. Chalo, no problem. Badhiya. Program opened. Yeah. So in this question they are asking E cell if E0 is 3.17 volt. So we know first equation E equal to E0 minus 0.059 by N log product by reactant power stoichiometry. That's the NCERT formula. You can put the plus also log P by R power stoichiometry, R by P power stoichiometry, but for that remember that is not in NCERT. That is the modification we are doing for understanding some questions. So now E equal to E0 minus 0.059 by how many electron transfer? So magnesium to Mg2 plus 2 electron transfer. 2 log product 0.13 by reactant 0.001, you will get the answer. But they will give you the log value, so don't worry about it. Equilibrium constant from this, dekhe. For this the formula is, if I take equilibrium, at equilibrium E will become 0. E cell will become 0 at equilibrium. So we know that E is equals to E0 minus 0.059 by N log Q. And at equilibrium, E becomes 0. Equilibrium means no reaction happening at that moment here. So there is no voltage generated. And I told you just now Q equal to K. So Q equal to K. Shifting it on the other side. So E0 will be 0.059 by N log K. That's the formula. Putting the value, E0 is 0.46. Hello, 0.46. This by sum. 0.059 by N, copper to copper 2 plus, 0 to plus 2, change of 2, log Kc. So on solving this, log Kc came 15.6. From here, how to find Kc? So log K is 15.6. So can I say it is 15 plus 0.6? 15 will be log 10 power 15. So log 10 power x is x. So 15 is log 10 power 15. And 0.6, if you remember, is log 4. So log a plus log b is log a into b. Now both side log k, you can take the anti-log, so k will be 4 into 10 power 15. So 3.92 given, so approximately 4 here. Clear, bhai? Delta G minus NF E cell, standard electrode potential of Daniell cell is 1.1 volt. Standard electrode potential SRP 1.1. Calculate the standard Gibbs energy change for the reaction. So delta G naught they are asking, minus N, Zn to Zn plus 2, change of 2. So minus 2 into 96500 Faraday into E naught cell 1.1. You will get the answer in joule per mole. This question, NEET 2025 question, I feel. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. So for this question, remember a direct shortcut. For hydrogen electrode, ERP, reduction potential, is minus 0.059 into pH. And EOP, oxidation potential, will be plus 0.059 into pH. So for example, pH is 10. They are asking the electrode potential. If they don't mention which potential, if they just say electrode potential, it means reduction potential. This is the IUPAC convention. If they don't mention which potential, take it reduction potential. So they are asking the reduction potential at pH 10. So my answer will be minus 0.059 into 10, so minus 0.59 volt. Simple, straightforward. 2.5, 2.6, both are direct Nernst equation question. Just now you have solved, and this equilibrium constant delta G naught. Try these two. Then conductance and the measurement. So few points. Number one, electrical conductance depend upon which factor? Electrical conductance, electronic conductance also. There is a conductance in physics. Wire, metal wire. Charge carriers are electron. Depend upon nature and the structure of metal. Number of valence electron per atom, more valence electrons, more electrons are there, so better charge conductance will happen. And temperature. Third point is important. In physics, if temperature increases, resistance increases, conductance decreases. But in this chapter, we have to talk about ionic conductance. Firstly, this value, underline 3.5, 10 to the power minus 5 Simon meter inverse. Underline and write there kappa water. It is a kappa, conductivity for water, bhai. So make sure write that in the notebook, sorry, in the NCERT. Then for ionic conductor, depends upon the nature of electrolyte. If the electrolyte is water, which is a good solvent, nature of electrolyte. Electrolyte is, let's say, strong electrolyte like NaCl. It will dissociate completely, so more and more conductance will happen, and weak electrolyte like CH3COOH or AgCl, negligible ions will come. Ions are the charge carriers, ions are the hero. The electrolyte matters. A strong electrolyte, good conductance. Size of ion produced and their solvation. So who is the better conductor? Li plus, Na plus, K plus. So if I compare in aqueous medium, Li plus, Na plus, K plus. So bhaiya, Li plus will be most hydrated, surrounded by water. Na plus will be mediocre hydrated. K plus will be negligibly hydrated. So Li plus hydration tarvata, Li plus become very fat because of chala hydration. Movement become difficult. Clear, bhai? So due to solvation, top to bottom in periodic table, lithium plus, Na plus, K plus, conductance increases due to solvation, due to hydration, because smallest ion will be most hydrated, bhai. And when the small ions are most hydrated, they are surrounded by water. It is like I am racing and Shah Rukh Khan is racing. Abhi Shah Rukh Khan is surrounded by all his fans. Even though Shah Rukh Khan is fitter than me, I'll be able to win the race. Why? I'm fat, but I'm alone. So I can run easily, bhai. Understood the idea, bhaiya? Next, viscosity of the solvent, nature of solvent. So if the solvent is highly viscous, like honey, in honey movement will become difficult. In water, movement will be easy. Concentration of electrolyte, we'll talk about that. Temperature, if the temperature is more, here the conductance is more. For wire, at high temperature, resistance is more. But for ionic conductance, for ionic solutions, at high temperature, conductance will be more. Clear hai bhaiya? Measurement of the conductivity. So my fans are online only, na yaar, and the race is offline. Moving on. Measurement of the conductivity of ionic solution. Firstly, passing direct current, number one. If you are passing direct current, two problems will be there, bhai. If you are measuring conductivity, to measure conductivity of ionic solutions, there are two problems. Problem number one, if you apply DC, direct current, then electrolysis will happen. And second, like in the Wheatstone bridge, you might be knowing, na, this is in physics you have read, Wheatstone bridge. Here you don't pass any current. Clear, bhai? Then you take R1 by R2, R3 by R4 equal. But how you will connect a solution here? You cannot pour the solution here, na? So the solution is a liquid. So measurement of conductance, resistance by Wheatstone bridge is difficult. And second, if you pass direct current by battery, then the electrolysis will happen, ions will react. So what we do, we take one oscillator, which will give AC. So AC current we are going to use. And second, we will put this solution in a container, connecting the wire, and that container is called conductivity cell. So you can see here, reasoning question very important. Firstly, passing direct current changes the composition of solution. Secondly, a solution cannot be connected to the bridge like a metallic wire. The first difficulty is resolved by using alternating current source. And the second problem is solved by using a specially designed vessel called as conductivity cell. So this can come as a theory question. Moving on. How to measure L by A, cell constant? Cell constant is measured by, cell constant L by A is measured by physical measurement? No, because the measurement of L and A is inconvenient and unreliable. So we don't use measurement using inch tape. We use KCl solution, a solution of known conductivity. So remember, we use a solution of known conductivity. How to remember? For cell constant, getting cell constant known kappa KCl. यार तो known conductance ले दूं, K for known, K for kappa, conductivity known. So known conductivity KCl solution will be used for finding the cell constant, bhai. Can be a very important question. Then converting molarity into mole per meter cube you can do by multiplying with 1000. So example number 2.4 we can see resistance of a conductivity cell filled with 0.1 molar KCl solution is there, 100 ohms. This is R1. And R2 is 520 ohms. C1 0.1 molar and C2 0.02 molar. Calculate the conductivity and molar conductivity of this KCl solution. Conductivity of 0.1 is given this much. This is kappa 1. Kappa 2 they are asking. So I know that kappa is equals to C into L by A. L by A same because in the same cell constant same. So kappa 1 by kappa 2, C1 by C2. And conductance is 1 by resistance, R2 by R1. So kappa 1, 1.29, kappa 2, I don't know, resistance 2, 520, resistance 1, 100. So kappa 2 will be 129 by 520, Simon meter inverse. This is the conductivity of the second solution. Direct question, kappa 1 by kappa 2, R2 by R1. Then they are asking the molar conductivity also. For molar conductivity, what is the formula? See, bhai, anyone listening first time properly, I am giving you formula along with the question only. So like this formula note down, this formula note down, this formula note down. Kappa, lambda m at a concentration is kappa into 1000 by m. But this is when Simon's centimeter inverse and Simon's centimeter square mole inverse is the unit. But here the units are meter inverse. And for meter, I can have a formula kappa by concentration. So this is Simon meter inverse. This is Simon meter square mole inverse. and this concentration is not molarity, this is mole per meter cube. So I'm going to use my second formula. Lambda I will find in meter square, kappa is in meter. I have to convert 0.1 molar KCl solution. They are asking for 0.02 molar. I have to convert 0.02 molar KCl solution into mole per meter cube. Multiply with 1000. So 0.02 molar is 0.2 into 1000. So 20 mole per meter cube. Putting the value. So kappa is 129 by 520. Akada, Simon meter inverse. By 20 mole per meter cube. So that's your answer in Simon meter square mole inverse. Check bhai. So, so many symbols are there. So what can we do? Tough questions will also come. Easy will also come. Prepare for everything properly. Only one advantage is there. For today, tomorrow, only NCERT solved example in touch questions are the main thing. This question you will do, easy one. Easy question you will do, I'm leaving for you by. Only tough one I'm solving. Now here, this graph, lambda m versus root c graph. The slope of the straight line will be A. And the formula, if you remember, is lambda mc for a strong electrolyte. The formula is lambda mc is lambda m naught minus A root c. This A is the slope for a strong electrolyte. So when the concentration decreases for a strong electrolyte, mobility increase. Those who are new also, you can write it down. Concentration decreases, mobility of ions will increase. For weak electrolyte, mobility will increase, number of ions will also increase. So for weak electrolyte, there is a sharp increase. And for strong electrolyte, there is a consistent but linear increase. So which lambda increases more with concentration decreasing? This side, concentration less. That means dilution happening. So if the dilution happen, concentration decrease, weak electrolyte, strong electrolyte, both lambda will increase. But I'm trying to say that lambda m is proportional to concentration inversely for weak also, strong also. But where the change is more, weak electrolyte. Why? Because if you are having more volume, less concentration means more volume. So ions will move easily. Larger volume, larger space, bigger house, more mobility. For strong, weak, both. But for weak electrolyte, if volume increases, number of ions will also increase. Dissociation will increase. Weak electrolyte, na bhai? Understood? Ha bhaiya?
The voice not coming 5 minutes.
From last 5 minutes not coming, yeah? From how long not coming?
From today onwards.
2 minutes wait. Check. Chalo. Coming now. Voice coming? चलिए now lambda m versus root c graph is there. In this graph, you have lambda mc is lambda m naught minus a root c, y equal to mx plus c. So slope will be minus a. But this slope will be equal. They will be parallel lines if they are same type of electrolyte. Like KCl, NaCl, both are +1, -1, +1, -1, same type. So parallel line will be there. But which graph will be up? KCl up or NaCl up? So देखो, remember this K plus Na plus comparison? Top to bottom conductance increase in because of hydration. So K plus will have more conductance than Na plus. Okay now? Ravi, voice coming?
Not coming, sir.
Coming now? Okay. Done भैया. चलिए, moving on. This JEE in 2025 very beautiful question came. A question I'm not telling you it's a long question comparatively, but what the main sense is, in a very low concentration, that is the molar conductivity at infinite dilution, it cannot be measured accurately. Whether you take a strong electrolyte or weak electrolyte, we cannot measure lambda naught accurately, lambda naught, molar conductivity at a very low concentration, because negligible ions are there here per unit volume. So we cannot measure conductance easily for very dilute solution. Accurate answer will not come. JEE Main asked a question on this and the answer was cannot be measured accurately. They did dilution and then they asked the question. After doing dilution, infinite dilution, what will be the molar conductance? The answer was we cannot find accurately. Chaliye, moving on. Lambda naught of CaCl to MgCl2, let's do this question, 2.8, because there the data is not there in solved example. Lambda naught for NaCl, SCl, NaAcr, this. You have to find for HAC. Simple. It's target equation method. Now for HAC, who will give me H? So sir, this H will be given by HCl. So can I say this is equal to lambda naught of HCl? H came, but Cl came extra. Plus, who will give me AC? AC will be given by Daikin, voltas. Beta voice coming, Ravi told what happened?
Sir, connection is lost currently.
Where?
Up second class.
They will repeat that part of the video. Because if I delay, it will go beyond 1:30 p.m. Hai na? So if little bit problems are coming, 2-3 minutes I can hold. But more than that, if I hold, it's already 3:30. Na? Only inorganic is left. Electrical chemistry is left. Okay, bhai? Now, AC. Clear, bhai? AC. Who will give AC? Lambda naught NaC. Clear, bhaiya? Hello? Who came extra? Na plus. Now to remove this NaCl from the list, I have to decrease this NaCl from here to minus lambda naught NaCl. Minus to remove NaCl. So what happened? Na plus Cl minus removed. By this, only HAC left. So put the data. HCl data 126 plus NaAc data 91. Sorry, HCl 425, NaAc 91 minus 126. So around 390. This question came in NEET 2021, and then this question also came in NEET 2021. Both came back to back. Conductivity of 0.001028 molar acetic acid is 4.95. They gave you conductivity kappa 4.95. So kappa of acetic acid is given as 4.95 10 power minus 5. Simon's centimeter inverse. Calculate the dissociation constant if lambda naught for acetic acid is this much. So lambda naught is this much. Lambda naught. How much given? 390.5. What they are asking us? Dissociation constant. So here they are asking Ka, and I know K is C alpha square upon 1 minus alpha. So alpha ka wali. So for alpha, it is lambda mc by lambda m naught. How much is lambda mc? So lambda mc not given, sir, kappa given. Badhiya. So lambda mc I will find kappa into 1000 by m. Because units is centimeter inverse, na? So kappa into 1000 by m. So kappa here will be 4.95 10 power minus 5 into 1000 by molarity 0.001. So by this my kappa came 48.15 by lambda naught 390.5. So around 50 by 400. Roughly I can say it is 50 by 400. Understood? So around 1 by 8 is alpha. Alpha came, so Ka will be C alpha square upon 1 minus alpha. Again C is 0.0010, whatever they are saying, into alpha square, whatever you will get here, 1 by 8 whole square upon 1 minus 1 by 8. C alpha square upon 1 minus alpha. So how to find alpha? Lambda mc by lambda m naught. How to find lambda m naught? Colruy's law, which you learnt in the previous question. That was Colruy's law. And lambda mc you will find by kappa into 1000 by m. That's how alpha will come. Clear, bhai? Once give a quick yes if the voice is coming, bhai. Here, Penavaluru. If the voice is coming, give a loud yes. Coming? Voice coming? Okay. Now, very, 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 very important point. Why there was a need of the second law? So yeah, when Faraday was doing the experiment many years back, at that time a constant source of electricity was not there. Like the voltage used to fluctuate a lot. So to maintain a constant current source, they cannot maintain a constant current source. Sometimes more current will come, sometimes less current will come. So I cannot apply this formula. Na? This is the formula of Faraday. Molar mass by valency factor, IT by 96500 into percent efficiency of the current also, if you want, you can put here. Now, I cannot have a constant I. And we cannot integrate the I after every single second here. So what they did, what Faraday played smart, he made a device called as coulometer. Clear, bhai? A standard electrolytic cell, coulometer, for determining the electricity passed. So he was not finding I, he found IT by 96500. There is a charge in Faraday, he was finding that. This much Faraday is there, so Faraday will give his name only na, for the charge. So he was finding how much Faraday passing. So current was fluctuating, but the total charge he was finding how? By connecting a solution. For example, this is unknown. How I want to find here how much charge came. I connect this with a known solution in series. So whatever the charge will come here also. And that what we are connecting in series, you can see it is generally silver or copper metal. Clear, right? Silver or copper metal electrode, that solution was connected, that was known. Let's say silver. Here I connected this in series with the unknown, where I want to find the charge. Clear, right? And this amount we knew. For example, 108 gram. I know silver reaction, na? Ag plus electron give you Ag. So if 108 gram, 1 mole of silver deposit, so 1 Faraday charge is passed. So at the last he was checking how much silver got deposited. Let's say 216 gram came. So he knew that the charge passed was 2 Faraday. So coulometer was a device which was used for measuring the charge when there was no constant current. But now this is obsolete. Obsolete means useless. We now have constant current sources available and the quantity of electricity passed is given by I into T. So this can be a good statement question, generally ignored by most of the good students also here. Chaliye, focusing on 2.10, solution of copper sulfate electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited at cathode? At cathode, how much copper is deposited, they are asking. So W is equals to molar mass by charge, or we can say valency factor, into IT by 96500. Put the value, answer will come. So molar mass 62.5 something, 63 we can take. Charge on copper 2, I 10 minute into 60. Don't forget to put in seconds, bhai. Time. And current how much ampere? 1.5 ampere. by 96500. Solve it, the answer will come in grams. Because your molar mass is in gram per mole, na? 63. So answer will come in grams. Products of electrolysis. For the products of electrolysis, one shortcut I have taught you. You can apply that. Clear, bhai? What the shortcut is? For example, if you have aqueous, you can take ZnSO4. Using platinum electrode, we are doing the electrolysis. So remember, at anode and cathode, water will compete. Anion will be F minus or anion will be Sol. Sol means S block and aluminium. Water will win. In all other cases, water loses. So for example, aqueous zinc sulfate I am taking. So this is the method we are going to apply. So here I have Zn2 plus ion, I have sulfate ion, and I have water. I don't need data now. Sulfate I will cut. Remember that whenever you have sulfate, carbonate, or nitrate, phosphate, they are already in the highest oxidation state, you can cut them. If you have concentrated sulfuric acid, you will get H2OH 2 minus, that is Marshall. We'll talk about that also. But generally, sulfate in normal solutions I will cut. At anode, water and there is no anion. At cathode, water and the cation is Zn2 plus. If it was S block or aluminium, water will win. In all other cases, water will lose. Here, water will win. So what will form at cathode? Zn2 plus takes 2 electron, becomes zinc. At anode, water will become O2 plus 4H plus 4 electron. This reaction you need to remember. Method is there to remember it also, but this marathon is not the right time to tell that method. It's better remember a few things and move on. So for example, another question is there. Aqueous NaCl. So at the anode, water anion, cathode, water cation. This is S block. Sol versus water, water wins. F minus versus water, water wins. In all other cases, water loses. So here Cl minus become chlorine by releasing 2 electrons. And here water takes 2 electron, become hydrogen plus 2 OH minus, basic medium. This also you need to remember. Now the point is, as per SRP value, what is the SRP value saying? If the reduction potential is more, the substance should get reduced. If the reduction potential is less, that substance must get oxidized. So as per SRP, Cl minus must lose and water must win at anode. But due to over potential, extra energy required for the water to start reacting. Water is neutral, bhai. Water is neutral. Cl minus is ion. So water require little extra energy. Activation energy more required. That extra activation energy required for water to start the reaction. Meanwhile, Cl minus start reacting and Cl minus wins. So due to over potential, Cl minus wins. See the NCERT language. The trick I am telling you, this trick, it is going to work always. Doesn't matter Cl minus there or not there. This will always work. But the trick is F minus versus water, water wins. Mug up the reaction if water wins. Sol versus water, water wins. Mug up the reaction if water wins. Otherwise, in all other cases, water will lose with inert electrode like platinum or someone like that. But understand, with NaCl, they can ask you a conceptual question that the reaction at anode with lower E naught is preferred. Lesser SRP, less SRP, reduction potential less, so reduction will not happen, oxidation will happen at anode. So water should get oxidized. However, over the account of over potential of oxygen, for the oxygen over potential, that means the water will not react easily to become O2. Because of that, the water, because activation energy is more, neutral molecule, na bhai? So water will be not reacting properly, Cl minus will win. So this they can ask you conceptual question, ki as per SRP, who should get oxidized at anode? So as per SRP, water should. But in reality, in lab, who actually get oxidized at anode? Cl minus. Chaliye, this reaction 2.39, if sulfuric acid is taken concentrated, you will get H2O with 2 minus plus 2 electrons, otherwise no problem. Next, 2.10, 2.11, 2.12, right now we can see very good questions. Current 0.5 ampere for 2 hours, how many electrons would flow through the wire? So Q is equals to I into T. So current will be 0.5 ampere, how much time? 2 hour into 3600, this much seconds. So this is the charge in coulombs, I into T. Suggest a list of metal that are extracted electrolytically. Sul, S block, aluminium, from their molten salt. Not from aqueous, from molten. Consider this reaction. For 1 mole dichromate, how much coulomb needed? So for 1 mole, I need 6 Faraday. So for 1 mole dichromate, 6 Faraday kawali, 6 Faraday is 96500 coulomb into 6. Fasak. Easy. They can ask you, can we use any cell, any cathode anode combination whose delta G is negative? Can we use it as a cell, as a battery? No. A battery for the practical use must be light, compact, and the voltage must not vary too much. Clear, bhaiya? Make sure that you read the primary battery properly, secondary battery properly, rechargeable. For button cell, wristwatches, there is a constant voltage. Lead storage battery, this line underline and remember it. For lead storage battery, sulfuric acid is consumed during the charging of cell. All those things read once by. Direct theory hai, 5-10 minutes reading it will take, not 10-15 minutes reading it will take, but give that time, bhaiya. Theory question can come from here. This line is very important. Then bhaiya, fuel cell. What is a fuel cell? It's a galvanic cell which uses the combustion energy, combustion into electrical form they convert. Combustion into electrical form. So combustion of fuels like hydrogen, methane, methanol. Hydrogen, methane, methanol are the example of the fuels. In the reaction will be combustion reaction, will be converted into electrical energy. Done, bhaiya. Then chemical kinetics, one of the very good chapter where the solved examples and in-test questions can be directly asked in the NEET exam. Even data is also reliable. They can ask you the similar data also, kind of like solution chapter. For the concentration, this, they have given you, find the average rate of reaction. So dekho bhai, it is just like physics. Average rate is just like average velocity. So average rate of reaction, kinetics and kinematics are almost same. Delta C by delta T. So let us say we are finding from 0 second to 100 average. So delta C, how much is the change in the concentration? 0.08 minus 0.1. Clear, bhai? With a minus sign outside. Sir, why minus sign? This is reactant. Reactant get consumed. So final minus initial will come negative. But we need positive answer. So for rate of disappearance, disappearance means reactant reacting. For that we put a minus sign. Don't put much brain. Positive answer kawali. Anyhow get positive. By delta T, 100 minus 0, 100. That's the average rate in molar per second. Then by next, this Br minus BrO3 minus 6H plus. Now how to do? Rate of Br minus by stoichiometry is rate of BrO3 minus by stoichiometry is rate of H plus by stoichiometry, rate of bromine by stoichiometry, just like mole analysis. Just like the stoichiometry chapter, same thing, but this time with the rate. Always remember here I cannot put gram per minute because I have to put either mole or molarity or ATM, pressure. I cannot put gram. On gram, stoichiometry cannot be applied. Remember? Mole concept. Same logic works here. Question is, decomposition of N2O5 in CCl4 has been studied by monitoring the concentration of N2O5 in the solution. Initially, N2O5 is 2.33. After 184 minutes, it becomes 2.08. So, initial there, final there. They are asking average rate of reaction in terms of hours. So, dekho bhai. Here, rate of N2O5 will be change in concentration by delta T. So it is 2.33 minus 2.08. I have to get positive answer. So I'm doing larger minus smaller. Delta T, 184 minutes. So this is the answer in molar per minute. But this is the rate of N2O5. It is not the rate of reaction. Why, sir? Why? Reaction contain 2 N2O5. And rate of reaction will be rate of N2O5 by 2, rate of NO2 by 4, or rate of O2 by 1. So this is the rate of N2O5. Put here, so by 2 will come. So 2.33 minus 2.08. 8. Clear, bhai? 33 minus 8 you can say. 33 minus 8, 25. So 0.25 by 184 by 2. This will be, that is 0.5 by 184 molar per minute. This would be the rate of reaction. So little extra careful. The rate of N2O5 and rate of reaction is not same. To understand, when you are finding delta C by delta T, that's the rate of reactant of product. Rate of reaction will be rate of reactant or rate of product by stoichiometry. Then simple question. Order is the sum of these power. This is called rate law expression. Rate equal to K, some reactant power, some value, some reactant power, some other value. Sum of these power is called the order of the reaction. So 1 by 2 plus 3 by 2 is the overall order. Half is the order with respect to A. 3 by 2 is the order with respect to B. Simple question, but yeah, simple questions are important. Using these units of K, you can find which order is this. For example, if I say 0 order, the unit will be molar per second or molar per minute or ATM per second, ATM per minute. First order will be just per second per minute per hour. Second order will be molarity inverse per second, ATM inverse per second per hour, like that. So like here, it is liter per mole, mole per liter inverse per second, so second order. Only per second, first order. Next. These points are very important, bhai. In that, one very important point I am highlighting. Order is applicable to elementary as well as complex reaction, whereas the molecularity of complex reaction has no meaning. So if there is a reaction which has more than one step, multi-step reaction is there, its molecularity has no meaning. So if someone asks you what is the molecularity of a reaction, where mechanism given step 1, step 2, step 3, molecularity has no meaning. Molecularity of the slowest step is the order of the whole reaction. Clear, bhai? Molecularity of the slowest step is the order of the whole reaction. Let's see, one question is there. Here, this one only I can take. Why to change even the question? NCERT question only I can take. This is the reaction. H2O2 with I minus catalyst give you H2O plus O2. Mechanism is this and this. And in this mechanism, the first reaction is your slowest step. This one. This is the mechanism, This is mechanism. This is slow and this is fast. Always your rate law expression will be written by slowest step. So R is equals to K. This is the slowest step. Reactant power stoichiometry of the slowest step. RDS, rate determining step. So this is your rate law expression. It's first order with respect to H2O2, first order with respect to I minus, but second order with respect to overall reaction. So his order is 2, but molecularity has no meaning for this reaction. It's a 2-step reaction. So molecularity is only defined for elementary reaction. Talking about the integrated rate law expression, but before that, one small thing. These are the examples of zero order kinetics. So which are the example of zero order kinetics? By how to remember? Very simple fundamental idea. Decomposition of gas on solid surface at high pressure, at low pressure. At low pressure, first order. At high pressure, zero order. So if a gas is getting decomposed on a solid surface at high pressure, the reaction rate will be a constant. And at low pressure, the reaction rate will be proportional to the concentration of gas. Because pressure is low, so little pressure will increase, so gas will be more excited to react, more reaction will happen. This is the simplest way of explaining the things. The real thing you have done in the main track, bhai, surface coverage, all those things you have done. Here I'm telling you a simpler way of remembering it. At very high pressure, the gas is already fully under pressure. You apply more pressure, nothing is going to happen, bhai. It is already under very high pressure. So the rate become constant. So at low pressure, first order, rate depend upon gas power 1. That's the meaning of first order. Here, zero order, rate becomes constant. Clear, bhai? Chaliye, moving on. The initial concentration of N2O5 in the following first order reaction. This much. And after 60 minutes, the concentration became this much. Calculate the rate of the reaction. No, not rate constant, they might be asking. Yeah. So it's a first order reaction. For first order reaction, the formula is K equal to 2.303 by T log of C0 by Ct. K equal to 2.303 by T2 minus T1 log of C1 by C2 if initial concentration not given. Leftover, this is leftover reactant is initial reactant by 2 power m, where m is time by half-life. Half-life means how much time it takes for the substance to become half. Like for example, our 10 chapters were there and 5 chapters got covered in 3 hours. So that means half-life is 3 hours. Done, bhaiya? So these are the formulas of first order. Remember that time taken for 100% completion of first order is infinite. First order reaction is never completed. And the half-life of a first order reaction is 0.693 by K, constant. Chaliye, so doing the question on the first order now, applying the simple elementary formula. NCERT applied T2 minus T1 for useless purpose. We can directly apply our main formula. So initial concentration, final concentration, something given K they are asking. 2.3 by T, 60 minutes. Log C0, initial concentration 1.24 into 10 to the power minus 2 by leftover 0.2 10 power minus 2. 2 6 are 12. 2.3 by 60 into log 6. Log 6 will be log 2 plus, log 2 into 3. So log 2 plus log 3. So 0.3 plus 0.4771. So 2.3 by 60 into 0.78. Clear, bhai, per minute. So direct first order kinetics, formula based question. Then, this is a tough one. So here method understand properly, bhai. Here the method understand properly. So they are saying, in this question, they gave the initial concentration of the reactant, initial reactant, and the leftover reactant they gave. Reactant. But in this question, carefully read, bhai. Total pressure giving, total pressure. Reactant not giving, total giving. So here stoichiometry kawali, bhai. So 2N2O5 giving you 2N2O4 plus O2. So initially total was 0.5. These were not there. But after time T, that is 100 seconds, from here 2x reacted. Let's say 2 reacted, na? So 2x reacted. 2 react, 2 produce, 2x react, 2x produce, 2 react, 1 produce, 2x react, x produced. And then they are giving us 0.512 is the total pressure. Getting the point? That means they are saying this total 0.5 minus 2x plus x is 0.512. X will be 0.012. Now this is my C0, initial concentration of reactant, and this is my Ct, leftover. So C0 I know 0.5, Ct I will find 0.5 minus 0.024. Why? 2x. 2 times of this. Clear है भाई? So 0.476. So initially was this much ATM, now this much ATM. So C naught CT came, so K will be 2.3 by T, 100 log of C naught by CT. Obviously, mathematically, they have to give you log value for solving it, but is the method clear to everyone? Here, this question and this question, what's the difference? Here, initial and leftover reactant was given. Reactant. So direct formula you can put. Here, reactant not given. Total given. So from total, making it equal to whatever given, you found X. Putting X here, then you found the leftover. And the formula was K equal to 2.3 by T log of C naught by CT. That is for reactant, bhai. Understood? Very, very, very important question. Tough one. But not only mathematically. Mathematically, they will change the data or they will give you log value. Conceptually, very good question. Then, for the first order reaction, rate constant K. Easy question now. 3.7. K, they are giving you 5.5 10 power 14. Half-life asking. 0.693 by K. So put K here. Get the answer. That's all. Show that in the first order. For this, remember, for first order, some shortcuts I am giving you. First order. Time taken for 75% is 3 times the half-life. Time taken for 87.5% is 2 times the half-life. Sorry. This 3 times the half-life, that is 2 times the half-life. And time taken for 99.9% completion is 10 times the half-life. Method in the main track I have taught, revision I have taught 100, 50, 25, 12.5, all that we have done. And in fact, one formula of Tx percent, 2.3 by K log of 100 by 100 minus X, X percent completion. But right now, that's not the point. Right now this is the question of NCERT, and this can be a NEET 2025 question also. The question can be, half-life of a reaction is 1 minute. Find the time taken for 99.9% completion of the reaction. So how much will it come by? Twarga se. How much will it come? Half-life, I am saying 1 minute. For 99.9% completion, how much will come? Fast. 10 minutes. Perfect. 10 minutes. That was JEE Main 2023 question. Clear है भाई? ओ भैया minimize हो जा चाचा. चलिए भैया, moving on. Now, this is the equation. From Arrhenius equation we can make this graph. So K is equals to A e to the power minus EA by RT. So natural log K is natural log A minus EA by RT. So Y is equals to mx plus C. The slope will be, देखो, x-axis is 1 by T. So ये 1 by T is x-axis. Slope is minus EA by R. But this can be tricky. It is minus EA by R in your NCERT, but you can also write minus EA by 2.303 R if x-axis is log K base 10. This you change in your NCERT by, because NEET have asked this question in 2022 somewhere, where they gave log K, or 23 maybe. Understood the idea? In that case, 2.303 will also come. Now, these two questions are based upon Arrhenius theory. Direct question is there. So, for example, I know this thing. Natural log K is natural log A minus EA by RT. If I take this T1, K1, T1 and K2, T2, and then I subtract them. So natural log K1 by minus natural log K2, log A minus log B is log A by B. So natural log K1 by K2 is equals to, this will cancel and this minus will become plus EA by R will come common, 1 by T2 minus 1 by T1. And if I take ln K as log K1 by K2, so as I said, 2.3 will come in the denominator, 1 by T2 minus 1 by T1. So one question came based upon that. So when you take LCM, it will become T1, T2, T2 minus T1. Done, bhai? Hello? Then, same, this is also there. Moving on. For a collision to be effective collision, effective collision means giving you product. Two conditions have to be satisfied. Condition number one, it must be having proper orientation and energy more than equal to threshold energy. So sufficient energy is there, not enough. Sufficient proper orientation there, not enough. Orientation also should be sufficient. Orientation also should be proper, and energy must also be sufficient. Now, NCERT exercise, which questions we have to focus upon? So number one, question number 3.11. Clear, bhai? This model. So 3.11 I will solve. 3.12, try. Then bhaiya. And 3.21. 3.21 is same, which I explained you, na? Very important method. This data can come. That data was difficult. So that will not come in the examination directly like that, or they will give you log values. A 0.476 question. This data is easy. This can come in the exam. This question you prepare properly. Clear, bhai? One of the question I will solve. 3.26 also comparison question. You can see how this question can be solved. K equal to 4.5 something something something. They are saying find activation energy. So compare this. Sir, with whom? Arrhenius. K equal to A e to the power minus EA by RT. So compare this. So you will get minus 28000 Kelvin T is minus EA by RT. So T cancel. Units you can ignore. So EA will be 28000 R. So these kind of questions, they look dangerous, but you can simply get them by comparing here. 3.26. One question I am solving. This box question, very important. 3.11. For serious NEET aspirants of by this time, I don't think this question would be a problem. But some of the people who just now became serious, they might need this. So let's see. So what I will do, I will make some equations from here. What the equation will look like? It will look like R is equals to R equal to K, A power X, B power Y. So this is the rate. Rate equal to K, this power X, this power Y, this power X, this power Y, this power X, this power Y, this power X, this power Y. So I created 4 equations. Equation number 1, 2, 3, 4. Now divide 2 equations where something should cancel. Like if I divide 1 and 2, nothing will cancel, bhai. Check na. 1 by 3, 1 by 2, nothing. If I divide second and third, these two, second by third, तो भैया ये 0.3 by power x will cancel. You will get 0.2 by 0.4. So 0.2 by 0.4 power y is equals to 7.2 10 power minus 2, 2.88 10 power minus 1. Fasak. So now can I say this is 2.88 10 power minus 1? This can I say 28.8 10 power minus 2. So 72 into 4. Attack. तो 1/2 power y is 1/4. Now half power y is 4. That means y must be 2, because 1/2 power 2 square will be 1/4. So y2 came. Now you take any ratio you want. For example, now I'm taking the ratio of, let us say, 1 and 4. So when I take 1/4 ratio, so 0.1 by 0.4, so 1/4 power x, this will cancel. 0.1 power y, 0.1 power y. This side will come 6 into 10 power minus 3. And here 2.4 10 power minus 2, I'm writing 24 10 power minus 3. Khatak. 1/4 power x is 1/4, so x equal to 1. So the order with respect to A is 1, x equal to 1. And order with respect to B is 2. That's how the question have to be solved. To make the equation rate equal to K, concentration power x, concentration power y, 4 equation, 5 equations will form. Divide any two, answer will match for x or y. Badhiya. Moving on. So this was chemical kinetics. Next, last, full and final settlement. Redox. Now for redox reaction, I think basic things you should be knowing. For example, this reaction is there. H2S plus chlorine gives you HCl plus sulfur. In this reaction, who is the oxidizing agent? Who is the reducing agent? What is the reaction going on? So simple. From -2 to 0, oxidation. Oxidation means the person getting oxidized is the reducing agent. So ये हो गया Ra. 0 to -1, reduction. Reduction means the person getting reduced is oxidizing agent. The oxidizing agent is chlorine, reducing agent H2S. Like this, second and third also you can try. Simple questions are there, bhaiya. So take it seriously, don't take it lightly, but good questions, easy questions. In this, who is the oxidizing agent, who is the reducing agent? From sodium 0 to sodium +1. In any compound form, sodium will always be +1. So 0 to +1, oxidation, reducing agent. 0 to -1, hydrogen with metal is -1. So 0 to -1, reduction. Reduction means oxidizing agent. Do all these questions, bhai. Right now, simultaneously do. Why to wait for the evening? Don't be a cow. Right now, all the grass you will eat in the evening, you will do rumination. That's not how it works for humans, bhai. This stock notation. For stock notation, in the bracket, we put the oxidation state in Roman numerals. For example, MnO2 I'm taking. So manganese is +4. Oxygen generally -2. So 2 oxygen -4. So manganese must be +4. So Mn in the bracket will be 4. Mn4O2. That is called a stock notation. Clear, bhai? Same thing here. Cu2O, Cu2S, Cu plus SO2. In this reaction, you check. Copper here is +1. Getting reduced to copper. So here I cannot say perfectly that this is the oxidizing agent, or this is the oxidizing agent, or this is the reducing agent, or that is the reducing agent. Why? Copper is in both. And both copper from +1 are going to 0. To understand, this is getting reduced. The oxidizing agent is copper first. Similarly, this sulfur from -2 is becoming +4. This is oxidation. The reducing agent is sulfur in Cu2S. I cannot say Cu2S reducing agent here. Why? Because Cu2S contain copper and sulfur both. Out of that, copper getting reduced, but sulfur getting oxidized. So I cannot perfectly define, because in the previous example, it was a clear cut. A and B are reacting, one of them oxidizing agent, one of them reducing agent. To see the beauty of 7.4 solved example, bhaiya. So the answer is, who is the oxidizing reducing agent? You can underline here. Copper first is oxidant, and sulfur of Cu2S helps both, copper both in Cu2S itself and Cu2O to decrease the oxidation number. So sulfur of Cu2S is the reductant. Badhiya. Moving on. Which of the following will not disproportionate? तो देखो भैया, who are the people? Disproportionation means same person getting oxidized, same element getting oxidized, same element getting reduced. People in their highest oxidation state, in their lowest oxidation state, fluorine, S block element, aluminium, zinc, scandium. These are the elements who cannot disproportionate. Why, sir? Highest oxidation state can be only reduced. Further oxidation not possible, na? Highest already. Lowest can only be oxidized, cannot be reduced. And fluorine, S block, aluminium, zinc, scandium, they show only one oxidation state apart from zero. So they cannot be simultaneously oxidized and reduced. Why? For someone to simultaneously get oxidized and reduced, there should be three different oxidation states. And they show only 0 and -1, 0 and +1 +2, 0 and +3, 0 and +2, 0 and +3. That's why these people cannot be disproportionated. So here, chlorine is +7. +7 is the highest for the 17th group. So it cannot be disproportionated. Clear? Hi. Classification. Do this question, very important but easy. These structures from the main track notes also see once and find their oxidation state also properly. Done, bhai? Easy hai, but make sure that you do it properly. So one example I am taking of C3O2 to explain you the same scenario. So for example, C3O2 is there. O is more electronegative. So he will suck the electron from 2 bonds to -2. That O will suck the electron from 2 bonds to -2 he will get. Carbon lost the electron from 2 bond to +2. This carbon also lost +2. But now carbon carbon same. Carbon carbon same. So this carbon will not lose any electron. This carbon will also not gain any electron. This carbon will not lose any electron, not gain any electron. All are carbon 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 in the same hybridization. So the oxidation state of carbon is 2, 0, 2. And the average oxidation state will be 2 + 0 + 2 by 3. 3 carbon atom, na? So 4 by 3. So average oxidation state can be fractional, but the individual oxidation state cannot be fractional. These are individual oxidation state. Always integer. Average can be fractional or sometimes can be integer also. Average can be fractional, just like your marks, na? Your marks in a test can always be integer, but the average, for example, your average can be 610.5, but your marks cannot be 610.5 in any one exam. So individual oxidation states cannot be fractional, but average can be fractional, same like oxidation state. Make sure that you read these examples: Pb3O4, Fe3O4, Mn3O4. They are mixed oxides. Then, based upon that, this question is there: कि Pb3O4 react differently with HCl and HNO3. Why? देखे भाई, understand this question. Pb3O4 है भाई, Pb3O4. It is actually a combination of PbO2 and PbO. So understand this, कि PbO2 is an oxidizing agent because highest oxidation state of lead is +4, and the person in their highest oxidation state is going to act like oxidizing agent, and he will act like a base. Metal oxide, he will act like a base. He is amphoteric, but in front of HCl and HNO3, he will act like a base. So how the reaction happen with HCl? And then the same bhai sahab, how this brother is going to react with HNO3. Let us understand. So here HCl is going to act like an acid, and acid and base will give you salt plus water. So this is the acid base reaction. But there is one more interesting thing, because chlorine is -1, and -1 of chlorine is the lowest oxidation state of chlorine, is the reducing agent. So OA, RA are made for each other. So oxidizing agent will oxidize HCl to become chlorine. So that is a product of redox reaction. But when it comes to HNO3, there the nitrogen is +5. That is the highest oxidation state. In the highest oxidation state, he is oxidizing agent. So what will happen? Acid, HNO3 is acid also, na? Acid plus base will give you salt plus water. There is no problem in that. Acid-base reaction will happen. But HNO3 also oxidizing agent. PbO2 also oxidizing agent. So PbO2, HNO3 will react with PbO, acid base. But PbO2 will not get a chance to react with anyone here. So PbO2 come out unreacted. Why? Both PbO2 and HNO3 are oxidizing agent. Boy, no marriage. Oxidizing agent, no reaction. Clear bhaiya? NCERT solved example, very beautiful one, redox. AIMS exam used to be separately conducted before. They have asked this question in assertion reason. Now, K2Cr2O7 N2SO3 reaction balancing is there, that I am telling you separately in the slide, done by. Then we'll come to this one, indicator theory and all. So now, they are asking to balance Cr2O7 2 minus with SO3 minus. The product is SO4 2 minus and Cr3 plus, and the medium is given as acidic. So firstly, find the oxidation states by. So here the oxidation state will come +6, here will come +4, here will come +6, here will be +3. So +6 to +3. How much is the change by? +6 to 3, change of 3. The mistake you should avoid is that for 2 chromium, the change will be 6. So the valency factor here is 6. So remember that for the whole dichromate, there are 2 chromium. 1 chromium +6 to +3 is going by. Hello. +6 to +3, change of 3. And for 2 chromium, change of 6 will be coming. Video, audio not coming. Ruko, wait. Look, let's see. Now audio video coming bhaiya. Now once check. Now check. Now audio video coming. Now check bhai. Give a yes or no. Now coming or not coming. Give a yes or no. Problem came in the class coming. In the class coming, na? Class. Achha, here also YouTube, right? Okay. And everywhere else YouTube connected?
No, sir. Only one class.
So other classes ask, na? Kanguru ask, problem coming, not coming. चलिए, so +4 to +6 change of 2, so valency factor 2 because only one sulfur there, no need to multiply anything. Then we cross multiply. I can cancel it also. 2 3 is 6. Cross multiply, 3 comes here, 1 comes here. So this is the electron balancing. Now we have to balance atom. So there are 2 chromium atom, so 2. 3 sulfur, 3. In the second step, don't balance oxygen. Electron atom charge balance. Electron, how to balance? Cross multiply valency factor. Atom don't balance O and H here. And charge balance by H plus or OH minus. Cross multiply, so 3 will come here, 1 will come here, 3 sulfur ho gaya balance, atom balance. Now charge. You can check here -2 and -6, so -8 charge. And this side -6 plus 6, 0. So 8H plus will be added on the left side. So overall charge will come 0. Where? Ask on YouTube, na? Connect on YouTube. You can try. But ask them, na, backup YouTube is there. You ask connect to YouTube. Why to waste time, na? They know how to connect YouTube. So ask them. Meanwhile, I will change it. Clear, bhai? So charge got balanced finally. 8 hydrogen atom. So how many water? 4. And oxygen must be automatically balanced. Like here we can see 7 oxygen, 3, 3, 9. So 7 plus 9, 16 oxygen atom. Here 12 plus 4, 16 balanced. That is a balanced chemical reaction. Now some problem is coming in the app. I will sort it out meanwhile. So we are going to take a break of 5 minutes. This part, redox titration part, I have to tell you, remaining part of the redox is over. Clear, bhai? So this is the end of the physical chemistry of senior inter also. So redox some titration part I have to take. Remaining part is over. So after a break of 10 minutes, we are going to start with the next point. That is the inorganic part, biomolecules, salt analysis, all these parts. P block, salt analysis, biomolecules, we are going to start after 10 minutes. Done, bhaiya? And restart, no problem.
refresh పెట్టు రీఫ్రెష్ పెట్టు అవసరం పెట్టేసావా ఓకే refresh button. Refresh button.
Okay. Go ahead and we will start. All campuses you can ask. Boys.
Boys.
Ask to bring the Check bhai, voice coming. Some interruption came in the app. Now I think it is all right. All audio video clear. Coming now, voice coming. Audio video clear now. Badhiya. So now, redox titration indicator. So there are three titrations. One is KMnO4 titration. Self indicator is there. K2Cr2O7 titration. Diphenylamine is the indicator. Third is iodine based titration. So iodine starch complex forms blue. That is the indicator. So here, this much everyone should be knowing, obviously, that self indicator is there. So the end point will be pink color appears. This will be blue color appears. This will be blue color disappears at the end. But the point I want to focus upon is ki why KMnO4 is a self indicator and why not K2Cr2O7 bhai? Because KMnO4 is colored. So when KMnO4 will be reacting and the leftover KMnO4 is there, extra KMnO4 came, reaction over. So he will show the color. But then K2Cr2O7 also colored. Na? KMnO4 you have learnt yesterday in the part 1 of the marathon gold also. It is dark purple. So like little bit pink color will come. Then why K2Cr2O7, which is also orange and yellow colors are there in acidic and basic medium? So why K2Cr2O7 cannot be used? Why? So the reason is this is very dark color. So this pink color appears even at 10 to the power minus 6 molar concentration as well. That means 0.00001 molar. Also if KMnO4 is there, you will start getting pink color. But K2Cr2O7 is the orange color, yellow color, which is not very bright color. So chala amount of K2Cr2O7 will be extra, then only the color will be visible to the cones of the eyes. So that indicator can be self-indicator, which has a very dramatic color change. That is the language of NCERT. So KMnO4 can show the color even at a minimal overshoot, a little extra KMnO4, even 10 power minus 6 molar it can show the color change. K2Cr2O7 cannot show there. Clear bhaiya? So now we are starting with P block. Now only physical chemical property from the P block is in the syllabus. So in the boron family, we call it Sarvanasham group here. Why? Everything is the exception here. Everything is the exception. Except a few where I put the arrows, like radius. Ionic radius is never the exception in any group. But covalent radius is also exception here. Metallic radius is the exception here, basically. Atomic radius. Density is not the exception. Top to bottom density increases. In general, for every group, top to bottom density increases. Boiling point, interestingly, is not the exception in boron family. Let's talk about exceptions one by one. Electronegativity, aluminium minimum. So boron to aluminium, there is a dip. And then the electronegativity increases. So aluminium minimum. For melting point, gallium has a dip. We call it a summer liquid. So gallium become liquid at 303 Kelvin. And then become vapor at 2676 Kelvin. You can understand, gallium is a liquid from around 300 Kelvin to around 2600 Kelvin. So it's a liquid for a wide range of temperature to use in the industrial thermometer. Ionisha enthalpy yesterday, VSP sir have told you, so I'm not wasting my time on that. Moving on, in carbon family, only one drama, density. Apart from that, lead will show little bit variation. Lead. The explanation is not given in NCERT in detail. It is something called as relativity effect. But that's not the syllabus of junior senior inter. So you just understand कि lead, last element. In nitrogen family, bismuth, they will do little bit of problem at the last, but otherwise there is no major exception in the carbon family. Ha, density you should be careful bhaiya. Why careful? Dekho, according to the density order given to you, carbon is given more than silicon. and then after that density increases. In general, increases only. But carbon given more than silicon. But below the margin, if you read, they have given that this density is of diamond. And diamond is very dense, bhai. Hardest known substance for humans is diamond. It is very dense. So here diamond has more density, but here the density of 2.22 is graphite. So diamond density is more than silicon, but silicon is more than graphite. So if I take graphite, silicon, germanium, tin and lead, then there is no exception in the density. Graphite has less density than silicon. Graphite has layer-like structure. It can slide over each other. There is a big gap between the two layers of graphite. So it's not very dense. Dense means closely packed. Diamond is dense. So diamond is denser than silicon. So if diamond is considered in the order, we can take the exception. Otherwise, we will not consider this as the exception. If graphite is given, then density top to bottom increases. Done, bhaiya. So carbon family, only exception, density if diamond is considered, otherwise not. Electronegativity, carbon to silicon, there is a dip. After that up to lead is almost same, 1.8, 1.8, 1.8, 1.9. In the nitrogen family, you only have to worry about arsenic melting point. Actually, the arsenic melting point is not the exception also. The arsenic melting point is measured at a very high pressure. But that much paper setter will not read below the margin of NCERT. The paper setter will just see the data. He will not see that these data are measured at different pressure and this is measured at high pressure. They will not see that. They will just see that arsenic data of melting point is coming high. So arsenic has the highest melting point. If they ask a very dumb question, you also become dumber and answer that and get marks and move on. Clear, bhai? Boiling point top to bottom increases. Now see the interesting point. Boron family, carbon family, boiling point will be decreasing top to bottom. Check. Boron family, carbon family have more metallic nature. For them, for junior inter p block. Junior inter p block means 13-14 group. Boiling point top to bottom decreases. Exceptions are there. In general decreases. But for senior inter p block, boiling point top to bottom increases. So nitrogen family, oxygen family, everywhere, halogen family, noble gases, top to bottom boiling point will increase. But for 13-14 group, boiling point decreases top to bottom. Major difference in P block, junior inter, senior inter. Then density, no exception, top to bottom increases. Oxygen family, the major exception they will ask you is oxygen electron affinity. So electron affinity of oxygen is minimum in its group. Yesterday VSP sir have discussed, so not putting more time on that. But yeah, that's the only problem. Otherwise density increases, melting point increases, boiling point increases. Sir, polonium, polonium, bismuth, in carbon family lead, they will do some drama, last element. Apart from that, there is no major exception you will find here as well. But electron affinity of oxygen is minimum in the group. For halogen family, I always say second from the top, second from the bottom. So fluorine, electron gain enthalpy, electron affinity is second from the top. So chlorine maximum, then fluorine, bromine, iodine. Chlorine tarvata fluorine. Second from the top and second from the bottom bond enthalpy. Second from the bottom fluorine is bond enthalpy. So chlorine, bromine, fluorine, iodine. So for bond dissociation enthalpy, fluorine is second from the bottom, just above iodine. And for electron gain enthalpy, the magnitude of fluorine is just after chlorine, second. Clear, bhaiya? Hello? Done? Now, fluorine, chlorine, bromine, iodine oxidizing power. So fluorine is best oxidizing agent, then chlorine, bromine, then iodine. Fluorine to crazy hai bhaiya. Fluorine is chala crazy. About noble gases, bhai, all the noble gases are monoatomic. They are colorless, orderless, tasteless. That's why they were discovered very late. They have very low boiling point. Why? Because of weak London dispersion forces. The last gas in the whole periodic table, the last gas to liquefy will be helium. 4.2 Kelvin will be the boiling point. Done by, and helium is very abnormal liquid. It can pass through. If you take liquid helium, if you liquefy helium and make it liquid, it cannot be stored in glass and rubber containers. It will pass through that. So 7.21 salt example. Noble gases have very low boiling point. Why? Because they have weak London dispersion forces. Now, important chemical properties. Number one, O2PtF6 was the red color complex prepared by a scientist called as Bartlett. And then he realized that the ionization enthalpy of O2 and xenon will be almost same. So if O2 can form O2PtF6, then xenon can also form XePtF6. So that was the first noble gas compound made, XePtF6, red color, because ionization enthalpy was similar. Reactivity towards hydrogen, देखो भैया, reactivity towards hydrogen, nitrogen family, NH3, PH3, ASH3, SBH3, BiH3, H2O, H2S, H2Se, H2Te, H2Pu, HF, HCl, HBr, HI, HAT. As you go from top to bottom, size of the central atom increases, bond length increases. Because of that, bond enthalpy decrease. So top to bottom, it becomes easy to break the bond. If the bond enthalpy decreases, bond is easily breaking. So acidic nature will increase, reducing agent nature will increase. Because if bond will break easily, so H plus will also be easily donated. And if H plus is also easily donated, it is good acid. If the bond breaks easily, H minus will also be easily donated. Now organic chemistry completed. So lithium aluminum hydride is a reducing agent. Why? H minus donor. NaBH4, H minus donor. Dival hai, H minus donor. All these H minus donors are reducing agent. So if the bond breaks easily, H can be donated easily, so good reducing agent. And if acidic nature is more, basic nature will be less. Here I can write, no problem, size more, basic nature of the hydride will be less. So understand, for acidic nature increase, Ka increase, pKa decrease, the reason is bond enthalpy weak. For bond enthalpy less, the reason is bond length more. For bond length more, the reason is size more. And for basic nature less, size is more, that is the reason. Rajendra, you know exactly what has to be done in this kind of a scenario now. Already this all we have gone through. 10 minutes gap was given for you. You know that parallelly two things we are running. There is a backup. So Rajendra, please, for God's sake, use an organ called as brain. Fingers cannot be used every time, brain has to be used. How can online student be so stupid that parallelly YouTube going on? And for that also they are having the issue. Already I have said one time. For offline, I understand it can be a problem. For them, we can play the video wherever required. Please, for God's sake, once in your life, use that your head. It might help you. Yeah. Understood, Rajendra? Please grow up a little bit. Might be very useful. Chaliye, moving on. Clear here up to here? Internet fluctuations will happen up and down. And I'm not going to stop the lecture for the time being. Time shortage is there. 12:15 right now already. 12:21 right now already there. Up to 1:15, 1:20 is my target to complete. I don't want to rush like an idiot because you are trying to be idiot. I understand there is an issue coming on with the internet. For 1 hour, if I complete my part, whenever you are free, recorded lecture will be there. You can listen it whenever the hell you want, bhai. Whichever the part you want, bhaiya. But if I will not even teach, what the hell did you listen? Even anything will not be there, bhai. Or if I complete in a rush, what would you understand by listening also that garbage which I will record? Clear, bhai? In Hindi we say ऊंट निकल गया पूंछ रह गई है. In other words, camel have already passed, tail only left. In that tail you are doing operation की नहीं sir, tail तो I want to see complete tail. Wait कर ले यार. Understood? Sensibility you cannot be taught, learn. Clear, bhai? If a 6 hour, 7 hour lecture will be going, there will be hiccups in the internet connections, especially from last class also you are saying it is happening. But we have backup. We are recording lecture. We have the backup. So please, you will not lose any goddamn thing until I don't teach. So can I please teach? Please, can I teach? Is that a possibility? Would you stop interrupting in the middle? Backup class is running already. You will have the recorded lecture as many times you can see and sleep, no problem. But I have to teach there first. Clear? Can I move on? Online warriors, हाँ भैया, Instagram, YouTube warriors, can I move on? एक तो ये online keyboard everyone has got ना, that is a problem. That's why on the YouTube I have switched off the comment section because unnecessarily said this is getting stuck. I know what is getting stuck. I'm taking the breaks there. Online, those who are seeing on the app, sitting in the house, I'm moving on. So please, for God's sake, don't disturb anymore. Non-serious candidate are going to become more interrupting in the middle. Serious candidate, not a single person is messaging. चलिए भैया, चलिए moving on. चलिए भैया, चलिए. Focus. To understand, if the acidic nature will be more, reason, assertion, acidic nature increases top to bottom, Ka increases top to bottom, pKa decreases top to bottom, assertion, reason is bond enthalpy less, or we can say stability less. That is the reason. Reducing agent nature more, stability less is the reason. Clear, bhai? Bond enthalpy top to bottom decreases. Reason, bond length is more. Bond length top to bottom increases. Assertion, reason, size increases top to bottom. This is how. You will not say for acidic nature increases, size increases is the reason. No. Top to bottom size increase, true. Top to bottom acidic nature increase, true. But reason is not the correct explanation of the assertion, you will say. So if this is the assertion, this is the reason. If this is the assertion, this is the reason. If this is the assertion, this is the reason. That's why basic nature I have written over here. If this is the assertion, this is the reason. So out of ammonia, PH3, SH3, SBH3, BiH3, who's the most basic? Ammonia. Reason, smallest atom. Clear, bhaiya? Should be clear. Moving on. Water is not a reducing agent. Otherwise, top to bottom reducing agent nature increases. Done by. Then, is the strongest reducing agent. Reason, least stable. Hydride of the nitrogen family. Talking about boiling point, melting point. So if you remember some story I told you, what was the conclusion of the story? Water is a natural topper. Boiling point, melting point, both will be maximum in the 16 group hydride. Clear, bhai? Firstly, general order. For general order, for these people from here to here, boiling point increases, melting point increases from top to bottom without any exception. But because they can show hydrogen bonding, for them, because they can show hydrogen bonding, for these people, boiling point, melting point will be little bit exception like water. Here the boiling point increase, but the topper will be water. Melting point also. For ammonia, boiling point, third. So third from bottom or top. There are 4 people. From the top or bottom, third is third only. It's the middle. But the melting point, top. And for HF, boiling point maximum. But the melting point will be second from the top. Then by, that's the easiest way to remember melting point, boiling point orders. So water, natural topper. Boiling point maximum, boiling point also maximum, melting point also maximum. For ammonia, boiling point is third, but maximum is the melting point. And for HF and for remaining people, top to bottom size increase, boiling point, melting point increase. Already I told you, na? For nitrogen family onwards, top to bottom for atoms, boiling point increases, melting point increases. Same thing happens for hydrides also. Size increase, boiling, melting point increases. They are proportional to size. Say bhai, clear or not clear? Clear bhai? Clear bhai? Chalo, recording. Chaliye, moving on. This was about the hydrides. All these assertion is and question just now covered. Now, property of hydride of 16 group here. चलिए, then d pi p pi bond. तो भैया phosphorus have d orbital, it can form a d pi bond. Clear है भाई? But nitrogen does not have a d orbital. It's from the second period ना. So they can have maximum covalency 4. He can make maximum 4 bonds, and there is no d orbital, so there is no d pi bonding with nitrogen. But phosphorus can form. Now next, all this done. Basic nature, falana dimkana, over. Clear bhai? Next, when we talk about p pi bonding, so second period element forms the best p pi bond. Small atom, Munchie pi bond. Chinna atom, Munchie pi bond. Catenation tendency, bhaiya, carbon much more than silicon. Carbon to loves catenation, yaar. Whole organic chemistry is there because of catenation. Who does not show catenation? Lead. Lead does not show catenation. From carbon, silicon, germanium, tin, as you go from top to bottom, the bond length increases. So bond becomes easy to break. So carbon-carbon single bond is the strongest. So that's why best catenation. So because of huge catenation and second element carbon will form Munchie pi bond. So due to Munchie pi bond and strong catenation tendency, carbon show allotropic forms. Diamond, graphite, fluorine. SiF6 2- is known, SiCl6 2- not known. Here this question can come. They can give you 4 options. SiF6 2-, SiCl6 2-, GeCl6 2-, SnOH whole 6 2-, GeOH whole 6 2-. Which of the following does not exist? SiCl6 2-. GeCl6 exists, but SiCl6 will not exist. Why, sir? Silicon chinna, germanium pedda. Around chinna silicon, 6 chlorine will not adjust easily, steric hindrance will happen. Crowding will be too much. But around pedda germanium, the space is more. So adjustment of the Cl- will be easy. Clear, bhai? So 6 large chloride cannot be accommodated around a small silicon plus 4. So SiCl6 2- does not exist, but GeCl6, SnOH whole 6, GeOH whole 6, SiF6, fluorine chinna. 6 of the fluorine can adjust. That's why SiF6 will exist, but SiCl6 will not exist. Select the member of group 14 that form the most acidic oxide, most non-metallic, and the high oxidation state. So carbon is the most non-metallic here, and the highest oxidation state is +4. So CO2 is the most acidic oxide. Commonly in +2. So you know inert pair effect. So in carbon family and in boron family. So for boron family, from boron to thallium. Clear, bhai? Bohr, aluminum, gallium, indium, up to there, +3 more stable. But for thallium, +1 more stable. For carbon family, up to tin, we can say +4 more stable, but for lead, +2 more stable. So the answer is lead. Use a semiconductor. Everyone knows silicon and germanium. Whole chapter is there in physics, bhai. Now, boron is very hard, black color, and it will not react at room temperature, bhaiya, at moderate temperature. Boron is very hard crystalline substance. It will not be reacting easily. If you crush it, if you powder it, then it can react. So boron does not react with acid alkali even at the moderate temperature. Aluminum is amphoteric. He will react with acid and base both. But aluminium with HNO3 get a protective oxide layer formation. So the reaction becomes less. So aluminium with concentrated nitric acid is passive due to protective oxide layer. Fumes. Whenever you listen the word fumes for a chloride compound, the fumes, cloud-like, white color, cloud-like structure will be coming. Clouds, white color will be coming due to HCl gas. So aluminium chloride, PCl5, why they fume in the moist air? Because of the formation of HCl. BF6 3- exists? No, boron is a second period element, maximum 4 bond. So BF6 will not exist. Clear, bhai? Then we have salt analysis, bhaiya. Salt analysis, you have to focus upon 2 major things. Number 1, firstly, primary test. For preliminary test, we have to worry about who are the gases evolved in which cases. तो देखिए भाई, first thing, anions I am dividing into two major part. One is dilute sulfuric acid group. One is concentrated sulfuric acid group. For dilute sulfuric acid group, carbonate is there, which will give you CO2 gas. Colorless, odorless gas turns lime water milky. It has a lime water test. SO3 2- will become SO2 gas. Burning sulfur smell. It can also show lime water milky test. Burning sulfur smell and turns K2Cr2O7 solution green. Sir, how K2Cr2O7 solution will become green? It becomes green because of this reaction. So when K2Cr2O7 react with SO2 or SO3 2-, it forms sulfate. Which sulfate? Chromium sulfate. Cr2SO4 whole thrice. This is the green color. Done bhaiya. Next. Whatever dilute can do, concentrated can do better. So like with carbonate, concentrated sulfuric acid if you take, then also CO2 gas will be coming out. So no problem in that. Understood the story, bhai? Next, after sulfite, this is sulfite. See the name also properly. Sulfide will become H2S gas. It has a rotten egg smell. And this sulfide can turn lead acetate paper black. It turns lead acetate paper black. So it's like your socks. Rotten egg smell, black color, PBS. It will be formed. Done by one test you can remember, that is SN Prasad. So what is SN Prasad? Sodium nitroprusside. SN Prasad, sodium nitroprusside, Praside, purple. So sodium nitroprusside, SN Prasad. Clear, bhai? So SN Prasad, purple. If you know the reaction, you remember in the main track I taught you one trick, no nose. So SN Prasad contains NO ligand, which becomes NOS with reaction with sulfur 2-. So no nose, purple color. Why no nose? Rotten egg smell, na? So no nose. Clear, bhaiya? Hello. Clear, bhaiya? Carbonate, sulfite, sulfide. Lime water milky test, both will show. So what's the differentiation test? K2Cr2O7 solution green for SO2. Sulfide, lead acetate paper black. SN Prasad, purple. Praside, purple. Purple color will form and the complex will have NOS. The ligand will be NOS. Clear, bhai? If you want, you can write also here Na2 FeCN whole 5 nose. Done, bhaiya. Then hair nitrate, hair nitrite. Nitrate, concentrated sulfuric acid group. Nitrite, dilute sulfuric acid group. Both will release NO2 gas, which is brown color gas. Reddish brown, brown you can say. Then bhaiya, carbonate hair, oxalate hair. Oxalate with concentrated H2SO4 will give you CO plus CO2. This will also show lime water milky test. But CO will also give you blue color flame when you burn a matchstick over the test tube. So if only lime water milky test, CO2. If lime water milky test along with blue color flame, so it is oxalate. Clear, bhai? So that's the NO2 gas. Brown color gas is there. Then here you have chloride, bromide, iodide. Very important, bhai. Chloride will not give you chlorine gas with concentrated sulfuric acid, but bromide will give you bromine vapor, iodide will give you iodine vapors. Done? Check, bhai. And finally, lollipop question. Acetic acid, vinegar like smell. Confirmatory test. One confirmatory test is also there. We can do esterification, fruity smell will come. Then bhai, these are violet vapors, reddish brown vapor. Bromine is a red color liquid. Iodine is a violet color solid. So if you are having a violet color deposition in the test tube, iodine. Red color solution to bromine, because bromine is liquid, so it will make the solution liquid. Solution red, because liquid na. Iodine is a solid. He will deposit on the solid test tube. So test tube purple, iodine. And solution red, bromine. Clear hai bhai? If dilute sulfuric acid added, concentrated sulfuric acid added, no gas came. So bhaiya, we have our sulfate and phosphate, no gas with dilute sulfuric acid or with concentrated sulfuric acid. Sulfate, phosphate, no gases will come. First idea clear to everyone, hopefully. Then bhaiya, then when you are revising now, the best thing is to revise this confirmatory table, because main track revision you have done na yaar. Now revise this confirmatory table. It will be very fast, quick revision for you. Like carbonate, lime water milky test, brisk effervescence will be there. Bubbles will come. Sulfide, sodium carbonate extract will be formed. Sodium hydroproside, purple or violet color will appear. SN Prasad. Sulfite, K2Cr2O7 solution become green, and barium sulfite is also white color PPT. BaSO3. BaSO4, BaSO3, both are the test. BaSO4, test of sulfate. BaSO3, test of sulfite. Then NO2 minus. In NO2 minus, bhaiya, one extra test will come, that is called Gris-Ilosway test. There diazotization and coupling reaction happen. If you take highly concentrated solution, then the reaction will stop at diazotization, coupling will not happen. But if you are listening this for the first time, this is too much for you to remember. And if you are listening it several times before you have done this thing, you don't have to listen it. So I'm not talking about those things which cannot be done right now or which are not going to be useful right now. So NO2 minus, one main test is there. This is Gris-Ilosway test. So just remember color. So red color will be formed with NO2 minus something. And reddish brown vapor will come. Clear bhai? Next. Acetate. With acetate also there are two tests. One to bhai, esterification you can do easily. Fruity odor will come. Esters are fruity smell. Next one, you can take neutral ferric chloride solution. Neutral ferric chloride. So red color will come. Clear bhai? Red color complex appears. Then bhai, which will later become brown red PPT. This much enough. More than that not required bhai. And keep in mind which are the main things to remember. See, hint in this kind of questions you have done, if enough practice you have done, you will realize these hints are generally enough. From here, most of the answers click in the examination. Until a very specific question they will ask you. So if you have done this in the main track properly, which I know you have done, clear bhai, you will be comfortable. You can revise it today properly. But if you are listening this for the first time and hoping to do everything today, not going to happen. Don't be over greedy. Learn basic things and move on. Like this thing. If you know this, you know. But if you don't know, then coupling reaction will be there. Electrophilic attack will happen. Why you want to go there and get by mistake in out of 10 year one question will come? Why to waste time? So these we have done. Coming to the confirmatory test. For chloride, bromide, iodide, for these, the confirmatory test, easy ones are there. Dekho. For these, the confirmatory tests are Cl minus, Br minus, I minus, test number 1, AgNO3. So we know AgCl is a white color PPT, AgBr is a pale yellow PPT, and AgI is a yellow color PPT. Very interesting thing, in revision, my eyes have got opened several times. In revision, I came to know that there are people in long term who have no idea that this downward arrow means precipitate. And such kind of scenarios comes in our daily life, then we realize what the hell we are thinking and what they are doing. So if any such species exist, make sure whenever you prepare next time for NEET PG also or some other examination in your life, bhai, for God's sake, from beginning onwards, start clarifying these doubts. In the revision, when these doubts comes na yaar, the teacher feel like jumping from the 7th floor. So please be more serious about the studies next time when you prepare for any examination in this world. Anyway, so Cl minus, Br minus, I minus, this is one of the tests. Clear, bhai? AgNO3 test. This is soluble in ammonia, soluble with difficulty in ammonia, insoluble in ammonia. AgI, insoluble in the ammonia. Remember, AgI, I for insoluble in ammonia. Then Br minus, one test is there which is called layers test. Layers test cannot be applied for Cl minus. Remember that. Layers test will not be shown by Cl minus. Layers test will only be shown by Br minus, I minus. Layers test. In layers test, we are going to react with chlorine water. He will not react with himself. Chlorine is more reactive. Fluorine more than bromine, more than iodine. So chlorine can kick out Br minus to bromine, I minus to iodine. We will take two layers. One I will take aqueous layer. One I will take organic layer. Chloroform, CCl4. In the organic layer, bromine will come or iodine will come. Will make the layer colored, orange color. Bromine is very colorful person here. Reddish brown vapor, red color liquid, orange color layer. Iodine is so cute. Iodine is like boys. For the party, shirt undi. For the convocation, shirt undi. Clear, right? For eating, shirt undi. Marathon class going on, shirt undi. Sleeping, shirt undi. Iodine. Violet, 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 violet. Only with the starch blue color comes. वो starch है ना. After marriage, wife will ask to change the shirts. Otherwise, the same shirt we can wear for 30-40 days also. Yeah. Clear, bhai? Little bit perfume we can use, but it will work. Bromine is like girls, ki morning party. For party, I need orange. ये ड्रामेबाजी bromine will do. So reddish brown vapor, red color liquid. Understood? Ugadi different color will come. Ramzan different color will come. Marathon different color will come. So all those colors have to be remembered for bromine. Yeah. Understood the idea, bhai? In the aqueous layer, ions will come. Like generally here, Cl minus ion will come because they will displace bromine, iodine. So Cl will take their place. Na? Cl minus ion in the aqueous medium. Done, bhai. Now partiality happened with Cl minus layer test not there. So we do chromyl chloride test. Who will show chromyl chloride test? Iodine. Sorry, chloride. So what is formed here with K2Cr2O7? You will get CrO2Cl2, which is going to become chromate, which is yellow color, which will be further oxidized in the presence of H2O2. Clear, bhai? To become CrO5, which is going to give you a blue color layer in amyl alcohol. Why to remember this much? Understand, if you ever get this deep red vapor, this is chromyl chloride. After that, whatever they will give you will be the same sequence of reaction. It's not like there is any other reaction where CrO5 is formed. No. Only one reaction there. So K2Cr2O7 came, deep red vapor came, chromyl chloride. Clear, bhai? So that means Cl minus ion is there. So after that, whatever there, if you are learning for the first time, no need to remember, just understand कि chromyl chloride, this word, or amyl alcohol, chromyl chloride, this is only for chloride. Chromyl chloride. For nitrate, we say brown ring test. Simple. So a brown ring you see anywhere, brown ring. So you can understand that was the test of nitrate. Clear, bhai? There's a test of HNO3 also. HNO3 is a good oxidizing agent. HNO3 is a good oxidizing agent. So if you react these ions with HNO3, if you react these ions with HNO3, Cl minus become chlorine, Br minus become bromine, I minus become iodine. So violet color vapors, वही reddish brown vapor, ये greenish yellow vapor. To understand, with concentrated H2SO4 na, HCl formed. But with HNO3, the Cl minus will be oxidized to chlorine. It's a good oxidizing agent, HNO3. So this was about the confirmatory test there. For C2O4 2 minus, we can make calcium oxalate, which is a white color PPT. Calcium oxalate, it's a white color PPT. So this is majorly about anion test. In case they ask you with iodide, which are the byproducts formed when H2SO4 will react? When H2SO4 will react with I minus, which are the byproduct formed? So I say, you can remember, high sulfur has SO2. High sulfur has SO2. These are the byproducts. I minus will become iodine. That is one. Byproducts are SO2, high sulfur. Has kahan gaya? Has. So high sulfur has SO2. These are the byproducts when I minus react with concentrated sulfuric acid. Moving on. This sulfate, phosphate. Yeah. Now, preliminary test you can see once. Coming to the cation main table. Let's come directly there. So main table of cation, how to remember? I told you, AP called to ask Papa ko. From Andhra Pradesh, 2 calls came. AP called to ask Papa ko. All fikr. Everyone was in tension. A call came from AP. Boy will go. Why? Jans, months, cause, knees. Then what was the cause? If Jans, months, cause, knees, then what was the cause? The cause was caring students bounty at that time. Clear, bhai? Mg2 plus, final. So this is group number 1, group number 2, group number 3, group 4, group 5, group 6. Group 2 and group 4, both are sulfide PPTs. Sulfide, both. And this sulfide will be lesser soluble. Both are almost insoluble because both are PPT. But who is more insoluble is group 4 sulfides. Now, AP call 2. AP call 2. These are the PPT. Ask Papa ko, arsenic sulfide, PBS, CUS. Ask Papa ko. All fikr, aluminum hydroxide, Phi, Kar. Then Jans, months, Janaman, Jans, months, cause, knees, caring, student, bounty, carbonate, carbonate, carbonate. And magnesium ion, no PPT. So these are the precipitate formed. Clear, bhai? All of them are precipitate. This is white color PPT. This is brown color PPT. MNS, mamsam, MNS, mamsam, mansan color, flesh color. Clear, bhai? These all are white color PPT and here no PPT. Group reagent. Group reagent. So number 1, for this the group reagent is dilute HCl. Then dilute HCl plus H2S. HCl already there. If no PPT will come with dilute HCl, then I put H2S also there. Common ion effect will happen. Conceptual part you might have done in the main track. Next, after that, take the fresh solution again. After that, what, sir? After that, you will take hydroxide. So ammonium hydroxide in the presence of ammonium chloride. So OH minus will precipitate. After that, in the presence of ammonium hydroxide, you will take H2S. So more sulfide will come, they will precipitate. If still PPT not came, again take the fresh. Every line I am making now means you will throw this solution and take a fresh one. Again fresh solution taken, then you will take ammonium carbonate. It will precipitate, okay. If not precipitate, over. It is magnesium ion. So that's the group test of cations. So they can ask you which cation belong to which group, match the column. Which group reagent is used for which group, match the column. Came in the last year NEET exam also. Check bhai. Lead belongs to group 2 also, group 4, group 1 also, group 2 also. Lead. Done. Now, a few conceptual tests you can remember, which are easy to score and easy to remember also. देखो, Zn2 plus Al3 plus, that is ZnS from group number 4, and aluminium hydroxide from group number 3. 3? Clear, bhai? AP call to us, Papa ku. All figure. Then Johnson's Cosmos. For both of them, they are precipitate first. So first you have to dissolve them. To dissolve, I am using dilute HCl. They will dissolve zinc chloride form. Here also I can use dilute HCl. Aluminum chloride form dissolved. So now I have free zinc ion, free aluminum ion. They both are going to become amphoteric oxides. Zinc, aluminum, both are amphoteric. So I'm going to use this to my advantage. I will take NaOH here, which is a base. Forms zinc hydroxide, which is a white color PPT. Forms aluminum hydroxide, which is a white color PPT. So previously also it was aluminum hydroxide only. Then we dissolve it back for further testing, adding NaOH. I again got white PPT. But now if I add NaOH in excess, it forms Na2ZnO2. That means white color PPT dissolves. It forms NaAlO2 with excess of NaOH because white PPT dissolves. So if you get a white color PPT with NaOH, which further dissolves with excess of NaOH, either zinc or aluminum will be there. So, but how can I differentiate whether it is zinc or aluminum by this test? You can't. That's why for aluminum there is another test called as lake test. So remember, lake test is for aluminum and blue color lake will form. And for zinc there is another test I will talk about in the next slide. But firstly, is the conceptual part clear? They both are amphoteric, and because they both are amphoteric, even though they are metal hydroxides are supposed to be base. Metals are basic, but these nalaic metal are amphoteric. So they react with the base also, they start acting like an acid with NaOH. So this I am using for my advantage. Say bhai, conceptually clear. This part I am teaching for those people whose brain is good, but education was not good. In case anyone is like seeing like that, so not studied well, but now they want to learn. Make sure there are some tests of cations which are very important and very conceptual. You can remember them without mugging also. Can I move on to the next? Obviously I will. Next is K4FeCN6 test. If this react with copper 2 plus, so Cu2 plus chocolate brown. Chocolate. Cu, copper, chocolate. So what to do? Replace this K plus with copper. So 4K plus will go, 2 copper will come to balance the charge. So it's a chocolate color PPT, chocolate brown. Okay, bhai. Zn2 plus, I said now one test is lake test, one test is this test. With K4FeCN6, you will get bluish white PPT. Bluish white. Zn2 plus himself is white color here, D10. So bluish white came, more than enough. More than that color don't expect from him. Fe3 plus. Fe3 plus ion will form Fe3 plus FeCN whole 6 4 minus crisscross. Ikada charge, akada number, akada charge, ikada number. It's the Persian blue PPT. But if you take excess of K4FeCN6 na bhai, to understand this will become potassium salt. And potassium salts you might have seen, almost all the potassium salts are highly soluble. So if I take excess of this, so ये crisscross not required. Total how many K plus? 4 ka wali na 4. So with FeCN whole 6, if I need 4K plus, Fe is plus 3. Fe is plus 3. So 1K will be enough. But now became a potassium salt. So this will be a Persian blue color colloid. It will not be a precipitate. So K4 FeCN6 test is clear, bhai. So this 3 cation test also done. With nickel you have done, firstly one thing, one important thing. NiS and COS, they are soluble in aqua regia only. They are not soluble in HCl, HNO3, water, hot water, nah. Only aqua regia they are soluble. So once they are soluble, let's say nickel I am talking about NiCl2 became, then I react with dimethyl glyoxime. It becomes NiDMg whole twice. And you might have mugged it up, it's a red color, brilliant red color PPT. So it's a test of nickel sulfide. So what about cobalt? Cobalt as per NCERT, as per NTA is not in the NEET syllabus. So that's why a little bit we can learn about it, but not in detail. Clear, bhai? Done? Flame test. For flame test color, beryllium, magnesium, no flame test. Calcium, strontium, barium. Firstly, I will convert them into their chloride. Why? Because their chlorides are volatile. They will easily become vapor. And burning gas is flame. Flame is burning gas. So that's why volatile compound required. Now, how to get the color? Simple. Calcium, strontium, barium. Barium is apple green. Unripened apple. Then after some time apple become ripened. So bright red, crimson red. Flame color. Clear, bhai? And when it become over ripened, so maroon color, yeah, reddish brown, so brick red color will come. So these are the flame color, and the flame color are observed in non-luminous flame. So whenever the flame is burning, the outer part is called non-luminous flame. Inner part is called luminous. So luminous flame has the color. Luminous means color is already there, shiny. So it will interfere with the color. Na yaar. Non-luminous is dull, no color of its own as such. So whatever the flame color will come, it will come in the outer portion. Inner portion, for example, candle you are lighting. So if you see a candle flame, you will see outer surface, you will see some gas is there, but you can't see, it's transparent. Inside yellow. Ab yaar, yellow color, flame color is yellow itself. So do you understand that red and yellow new color will form? So they will interfere with the color. That's why we use non-luminous side of the flame to see the color. So color will come inside also, but we ignore that. We see the outer color of the flame. Say bhaiya, flame test this much clear. Only conceptual part, easy to remember part I am touching right now. Are you comfortable by this time, bhai? Twarga say. Done. So little bit about all of them you have learnt now. Except lead. Lead I did not say. For lead, one small thing I will say. PbCl2, PbI2. Main hit point I am telling you. According to Fajan's rule, larger anion will be more covalent. And more covalent will be less soluble. So PbCl2 is soluble in hot water, but PbI2 will be soluble in boiling water. Because it's more covalent in nature, it is less soluble in the water. It's a white color PPT otherwise. It's a white PPT in the cold water. and that's a yellow PPT in the cold and hot water. But in the boiling water, PbI2 becomes soluble. That's about lead. PbSO4 white, PbCrO4 chromates are yellow, but PbSO4 white. These are the PPT. So you are adding a sulfate, became white color PPT, so maybe lead is there. Chromate added yellow color PPT, so lead is there. Say bhai, are the main test of all the cations tests are completed bhai? It might appear like it is very little only told, but when you will turn the pages and revise, you will realize ki yeah, 99% over, and that 1%. Clear bhai? If you are learning for the first time, it's better to ignore. If you have learned this before in the main track, then do everything bhai. Our students should do everything. Someone joined late, revision only you joined, short-term classes you attended, clear bhai? Or just seeing SE normally, just came by mistake. In all those cases, bare minimum this much you can do, and this is bare minimum. This is not very high-fi thing, this is bare minimum. Chaliye, shall we move on? This was the salt analysis. Now, moving to biomolecules. Acha, which apparatus is used to prepare H2S? Gibbs apparatus, remember that, Gibbs. All these questions have come in our test several times, but anyway, moving on. Talk about biomolecules. Number one, reactions. So with HI, glucose will form N-hexane. I'm just skipping the easy part, coming to the main part. With NH2OH, oxime, HCN, cyanohydrin, test of aldehyde yesterday you have done. With bromine water, oxidation will happen of the aldehyde group. You will get COOH group over there in the place of aldehyde, gluconic acid. With HNO3, even more oxidation will happen with HNO3, better oxidizing agent. So aldehyde will also get oxidized, primary alcohol will also get oxidized. The two side COOH will come. Saccharic acid. Acidic anhydride, acid derivative and alcohol will form ester, esterification will happen, you will get pentacetate of glucose. All those things are okay, no problem. Now, third point is very important here. Obviously, there are some reactions which are not shown by glucose, even though aldehyde group is there or ketone group is there in ketose. Reason is aldehyde and ketone groups are associated in the glycosidic linkage because of cyclic structure. Those reactions are 1 and 2. Third one is very important. Glucose is found to exist in two crystalline form, alpha and beta, 2 glucose. Melting point of alpha glucose is more. So melting point of alpha glucose is less and beta glucose melting point is more. Understood the idea bhaiya? So beta glucose little, 423 Kelvin. Alpha glucose 419 Kelvin is the melting point. Hello. So alpha glucose, what is alpha and beta glucose? If you remember, anomeric carbon, the carbon which had aldehyde or ketone group, that carbon is called anomeric carbon. In simple words, for glucose, first carbon after O, first carbon, that is C1, glucose, that is anomeric carbon. For fructose is a ketose. After O, the first carbon is called C2, second carbon. Clear, right? So C2 of fructose and C1 of glucose are anomeric carbon. There, if the OH will be having L or OH is on the left or right, up or down, based upon that you will have two different isomers called as anomers. So alpha and beta, glucose, fructose, alpha glucose, beta glucose, alpha fructose, beta fructose are anomers. Glucose and fructose, they are functional isomers here. Glucose is a aldehyde, aldose. Ketone is a fructose. Fructose is a ketose. Done bhaiya. How to remember the structure? Dekho, the trick which we use is for glucose also, fructose also, both are 3L. Clear bhai? L is up, D is down. Done bhai? So for glucose, it's a 6-membered ring like this. Carbon number 1, 2, 3, 4, 5. This is anomeric carbon. 6th one will be on the top. 3 is L. L you can take up. If L is up, it's not a rule that L should be up only, but generally we take L as up. If L is up, remaining carbon number 2 and 4, OH will be down. Simple. 3L. Remaining 2 and 4 will be down. So what about first one? First one depend upon you. You want alpha or beta? Sir, I want alpha. Chalo, if you want alpha, then OH must be down. You get alpha glucose. Clear, bhai? And if you take the same exact structure, and in the place of OH here, if you take OH up, then the same thing is called beta glucose. Done by alpha glucose, beta glucose. Same thing you can see for fructose now. You will understand the structure very easily by seeing the NCERT. So for fructose, the anomeric carbon is the second carbon. The counting starts from second carbon here. Second carbon OH down, alpha. Second carbon OH up, beta. These are called anomers. 3L. So third, second here, so third here. Third carbon L, OH. Fourth down as usual. Sixth will be always up. Sixth will be always up. So sixth is the reference. If sixth is up, so third carbon will be up. For glucose also, fructose also. OH group will be up. And for carbon of glucose depend upon alpha beta. Alpha writing or beta writing. For remaining carbon 3L, third carbon OH is up if the sixth carbon is up. Then talking about disaccharides and polysaccharides, sucrose. Achha, all the monosaccharides and disaccharides except sucrose. All the monosaccharides and disaccharides except sucrose are reducing sugar. That means they will react with Tollin's reagent, Fehling solution and Benedict solution. With tartrate, citrate, both type of copper 2+ ion, they will form a red color complex. Benedict solution, Fehling solution. Clear, right? With both of them, they will form orange red PPT, orange red OR. Tollin's reagent, silver mirror test. So silver mirror will come. Now, sucrose is a non-reducing sugar. Why? His anomeric carbons are not free. It is a dimer of alpha D glucose, beta D fructose, C1C2 linkage. So C1 of glucose was the anomeric carbon and C2 of fructose was the anomeric carbon. Both anomeric carbons are busy. Anomeric carbon are hero carbon. They are aldehyde and ketone group carbon. If they both are busy, so the test of aldehyde and ketone cannot be shown. So sucrose is a non-reducing sugar. But if you see the remaining examples of disaccharide like maltose, in maltose it is alpha D glucose, alpha D glucose. Maltose, amylose, same. Difference is maltose dimer, amylose polymer. Otherwise, both are alpha D glucose, C1, C4 linkage. Everyone C1, C4. Whole syllabus for you, disaccharide, polysaccharide, everyone is C1, C4. So alpha D glucose, C1, C4 linkage, this C1 is free. So that's why anomeric carbon free is a reducing sugar. Anomeric carbon must be free for some sugar to be a reducing sugar. For lactose, alpha, beta D glucose, beta D galactose. So remember beta D galactose and glucose, C1, C4 linkage. So this is beta link because beta beta. Alpha link, alpha alpha. Here also C1 carbon of glucose free. You can write here C1 of beta D glucose is free. So lactose is a reducing sugar. Amylose, one of the component of starch. Clear, bhai? Just like maltose, but just polymeric structure. Amylopectin, branching is there. So C1, C4 linkage there, but C1, C6 branching also there. But everyone alpha, 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 alpha. Clear, bhai? See, it is not looking like a C1, C4 linkage, it looks like a branch, but it is also a linear polymer. Just the line is not straight, line is inclined. But this is also C1, C4 linkage. Clear, bhai? Cellulose. This is also C1, C4 linkage, but beta D glucose. तो बीटा डी ग्लूकोज तो C1C4 बीटा लिंक, तो अल्फा अल्फा, इफ द मोनोमर्स आर बोथ अल्फा तो अल्फा लिंकेज, बोथ आर बीटा तो बीटा लिंकेज, वन अल्फा वन बीटा तो अल्फा बीटा लिंकेज, बट अल्फा बीटा नॉट इन योर सिलेबस, कांग्रेचुलेशंस. Glycogen same like amylopectin but more branching. Talking about amino acids, bhai, you have to remember the side chains of amino acid. So firstly remember who are acidic amino acid, basic amino acid and all those things. So how to remember? देखो भाई, acidic amino acids are DE, aspartic acid, glutamic acid. This is aspartic acid, this is glutamic acid. D and E, single letter codes. Acidic amino acids. Basic HAL, histidine, you can check also. Wherever extra NH2 group is there, they are basic amino acids. Extra NH2 group. See, histidine. In the side chains, there are so many N groups here. Amino acid have amino acid both groups anyway. Extra will be in the side chain. Clear, bhai? So here also nitrogen there. But his lone pair is involved in the conjugation. So not free. This lone pair, this one in conjugation, but this lone pair is free. Because remember, the same element has double bond also, lone pair also, then lone pair is not involved in the conjugation. So he's localized. So histidine is a base. Sorry, basic amino acid. Clear, bhai? Then, see, lysine, arginine. These are basic amino acids. So acidic basic amino acids are clear, bhai? Then, these are basic amino acids. CM sir, CM Saurabh. Someday in my life, cysteine and methionine, they are sulfur group amino acids. Then, Telangana state, if you remember before this election, Telangana states, alcohol was cheaper as compared to AP. You might have heard. This was another part of manifesto also. So Telangana state, alcohol group. TS, serine and threonine. Serine and threonine. These two amino acids, alcohol are there. Done, bhaiya. So these amino acids, at least you can remember. These are the bare minimum you can remember, bhai. Essential amino acids you will remember because you have done in botany, or you will do in botany also in detail. So I'm not wasting my time over there. Already we are short of time. Clear? You can write one thing. Xanthoprotein. Together I will tell you. All together I will tell. Protein structure. Amino acid sequence is primary structure. It can be alpha helical or beta pleated. That is secondary structure. So primary is a chain. Secondary is alpha helical or maybe beta pleated sheet. That is secondary structure. Then if you take alpha helical and make it guj, is tertiary structure. If you take beta pleated, make it guj, tertiary structure. If you take one guj, another guj, combine together, quaternary structure. So primary structure, amino acid sequence. Secondary structure can be alpha helical or beta pleated. Tertiary structure, when this alpha helical become guj. Are you getting? Guj getting na? Ye guj. For example, it was alpha helical. This alpha helical become guj. This is tertiary structure. Ye secondary, tertiary. This was beta pleated. Secondary. His tertiary structure will be guj. Tertiary. When one guj, two guj, three guj, four guj, more than one guj come together. Quaternary, like hemoglobin. Hemoglobin have two alpha, two beta moiety. You might have mugged up. In the middle, Fe2 plus is there. Iron is there in the middle. Heme group. In biology, it's very common. Alpha 2, beta 2 are there. That is quaternary structure. So in the denaturation, quaternary, tertiary, secondary structures will open up. Primary will not be affected during the denaturation. Then by vitamins, make sure that you remember all the vitamins, their sources and their deficiency. Diseases, what will be caused. People generally remember only scurvy, rickets. More than that you have to do, bhai. I'm coming to the main point. In ribose, there it's a 5 carbon, it's a pentose sugar, 5 carbon. So in deoxyribose, which carbon deoxidize or which carbon deoxy it becomes? So second carbon from OH becomes H. This is deoxy. So which carbon is deoxy for deoxyribonucleic acid? Second carbon of the pentose sugar. Now, how to remember the structures of purines and pyrimidine bases? Done by. So number one, whenever you study, you should study as pure as Gosalites. And bhai, you are the purest people in the world. Clear bhaiya? So pure as Gosalites. So purine are A and G. Pure as Gosalites. Purine A, G. So purine A, adenine, and G, guanine. These are purine bases. They both have 2 rings. Clear bhai? 2 rings are there. Remember now how to remember the structure. Dekhe, when we talk about pure as Gosalites, both have 2 rings. In the exam option will come which of the following is adenine, which is the guanine, cytosine, thymine, uracil. Single ring, cut. Single ring, cut. Not cut. Means cysteine, uracil, thymine. Cut. Single ring. Then by double ring can be A or G. Out of that, if you have Gosalite, G, Gosalite, this O will be there. So guanine contain O. Adenine will not contain O. Check. So Gosalites, Go. Viliginda, Marathon Gold, Go Care, Go. Gosalites, Go. O will be there, extra O with guanine. Next, in guanine, can you see this U is also there in the spelling? So remember, kya U-like formation will form in the structure in guanine. Sir, but U is there in uracil also. Bilkul, U is there in uracil as well. There also U will form. In the functional group, U structure will form. Clear hai bhai? Hello. So firstly, adenine, guanine, clear how to differentiate and how they are similar. Adenine, guanine, both are double ring. Guanine, Gosalite, O will be there extra on the top, easy to identify. Then, for cut, pyrimidine, 1 ring, cut. Dekho, cytosine, O. Clear bhai? O is there in the name, so O. You can put 1 arrow on the O and highlight O. CO. Done by. Sir, for thymine also, so O there. But thymine, the word thigh comes from methyl. Thymine. Methylamine. Thigh. So methyl. Clear hai bhai? So methyl group only there in thymine. There is no other group. Uracil, there is a U like C double bond O. Say bhai, can you remember the structures now? Nucleoside, nucleotide. So when you have nucleoside, so phosphate go on the side. When nucleotide, so phosphate will come. So understand, this is like, you have seen the ad of Tide, na? Same. So when Tide will come, this is Tide. So extra phosphate will come like this. So nucleotide. Nucleoside, side is empty. No phosphate group is there. So nitrogenous base and pentose sugar. Base and sugar, nucleoside. Sugar, nucleoside. Base, sugar and phosphate, tide. Done bhai. Hormones, make sure that you read very properly bhai. Very, very properly. Now very important point. The main forces that stabilize secondary and tertiary structure of proteins are number 1, hydrogen bond. If you have to choose only one answer, then choose hydrogen bond. Secondary structures are stabilized by hydrogen bond. Secondary and tertiary are stabilized by hydrogen bond, disulfide linkage, van der Waals attraction, electrostatic forces of attraction. Clear hai bhai? So very important point, bhai. Very important point. Done. Now, for most of you, things are done, but for some top level student who want to go into AIMS Delhi and not, sorry, I rephrase, who have scored 660, 670 on a consistent basis except a 1 or 2 tests. We have around 7 to 8 like candidates in long term who are consistently scoring that level, so they have a chance to go to AIMS Delhi if the paper comes according to you. For you people, very small thing is there. Remaining people, chill, relax, over, marathon over, tata, bye bye, yeah. I mean the, for remaining people, remaining means 6, 7 only. Maybe you are attending the class right now or not, but I'm assuming that someone would come and inform you this thing or someone would note it down. You might have done everything because main track you have done, revision you have done, that's why the score is coming like that. So you are in a comfortable position for biomolecule to do little bit extra testing also here. And when I say extra testing, it means the practical part of biomolecule. Very small things. I was telling you that orally, but then I stopped in the middle. Then I said, okay, together I will say. Why silver mirror test, all those things. So number 1, Molish test. Molish. Same as Gris-Illosway test. Now this part of the lecture, the next 5 minutes are only and only for those people who have been the most sincere throughout the year in our campus by this time. Clear, bhai? So I'm not going to separately take the class for that, and obviously whole crowd cannot attend together. So a small 5-minute chunk is there. See, just like Gris-Illosway has one naphthol there also, one naphthylamine. Here one naphthol, Molish, with sulfuric acid, Molish test. Just like brown ring test, na, between the 2 layer brown ring comes. Here also between the 2 layer violet will come. So Molish test is shown by all carbohydrate. Write it down, violet color, all carbohydrates. Reducing sugar will show Fehling solution test, Benedict test. Both will have OR. OR means orange red PPT, Cu2OR. You have done that in test of functional group in the main track. Same. Tollens reagent, silver. But this is the easier part. This is important because this you might not have done in the track 2 because not there in the test of functional group. Barfoed test. This is the difference between monosaccharide, disaccharide. You can differentiate. Just like Lucas test will show immediate turbidity with tertiary. In the same way, for Barfoed test, monosaccharide immediate, disaccharide little late. Think like this: when mono, single person go to bar, and disaccharide, 2 people go to bar. Single person is sad, alone, lonely. Immediately bar effect will be coming. Orange, red PPT. Disaccharide little late because 2 are there. Gossiping will also happen. Done bhai. Sullivanov test, same as Lucas only. But here difference between ketose and aldose. Fructose and glucose you can differentiate by this. Ketose Tvarga reaction. Reason is also there, but we don't have to go that much beyond the syllabus part because practical questions are there. JEE Main is asking here and there by mistake because they have to make several papers, so they go beyond the syllabus also sometimes. In NEET that they will not go, but why to take the risk? Clear, bhai? So furfural formed for ketose, furfural is easily formed. For aldose it is tough. That with that much depth you don't have to go. Just remember this much: ki Sullivanov test for ketose, Tvarga. Aldose, slow. So fructose will show fast this test and aldose will show slow, but all the ketose, aldose can show that. Now coming to proteins. 3 tests are there: burette, ninhydrin, xanthoprotein. I was about to say xanthoprotein at that time. It is only shown by aromatic amino acids. If aromatic amino acid is there, then xanthoprotein test it will show. And burette and ninhydrin test will be shown by proteins and polypeptides. So peptide bond is there. How to test polypeptide? How to test the peptide bond? Burette test. Color violet. Ninhydrin test of protein, color purple. Clear, bhai? These things you can write over. That's all. I think that's all only. Yeah. Clear, bhai? So there's a main thing. If you remember this much and little outside the syllabus, they will ask you, which JEE main asked 2 years back, when the syllabus got changed that year. Last year only, I think. Clear, bhai? They asked one question only. By this time, 16 papers happened. Out of that, only one question came from here. But why to take that risk also? Little bit extra effort we can put. Done, bhai. Now your job starts that you will complete all the NCERT solved example, all. In text question, all. And some of you will also do NCERT exercise question, which I gave as the homework. Work really very well. The festival of chemistry energy should not go down here. Chala energy. Only chemistry. Physics, botany, zoology, or wish. Chemistry full on. All India rank 1, all India rank 2. Chemistry at least should come from here. Clear hai yaar? It will come for physics and botany, zoology also, obviously. But for chemistry, today, only chemistry. Tomorrow, only chemistry. Day after tomorrow, forget about chemistry. Only botany. Clear, bye? Okay then, tata, bye bye, bye bye, bye bye, bye bye, bye bye, bye bye. Chill, enjoy. If any part of the lecture you have missed, you can contact to your vice principal or principal, anyone. Clear, bhai? They can show you that on the YouTube, but make sure work really very hard and happily. Clear, bhai? Chalo, enjoy. Happy Marathon Gold.